Right from the start, software development comprised two different departments. The development team that develops the plan, designs, and builds the system from scratch, and the operation team for testing and implementation of whatever is developed. The operations team gave the development team feedback on any bugs that needed fixing and any rework required. Invariably, the development team would be idle awaiting feedback from the operations team. This undoubtedly extended timelines and delayed the entire software development cycle. There would be instances where the development team moves on to the next project, while the operations team continues to provide feedback for the previous code. This meant weeks or even months for the project to be closed and final code to be developed. Now, what if the two departments came together and worked in collaboration with each other? What if the wall of confusion was broken? And this is called the DevOps approach. The DevOps symbol resembles an infinity sign, suggesting that it is a continuous process of improving efficiency and constant activity. The DevOps approach makes companies adapt faster to updates and development changes. The teams can now deliver quickly, and the deployments are more consistent and smooth. Though there may be communication challenges, DevOps manages a streamlined flow between the teams and makes the software development process successful. The DevOps culture is implemented in several phases with the help of several tools. Let's have a look at these phases. The first phase is the planning phase, where the development team puts down a plan, keeping in mind the application objectives that are to be delivered to the customer. Once the plan is made, the coding begins. The development team works on the same code, and different versions of the code are stored into a repository with the help of tools like Git and Merge when required. This process is called version control. The code is then made executable with tools like Maven and Gradle in the build stage. After the code is successfully built, it is then tested for any bugs or errors. The most popular tool for automation testing is Selenium. Once the code has passed several manual and automated tests, we can say that it is ready for deployment and is sent to the operations team. The operations team now deploys the code to the working environment. The most prominent tools used to automate these phases are Ansible, Docker, and Kubernetes. After the deployment, the product is continuously monitored, and Nagios is one of the top tools used to automate this phase. The feedback received after this phase is sent back to the planning phase, and this is what forms the core of the DevOps lifecycle, that is, the integration phase. Jenkins is the tool that sends the code for building and testing. If the code passes the test, it is sent for deployment, and this is referred to as continuous integration. There are many tech giants and organizations that have opted for the DevOps approach. For example, Amazon, Netflix, Walmart, Facebook, and Adobe. Netflix introduced its online streaming service in 2007. In 2014, it was estimated that a downtime for about an hour would cost Netflix $200,000. However, now Netflix can cope with such issues. They opted for DevOps in the most fantastic way. Netflix developed a tool called the Simian Army that continuously created bugs in the environment without affecting the users. This chaos motivated the developers to build a system that does not fall apart when any such thing happens. So, on this note, here is a quiz for you. Match the DevOps tool with the phase it is used in. A. B. C. D. None of the above. Today, more and more companies lean towards automation, with the aim of reducing its delivery time and the gap between its development and operations teams. To attain all of these, there's just one gateway: DevOps. And if you are also looking forward to doing the same and excel in DevOps, check out Simplilearn's postgraduate program in DevOps, designed in collaboration with Caltech's CTME. The program can help you master several in-demand DevOps skills and tools, like continuous integration and delivery, DevOps on cloud, Kubernetes, Docker, and much more.
Hey everyone, have you ever thought what would have helped Netflix to evolve from shipping DVDs to streaming videos over the web? Or what would have helped Amazon to predict how much equipment to buy to meet traffic demands? How do you think NASA was able to analyze data from Mars rover's Curiosity? What would have made it possible for Walmart to become the king of big box retailers? Or What would have helped Facebook to refresh its mobile app so rapidly? The answer to all these questions is DevOps. The DevOps market generated $3.36 billion in 2017, and it is expected to generate $9.40 billion by 2023. DevOps is helping many organizations to automate their entire process. The process allows any organization to create and improve their products at a faster pace than traditional models. So now, let's see what is DevOps. DevOps, as the name suggests, is a combination of two practices. Dev refers to development and Ops refers to operations. DevOps is not a workflow, but a culture that brings these two teams together. The development team writes codes for new products, security updates, and bug fixes, while the operation team looks after the servers and makes sure that the deployments happen more reliably and frequently. The main focus of DevOps is towards integrating these two teams to improve collaboration and increase productivity by automating the entire process of software development. DevOps has several stages and tools to ensure that all the process is implemented in the best possible manner. Let us look at all these stages with the tools that play a very significant role in that phase. Beginning with the development phase, the first step is to put down a plan that includes modules and the algorithms to be used in the software. Once the plan is finalized, it is developed with tools like Git, as Git helps to store all the codes and different versions of those codes. This is called the version control system. This code is now fetched and made executable in the next stage, and that is called the build phase. The phase uses tools like Gradle and Maven. After the code is made executable, it is supposed to be tested. The next stage tests the code for any bugs, and the most famous tool used in this phase is Selenium. Once the testing is done, deployment comes into consideration. This is where the work of the operations team begins. In the deployment phase, the product is deployed, and this deployed product is continuously configured to the desired state. The tools that could be used to automate these phases are Ansible, Puppet, and Docker. The product from here is continuously monitored for any failures, and the most common tool that makes it possible is Negios. The feedback of all the monitoring is sent back to the planning phase. This process is repeated in continuous cycles, and this happens until a satisfactory result is reached. This completes the entire DevOps cycle. That is the process of automation from the planning phase to the monitoring phase. This is what is referred to as the core of DevOps lifecycle, the integration phase. Jenkins, another DevOps tool, is known for sending the code for build and test. And if this code passes the test, it is further deployed and monitored. Let's have a look at some features that are making industries move towards DevOps. Increasing customer satisfaction, improved response time, fewer chances of implementation failure, reduction in IT cost, better business agility, high employee productivity and satisfaction, faster delivery, better release control, frequent software releases, better collaboration among teams, automated server configuration. Now, when you know so much about DevOps, you must be curious about what would the future of DevOps hold. It is quite evident that DevOps is on the rise and it is going to have a long way ahead. There are several fields that DevOps is going to be explored in the near future. Every organization has started leaning towards automation, so DevOps will play a significant role in new upcoming organizations. When everything moves towards automation, there will be a need for DevOps in the security field. DevOps framework in AI and ML will help the DevOps team to focus on innovation and creativity by enabling them to manage the amount and speed of data more efficiently. DevOps focuses on infrastructure as code, which ensures continuity as all the processes from building to staging are configured automatically with no place for human error. The future of DevOps will make the culture more accessible. There is no industry that would not want to shift towards more reliability in deployment. Every organization wishes to deliver its product in shorter durations and reduce the gap between its development team and the operations team. All these scenarios are going to take DevOps to the new height very soon. Some organizations have already shifted towards DevOps and many are planning to do the same. Hence, the jobs for DevOps engineers are certainly going to rise in the market in the near future. So, when are you planning to master DevOps? You can begin today with Simplilearn's DevOps Certification Training course.
My name's Antoine Victor, and I'll be your instructor for this DevOps training. In this training, we're going to look at what is DevOps, the DevOps lifecycle, DevOps tools, talk a little bit about version control, and then we'll get into CI and CD, that's continuous integration and continuous delivery, and then we'll follow on with configuration management, containerization, and finally finishing up there with monitoring. So let's go ahead and dive right in with a definition of DevOps. So what is DevOps really? Well, DevOps largely is a cultural shift. It's an organization-wide cultural shift towards delivering business value to the end customer. Now, this means that development and operations both have to work together. Now, because DevOps is a clipped compound, which includes only development and operations, it might seem like DevOps is just for developers and operations staff. But the reality is, if we were to include everything that DevOps really contained, DevOps containing development and operations, obviously, but also quality assessment, security, configuration management, infrastructure management, network management, and so on and so on and so on. The name wouldn't sound cool. It wouldn't be a good marketing term anymore. So let's assume for now that DevOps includes not just development and operations, but everything on the software delivery pipeline from idea to business value, making it into the customer's hands. So developers continuously want to develop and test code. So they're building new features. They're rewarded for delivering new features to the end customer. On the other hand, the operations team is in charge of keeping the network and the production software in a running state. So for them, less changes are better. So you can see we've got kind of opposing missions here between development and operations. Development wants to deliver new features, but the operation of delivering new features tends to cause downtime, which the operations team are rewarded for maintaining the opposite of that, which is uptime. So in order to get these guys working together, the development team and the operations team working together to enable continuous deployment, we have to automate a lot of these historically manual processes. So what we're really talking about here is the DevOps lifecycle, or the software delivery lifecycle, where we plan, and again, because we're talking about the entire team working together here, we're planning, but not planning everything. We plan just enough to get the next iteration done. And then we code, but just enough to complete the features that we plan to deliver in the coming release. And then we compile or build that solution. And once we get a successful build of that solution, then we go on and test that solution. And only on successful completion of all of those tests do we move on to the next phase, where we integrate the code that one team member has just submitted, got a successful build on, and then a successful test run. Then we take that code and we integrate it with all the code that was written by the other developers on the team. And then we test it again. And once we are successful with that integrated build and that integrated test run, then we can move on to configuring the environment that we're going to deploy this successfully compiled and tested solution to. That's where configuration management comes into play. It's best to avoid configuration drift and incorrect configurations by automating this process of configuring those servers that we're going to deploy our solution to. So with configuration management and automated configuration, our goal is to automate this process so we can be more consistent and reliable. And once we've configured the system that we're going to deploy to, then we want to use automated deployment to deploy to those systems that have been configured in a consistent way. We want to now deploy to them in a consistent and reliable way. And finally, once those solutions are deployed successfully into our stable, consistently configured environment, we want to monitor the ongoing use of those solutions to make sure that users are getting the features and the performance that they expect from the solution that we've delivered. So let's start at the beginning. Let's say we want to build a website for a company. We might have a customer that comes to us and says, hey, I want to build a new website for my organization. And we might respond, you can use DevOps tools and techniques to build your website and streamline your delivery process. Hey, that sounds like a great idea. Let's do it. So let me hire some developers, testers, and operations guys who can develop and test and maintain the website. And then after gathering all the requirements, the developers can start building the code for the website and store each version of that code in a source code repository. Now, for now, we'll call it GitHub. We'll say we're using GitHub. So we've got a couple of developers, and then we've got our GitHub repository to store all of our solution artifacts. So at this point, we've done a little bit of the planning. We've collected some requirements for our customer. We've started on the coding. We've stored some of the code in our local Git repository. Or maybe we're using the Microsoft stack, and we might be using the tool formerly known as Team Foundation Services. It's now called Azure DevOps. But as far as source control, it uses the same foundations as Git. So we get our code into version control. So we might have multiple files that the developers have created. Developers are working on file 1, file 2, file 3, and they check those files into the GitHub repository as version 1. Another team of developers might be working on different features that might impact those same files. So they're working on file 3, but have made a couple versions of it, a couple of iterations to it. So they're on file 3.3, while team 1 is only on file 3. As we merge those different branches of changes together, we create version 2 of the solution. But if anything goes wrong anywhere along the way, we have kept those branches of changes separate, so one will not affect the other. This is the benefit of version control and source control tools like Git and GitHub. So the basic architecture of Git here, we have a working directory. We've got a local staging area where we prepare changes that we've made to be committed to the local repository. And then to share those changes with other developers on the team, we can push the changes out to a remote repository. To receive changes that other developers have made or other team members have made, we can pull those changes down from the remote repository. So back to our website project here. Now the developers have built the code using whatever tools they chose to use, whether they be .NET, Eclipse, or some other editing tool. We can then take that code and make sure that that code is valid by compiling it, packaging it, and then having the code verified by our quality assurance team. Now, in order for other team members to access this code, it's best if it's moved to that central repository, the GitHub that we were talking about earlier. So our developers write their code, they compile it, make sure it runs, and the tests all pass locally, and they can push that out to our central repository in GitHub. Now, we've talked about planning, and we've talked about testing, and we've talked about the compiling in the source code repository, but we didn't really talk about how that compiling is being done. So one of the ways that we might build Java code is by using a tool called Maven. Now, Maven is what we can use to define how our build is going to be done and automate our build process. So once we have that planning and building phase done, our solution has been tested and stored in version control, we might want to run some additional tests. For that, we need the testers. The testers are going to test the code that we built to make sure there are no errors that perhaps weren't caught by our automated testing that was part of the development process. So the testers are going to perform functional tests. They may rerun some of the unit tests created by the developers, system tests, and the user acceptance tests to fully vet the solution to make sure that it's ready for prime time. So again, at this point, we've done a little bit of planning, we've done some coding, we've done some building of that code, and some automated unit testing of that code, and now we've passed it off to the QA team so they can do more exhaustive testing of that solution. Now, some of the additional tests that the QA team might run would be UI automation tests, exploratory tests, smoke tests to find issues that may not have been exposed by the low-level testing, unit testing that developers may have done during the development process using test-driven development. Once the QA team is finished doing that additional testing, making sure that we didn't miss anything with our automated testing process, then the operations team will need to integrate those changes along with anything that's already out there in production, maybe a previous version of the solution, existing data from an old database, or what have you. We can use continuous integration to make sure that all that code, all those changes that are being made by different team members, is compiled and tested and deployed together on the production servers in a consistent way. So again, we've gone from planning to developing, or coding rather, and building that code and testing that code, to integrating those changes with changes that the other developers on the team have made, and finally running additional tests, and after all of our tests are passed, pushing that solution out to production servers or production-like servers as we prepare for additional tests like load and stress tests. Now this automation process of moving these resources out into the QA environment and on into the pre-production staging environments and finally off into production, there are several tools that we can use to automate this process. Some of the more common tools listed here on the slide: Jenkins, Bamboo, and Travis CI, that's continuous integration, and of course Azure DevOps, not here on the slide. So a common example of using CI and CD in Jenkins is, again, we have our developers doing their work, hopefully writing their tests first, so that when they complete their work, they can commit their work to our source code repository, and that act of committing the work to the source code repository can cause a tool like Jenkins to automatically fire off a continuous integration trigger to build that solution, test that solution, and if it passes, potentially deploy that solution off to the next environment. But if it fails, we can reject that check-in to the repository and send notification back to the developer or other team member that introduced that defect, allowing them to fix that defect before it causes any problems for other team members. Now, of course, if that build and that test run passes, then Jenkins can automatically move that change, that version of the solution, onto the next environment. Now, that next environment in this case is the QA environment, where now the testers have access to that solution. And the testers can perform more exhaustive exploratory testing, user acceptance testing, and so forth. If they then find any errors, then they can push that feedback back down to the development team, who can then fix those issues and then resubmit that code through the continuous integration pipeline. Now, if the testers don't find any defects, then they would promote or approve that solution for promotion into the production environment. Or again, we might have a more complex environment where we push from QA into a staging environment, where we then continue to run load and stress testing. So far in our CI/CD pipeline here, we have the developers making the changes, we have the developers pushing those changes into a code repository like Git, we have the build system or the continuous integration system like Jenkins, detecting that change in Git and then automatically compiling and testing those changes submitted by the developer. And on the test framework side, we have unit tests, which are most likely written by the developers as they're writing the code or before they write the code, if we're using test-driven or test-first development. And then we have web UI testing done with tools like Selenium, and then integration testing, which could be additional unit tests run with those UI tests and other acceptance tests on our integration server. Now, as we move on from continuous integration to continuous delivery and continuous deployment, there are other tools that we can employ, like Serena and Pivotal CF, as well as Google's cloud platform, Azure, and Amazon's AWS, to assist in this automation of delivery and deployment. So a textbook definition of continuous delivery is to be ready and able to deploy any version of our solution to any supported platform at any time. Continuous deployment is basically the same thing, but without the ready and able. With continuous deployment, as the name implies, you are continuously deploying every change that successfully makes it through compile and test automatically to the production environment, or at least to a production slot. Whereas continuous delivery, we're just ready to deploy it because we've done all of our compiling and testing. Maybe even we've done some more exploratory testing, manual testing, and even some automated load and stress testing. But in any event, the solution is ready to be deployed. It's just not deployed yet. with continuous delivery. With continuous deployment, as the name implies, we have actually deployed the solution. So now that the solution is deployed, the operations team is going to want to make sure the systems and deploy the code onto the production environment in a consistent way. For that, we need configuration management to help make sure that the systems are configured in a consistent state and functioning properly for the version of the software that's about to be deployed. This avoids configuration drift and incorrectly configured devices. Using a configuration tool like Ansible, Puppet, or Chef, we can make sure that the configuration happens automatically and in a consistent way, so every deployment is either successful or fails the exact same way it failed last time because the failure was part of the automation. Some DevOps tools that we can use for these configuration operations are Puppet, Docker, Chef, and Ansible. Now, these tools are the most common tools used for this deployment and configuration automation phase of our DevOps delivery pipeline. So again, configuration management is the process of systematically managing and handling changes to a system in a way that maintains integrity over time. How does it do that, you might ask? Well, it does that by doing the configuration in an automated and consistent way. So the same way we take our code and we compile it, we test it, and make sure that it passes those tests and compiles successfully, we can take our configuration and do that in the same automated way. And once we have a configuration automation script that works successfully, we can then take that configuration automation script, that playbook, that recipe, or what have you, and store it in the source code repository, along with the rest of the solution artifacts, the code, and any documentation that we might have collected or created over time, and put it in that central source of truth, GitHub, our central repository, or whatever tool that you choose. Now we have everything either in our artifact repository, that would be the output of our build, our deployment package, or in our source code repository, which is all of our source code, documents, configuration files, and so forth. We have a central source of truth for all of the resources necessary to successfully deploy this solution. So even if we had nothing more than our source code repository, our artifact repository, and bare metal resources, we could reproduce this solution. So Puppet's an open source configuration management tool for deploying, managing, and configuring multiple servers in an automated way very consistently. So we basically have the notion of nodes, or the puppets, if you will, that are controlled by the Puppet master. So what basically happens here is the node sends the data about itself to the Puppet master. The Puppet uses that information to compile a catalog that shows how that node is supposed to be configured. But if over time something changes and that node reports back to the Puppet master that the configuration is incorrect, incomplete, or has changed something that's non-standard, then the Puppet master can then push down updated configuration to keep that server in a standard state, consistent with its stored configuration and all of the other nodes that are necessary for that solution to run. Now, as far as deployment to these different servers and configured resources, an easy way to make sure that deployment is consistent is to really avoid the redundant configuration and deployment of those solutions to multiple servers individually by deploying into a container and then using that container to replicate that configuration across multiple devices and resources. Containerization is basically the process that allows software to run reliably when moved from one computing environment to another, because it's not dependent on the local computing environment itself, rather on the container host, if you will. Basically, a virtual machine requires that we use up a lot of resources and install a full copy of the operating system inside of that virtual machine. And that virtual machine basically needs all the same hardware that the operating system needs to run. Containers, on the other hand, live inside of that host machine and effectively are segmented from all of that hardware and requirements of having a full operating system. They're basically small containers inside of the existing operating system. So we get the same level of isolation without all the overhead requirements of having a full virtual machine with installed operating system. This allows us to easily deploy the containers without all the headaches of installing an operating system and redoing the configuration. So Docker containers are basically standard units of software that package the code and all of their dependencies so that the application runs faster and it's reliable from one computing environment to another. Again, because it's not dependent on the underlying hardware or even the underlying operating system, but just the container host. So the operations team verifies that the website is functioning correctly and the entire architecture is working properly. And once it is, then we can continue to monitor the website on an ongoing basis and make sure that performance doesn't degrade over time, to check and see what features users are actually using and what features that they're not. So we can send that feedback back to the development team so they can make changes as needed to make sure that we're meeting the requirements of the customers. So operations team monitors, collecting feedback from the website, and doesn't do us much good to collect that feedback if we don't have an easy way to push that feedback back into the team that built the solution in the first place. So some tools that we can use to collect that monitoring information, to collect that ongoing usage information are Splunk, Nagios, and New Relic tools I'm sure you've heard of before for monitoring on the enterprise scale and being able to collect that log information, to collect that monitoring information, those key metrics, and display them in an easily consumable way. So basically monitoring is that process of detecting, examining, and reporting if there are any faults or threats in the entire infrastructure. So not just with the hardware, but also with the operating system, with the software that's running on that operating system, with any of the containers, with the network, with the memory, anything that might impact in a negative way the execution of our solution should be collected and alerted on using our monitoring tools. So Nagios allows you to monitor the server and check and see if there are any underutilized resources or if there are any task failures that need to be addressed or any other critical issues that might cause a negative impact to the service of our customers. So basically Nagios has a plugin that we install that allows it to load resources or log data or alert information from those remote servers and send them to a central location where they can be aggregated and displayed through the web interface. This allows operations team members that are monitoring those systems in production to easily see and aggregate that data so they don't have to go and look at individual reports from every single server that they're responsible for. If there's a problem, then the tool will notify the admin about the status or of whatever resource is having an issue.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
And in this demo, we are going to demonstrate some of the uses of the common commands in Git. So we're going to use Git version to check our Git version. We'll use Git help to list some of the help commands there. And then we'll use Git Commit, Git Add, Git Init, and Git Status to manage a basic Git repository. So let's go ahead and get started. You can see I'm on my C drive in a Git repos folder here. So I'm just going to right click and say Git Bash here. So I'm going to open a bash command prompt here, and we'll increase the size of the font so you can see it better there. And here we'll start with just Git version. You can see I'm running Git version 2.21.0 for Windows. And to see what's in this folder, we'll do an ls. As you can see, the folder is empty. I do not have any repositories yet. So I'm going to do a make directory, and I'll make a directory called Hello Java. See, I've got my Hello Java folder now. So I will change directory into the Hello Java folder. And here we'll do a Git Status to see if this Hello Java folder is a repository. No, it is not a repository yet because we just created it. So we're going to do a Git Init to initialize this repository. And you can see now at the end of the command prompt here, we have master, indicating that we are in a Git repository and we are on the master branch. So now if we run a Git status, it says we are on branch master. There are no commits yet, and there is nothing to commit. So let's create a new file, and we'll create the file hello Java. You can see we have that file. Now I'm not going to bother with the Vim editor in here. I'll show you why in just a few minutes here. But I'm going to go into my Hello Java folder, and I'm just going to edit this file using Notepad. And I'm just going to create a very basic class here. And my class is going to be called Hello. So I'm going to create a public class, Hello, and my public Hello class is going to have a single public static method, that's spelled static correctly, that returns no values and is called main. This method accepts a string array as the argument list. All this function is going to do is simply print something to the console. So this will print hello world to the console. So we're going to do that by doing a system.out.println, and what we're going to print is hello world. Can't have a programming demo without at least one hello world. So there it is. So that's our class. I'm just going to save our class and close the editor here. You can see we've got our Hello Java file there on the Windows Explorer. Again, double check that it's here, and we'll do a cat hello.java to see that we do have those contents of the file. Now, if we do a git status, you will see that we have our Hello Java with untracked changes. So in order to be able to commit our new Java file to our repo, we're going to have to do a git add and the name of the file that we want to add, in this case Hello Java, adding it to the staging area, where if we do a git status, we'll see now it's green. It's a tracked change, but it still has yet to be committed to the repository. So to commit, we're going to do git commit. Now normally what I want to do is put a -m in my commit message, but I want to show you why I didn't use the Vim editor earlier. By doing a git commit, and it says, hey, you have to add your commit message, so here's this text-based editor for you. I'm not really a fan of this text-based editor, but if we start typing, we get the insert command, and we can type added hello.java file. And then we have to hit escape to get out of insert mode, and then we have to type :x, enter to save and exit. In the case of creating a file, to open Notepad to create the file, or in the case of committing, to just use the -m switch and put your message right there on the commit line. We do our git status again. You can see that we now have nothing to commit because we have committed our change already. Now, the next thing that we might want to do here is to push our changes to a remote repository like GitHub. But if we try to do a git push, normally we would call that remote repo origin, and we'd want to push to the master branch. If we try to do that without first specifying where that remote branch is, it's going to give us an error message. And the error message basically says, origin does not appear to be a Git repository and could not read from the remote repository. Make sure you have correct access rights and the repository exists. Make that message a little more clear. If we delete where we were trying to go and we just do a git push, it tells us that we first need to specify a remote repository using git remote. So if we do git remote add origin, it wants then the URL to our remote repository. So to get to that, what we'll do here is we will launch a new instance of the browser, and we will go to GitHub. On GitHub here, we are going to first create a new repository. Call our new repository hello. Let's call it hello world. We'll accept all the defaults here and create our repository. And then it gives us here the URL to our repository. So I'm just going to copy the URL to the clipboard and then switch back over here to my git remote add, and I'm going to paste in the URL to that repository. Now I have a reference to my remote repository, and now we should be able to successfully commit our changes to that remote repository. But before we do that, let's take a look at the repository. You can see this repository has no files in it. It's completely empty. It says we can create a file or upload an existing file or import code from another repository. All we are going to do is complete our git push to the origin master, enter. And after a few seconds here, you'll see that our push completed successfully And we can switch back to the browser and do a quick refresh. And you can see that our one file hello.java has been added with our commit message added hello.java file or class in parentheses. So at this point, we have created a file, added it to our local repository, and then pushed that file to our remote repository, where we then might be able to share that file with other developers or other team members working on this solution. We are going to do another demo here on Jenkins. And in this demo, we are going to first create a basic Jenkins job to run a Windows batch command. And then we'll build another Jenkins job that pulls a very simple Java class from GitHub and builds that Java class and executes it as part of our Jenkins job. So first thing, let's take a quick peek at Jenkins here. And in Jenkins, a couple of key locations that you're going to want to be aware of are the Manage Jenkins area here. And inside of Manage Jenkins, we have the area where we can do our global tool configuration. And this is where we would set up tools like Maven for compiling our solutions, the JDK for accessing Java. There's our Maven access. If we want to set up Docker containers as part of our Jenkins jobs, we'd also want to set up a reference to our Docker installation here. We're going to do a pretty basic demo, so we won't have the need for any of these tools. But if we go back to our dashboard and then back to Manage Jenkins, there's also an area here where you can manage the plugins that are installed in Jenkins. Now, here shows the updates that are available. And since I just installed Jenkins and loaded all of the updates, there are no new updates available. But if we click on the Installed tab, you can see all of the default, or rather recommended, plugins that Jenkins loaded after installation. After installation, it'll basically ask if you want to do a manual installation of just the plugins that you want, or if you want Jenkins to go ahead and install the recommended plugins. And this is what you get if you install the recommended plugins. For our purposes, in a later demo, we'll be using the Git plugin. And you can see here that's installed by default as part of that recommended setup. Okay, so we're going to start by creating a new Jenkins job. Pretty basic Jenkins job here. And we're going to call it Hello Jenkins. You can see I've done this before. We're going to set that as a freestyle project so we can build it from scratch. And in this demo, we're not going to pull anything from GitHub. We're just going to send a very simple command. And so we're going to scroll down to the build step, and we're going to add a build step called execute Windows batch command. And in this Windows batch command, we are just going to echo something to the console where we're going to say hello from the Jenkins job. And we're also going to display the date and the time that this request came in. And then we'll go ahead and save that. And now when we go and build this project, very quickly we get a success because there wasn't much to execute. And then if we click on the build there and we go look at the console output, you can see that we successfully ran this job and printed to the console, hello from the Jenkins job, Wednesday, 3/20/2019, 15:39 and 29.96 seconds. Success. So let's up the ante a little bit. Let's go back to the dashboard, and now we'll build another new project. This project, we'll call this one, yep, you guessed it, Hello GitHub. And again, we'll make it a freestyle project so we can build it from scratch. And we're going to tell it that we're getting this code that we want to build from our remote repository. So it's going to want the URL to our remote repository. Just so happens I have that open over here. We're going to get our Hello World repository here. So I'm going to grab the clone or download and copy the link to the repository. Once I have that link, I can come back over here into into Jenkins, and I can paste that link to my GitHub repository. Now, if your repository requires authentication, you'll want to go and add that credential in your Jenkins credential provider and add those additional credentials that you want to use here. I believe I've already added the credential for that GitHub account. So all we need to do now is just add our build step. And our build step in this case is again going to be a Windows command, your Windows batch command, and we're going to do Java C for the Java compiler, and we want to compile hello.java, and then we want to run using the Java runtime the hello Java class that we just created. So now we can go ahead and save, and then we can now build this job. A small delay while we compile, and the blue sphere there means that we were successful with our compile and run of this job. And if we go and look here in the console output, we can see that we compiled our Java hello, and then we executed our Java hello and got hello world on the console. That concludes our Jenkins demo. And in this demo, we are going to install Puppet and the Puppet agent on 3 nodes in AWS. So to that end, we'll create 3 instances in our AWS console here. We'll start with the Puppet Master instance, and we'll create that on an Ubuntu server. And we're going to use a T2 medium with dual core CPUs and 4 gigabytes of RAM. Now, we're going to put it into a security group that has all ports open, just so we don't have to deal with any firewall issues. And we'll just double check in the instance details. Subnet usage. We'll let it go ahead and create its own subnet here, and then we'll review after it's created to make sure that our other nodes end up in the same subnet. As for tags here, we're just going to add a new name tag, and we're going to say Puppet Master. And then we will launch the server. We're going to use the Oregon key here, since we are using the Oregon data center. Go ahead and launch that instance, and we'll view this instance again just to review the subnet ID that it's on, and it's on subnet with the last 3 characters of 4D4. So now we'll go ahead and launch our 2 nodes, again using Ubuntu server. This time we're just going to use the T2 micro, 1 CPU, 1 GB RAM, because it's in our free tier, eligible tier. So we'll go ahead and again set the security group to everybody all in, review and launch, and then we'll update in the instance details the number of nodes. We're going to get 2 nodes this time, 12, 2 nodes this time, and then the subnet. Again, going to use that 4D4 subnet so that we can access the master node, and then we'll add a tag, a name tag called Puppet Nodes, and review and launch, and we'll launch those nodes again with the Oregon key, and we'll launch those instances. All right, so if you view our instances, we've got our Puppet Master, and I'm going to edit these names here and call this Puppet Nodes 1, and we'll call this one Puppet Nodes 2, just so we can keep track of which is which. Now, first things first here, we want to connect to our Puppet Master using Putty, and to do that, we're going to use its public IP address. And then we'll go launch Putty here. I've already got a setting here for Puppet Master, but we need to paste in that updated IP address. And then just to make sure that we are using the correct key, there's our Oregon key. Now we can go ahead and connect. But before I connect, I'm going to go ahead and save that. And now we have a connection to our Puppet Master. And then, now that our nodes are up, we'll connect to the public IP of our Puppet Node 1, again using Putty, agent connection here, paste in our proper IP address, and again just double check to make sure we're using the right certificate, and no we're not, so let's change that to our Oregon key, and again we'll save that just so we can reference it easily later. I'm going to move this window over here and then go and connect to node 2 using its public IP. And again to Putty, we'll use that same agent setting. We shouldn't have to double check and make sure that the certificate is correct because we just saved it, just in case anything's gone horribly wrong. Yes, we see we're using the same Oregon. I'm not going to save this one. I'll just switch the IP back and forth. Now we have a connection to our second node. So we now have node 1, node 2, and our master node over here. So now we can begin to add our settings. So first up on our Puppet Master, we are going to set its hostname to Puppet. We're going to do that using the hostname ctl set hostname command. And we're going to do that using a super user do and set that hostname to Puppet. Now we'll do the same on the nodes, setting them to Puppet agent and Puppet node respectively. But before we do that, let's go ahead and edit our host file so that we can tell the system what the local IP address is for our Puppet master. Now to do this, we're going to go back over to AWS. We're going to grab our Puppet master and grab its private IP address. Then we'll jump back over to our Puppet master's host file, and we'll paste in that IP address along with the name of our server, Puppet. And then we'll use Control X, Y, and Enter to save that file. Now we'll do the same on each of our Puppet nodes. We'll first set our agent to Puppet agent, and then we will set our node to Puppet node, and then we'll go back and edit the host file on each of those machines. And again, we're going to grab that private IP for our Puppet master, and we'll include that as well as the name of that server. And we'll do the same down here, and then Control X, yes, to save the changes, Enter to save to that file name, Control X, yes to save the changes, and Enter to save that file name. So now that we've got the basic DNS info set up, we can continue on with installing resources on these servers. So to do that, we're first going to do a sudo apt get update to update the package repository, and we'll do that on all three of these servers here. First on the Puppet master, then on the agent, then on node 1, then on node 2. And once our update is complete, we will then do a wget to set the Puppet Labs installation repository. And since we'll need to install the Puppet master on the Puppet master, obviously, and then the Puppet agent on each of our nodes, we'll use this same statement on all three nodes. So wget https://apt.puppet-labs.com/puppet-labs-release-pc1-exenial.deb. Go ahead and execute that on the Puppet master, on node 1, and on node 2. Then after that, we want to reference the package, again on all three nodes. Sudo dpkg-i puppet-labs-release-pc1-exenial.deb. Again, we'll execute that on all three nodes because we'll need access to that repository to install both the Puppet master as well as the Puppet agent on all of our nodes. And then we'll do a git update to update our package repositories again. Again, on all three nodes, we'll do that. And finally, on the first node, we can go ahead and install the Puppet server. So we'll do that with a super user do apt get install puppet server-y. Now obviously that's going to be a little bit different than what we do on the Puppet agent on our nodes. So on those additional servers, we're going to execute super user do apt get install puppet-agent. So Puppet agent this time instead of Puppet server. So sudo apt get install puppet-agent-y. We'll do that on both of our nodes here. And then we'll jump back to our Puppet master so that on our Puppet master we can complete the configuration by editing the Puppet server configuration file. And we'll do that with the super user do using the nano editor to edit etc/default/puppet server. Now in this file we need to modify the Java args so we can adjust the memory allocation for our Puppet installation. We're going to change that from 2 gigabytes down to 512 megabytes. So do that by adding XMS 512M and XMX 512M to the Java args. And then again, we'll Control X, yes to save, and Enter to save to this file. Now that we've got the memory configured, we can go ahead and start Puppet server. And to do that, we'll use systemctl start Puppet server. Super user do systemctl start Puppet server. And once we've started the Puppet server, then we can go ahead and enable it for auto start when the system starts back up again. And then before we can go any further on our agents, we'll want to set up a manifest file to install something on those agents. And for this demo, we'll do something pretty simple and straightforward. We'll go ahead and install Maven so that we can later build Java projects. But first, let's enable our Puppet server for auto start. Now, our server is up and running. We can check the status of our server using systemctl status Puppet server. Check and make sure our Puppet server is up and running. We can see here that it is active. It's up and running. That means we can now go ahead and add our Maven manifest file. So we'll do that this time using the Vim editor. And we'll do that with the superuser do vim and then the path to our manifest, etc puppet labs /code /environments /production. So we're working with the production environment here, and in the production environment we have a manifest folder that we are going to create a file called maven.pp in. Now in this file we're going to specify a node configuration for default nodes, so that's every node that we encounter. We're going to set up a package, the Maven package, to be installed. So we're going to ensure that that package is installed. And we'll close our package reference as well as closing our node configuration. And then we will enter to save that file. Alright, so now that we've got our manifest file over there, we can go to our two Puppet nodes, and on those Puppet nodes we can edit their Puppet configuration files so that they can reference the environment that we want to install our configuration from. So we're going to edit using nano again, using the path etc/puppet labs /puppet config. And in this file we are simply going to add a reference to a main section, and then we'll include cert name, and we'll set the cert name in this case to puppet-node1, and then the server equal to puppet, and the environment equal to production. And again, we'll control X and Y to save, and enter to save to that file. We'll do the same down here on node 2, and again we'll create a main section. We'll add a reference to the cert name, puppet-node2 this time. And then the server will still be puppet, and the environment will be production. And one more time, we'll control X, yes, and enter to save the file. Now that we've got that set up, we can go ahead and start our Puppet agent service. So we'll do that with the same command that we used earlier, sudo systemctl start puppet this time instead of puppet server. Both servers, and then we'll configure those servers for auto start. And just to make sure everything is doing what it's supposed to be doing, we'll try to telnet to the Puppet server. You can see there that we have successfully connected to Puppet on its private IP. The same thing down here on node 2. Make sure node 2 is good. Also successfully connected to Puppet. So now we can go back to our Puppet server, and the act of starting the Puppet agent service on each of our nodes should have sent a certificate signing request to our Puppet master, just to make sure that we have secure communication. So let's take a look at the cert list on Puppet to see if we have a list of 2 certificates. To do that, we're going to use superuser do opt puppet lab /bin and puppet cert list. This should give us a list of the cert requests that have come in, and you can see there we have one from node 1 and another from node 2. Now we could either sign these requests one at a time by adding puppet node 1 and then puppet node 2, or we can sign the requests all at once using this command, superuser do /opt /puppet labs /bin /puppet cert sign --all. That will sign both of those requests with one command instead of having to execute 2 separate commands. Successfully signed both of our cert requests, and now we can go and execute our configuration. Now before we do that, let's just double check and make sure Maven is not installed here. We try to do an mvn --version run, we get a message that says command mvn is not found, but can be installed with sudo apt install maven. So that tells us very clearly that mvn is not installed on either of these nodes. So now we can run a superuser do opt/puppet lab/bin/puppet agent test. And this will attempt to go out to the master server, the puppet master, and retrieve manifest files that are configured for this node, or in our case, default, which is all nodes that connect, and then it'll install whatever's in the manifest. So we'll run that first on node 1, and then we'll run that same command on node 2, and you can see that ran very quickly in 0.04 seconds. And now, if we run mvn -- version, you can see that Maven 3.5.2 was successfully installed on both nodes. And that concludes our demo of Puppet running on AWS. So from this section, the key takeaways are that DevOps is largely an organization-wide cultural shift. It's mostly cultural. There's a lot of tools, there's a lot of technologies that we'll talk about, but for the most part, DevOps is a cultural shift from one way of doing business, from one way of developing software to a new, more agile, optimized way of delivering software and resources. To do that, we need tools, obviously. So things like version control, we talked about Git and GitHub. And once we have some changes loaded into version control, then we also need to have some system in place that can detect those changes and then make sure that those changes haven't introduced defects by making sure that they still compile or build. And after we get a successful compile, making sure that those changes pass the tests and that automated tests that we have in place don't start failing after we've made a change. And then using those same tools, we want to make sure that we get that successfully compiled and successfully tested solution off into an environment where we can do more exhaustive testing, where the QA team can do some manual testing, some exploratory testing, or do more in-depth automated testing. And then finally, we want to move into an environment where the operations team can make sure the configuration is done correctly. We can make sure the infrastructure is in place before we begin to deploy in an automated way to those production environments. And again, with that deployment, we want to make sure that we're doing it in an automated, consistent, and reliable way. So we'd want to use an automation tool like Puppet or Chef or Ansible. Now, to simplify the deployment process and make the deployment process more repeatable, we can use containerization and containerization tools like Docker to allow us to deploy in a repeatable, reliable way while minimizing the need for excessive operating system configuration or dependency on multiple virtual machines. And finally, using log aggregation tools and monitoring tools like Nagios and Splunk and Elk, we can collect all the information from these multiple servers on our DevOps delivery pipeline and make sure that we're alerted instantly if anything happens that would negatively impact the service to our customers.
Now in this tutorial by Simplilearn is designed in such a way so that we can give you a basic understanding that how exactly Git really works. Now in this one we are going to talk about various concepts which we involve in Git. We are going to also talk about the various Git commands which we are going to talk about here, and a variety of things, and different kind of demos are also a part of this one. Now Git is something which is really popular at right now over here. Before the Git, Subversion was quite popular and a lot of organizations were actually using it. But now Git is a kind of a version control system which helps us to track the changes just like any other version control system into a particular working copy or into our particular laptop. Now it's having a certain benefits which is exactly not available in any of the other version control system. So it's used to coordinate the work among the developers. So different developers are actually collaborating with each other with the help of this version control system. They are able to track the progress. The senior developers or the leads or the managers can always find out that what are the different changes a developer is doing, how the different commits are happening there. So it's a wonderful feature of a version control system that you get a complete tracking, you get a complete history. So any person can go ahead with the version control system and they can really find out that what exactly it's happening into this one. So all those features are definitely provided by Git also. It is used to act as a kind of collaboration tool so that multiple developers can really push their source code to this remote repository. And then again, it also provides us the tracking mechanism to track the overall progress of the development. So the main work of Git is to manage the projects, and a couple of repositories are managed here. And in these repositories, you manage your work, you manage your source code, and the developers perform various kind of activities like checkout, check-in, push, pull, different activities they do to interact with the source code. Right, so Git can be useful for both programming professionals like the developers and all, and non-programming particular professionals also. Now, as a DevOps engineer, if you are not doing the programming, still you can use the Git repositories for having your files, for having your source codes, your scripts. You can store Ansible scripts, you can store Puppet script, you can store Python shell scripts. All that things you can do it. For you, it is a kind of a source code. For developers, they can store Java source code, .NET source code, Android projects. So that's a kind of a source code for those particular programming language or for those teams. Now, that is the reason why Git is really helpful over here, because it provides the comfort, or it provides the help to both the programming professionals and the non-programming or non-technical professionals also. Right? So it also helps in coordinating the work among the team because of the tracking feature, history feature, and the collaboration here. So different developers can actually use these repositories so that they can push their source code to this single location. And then in fact, different developers can, take updates. They can even find out at what other developers are doing. So they can do the sync up, and even if someone is not giving you the, the particular details, still you will be able to get it from the repository. So that's a kind of a good collaboration mechanism or tool which can really help to increase or improve the communication between the different developers. So what exactly is a Git repository? Now, a Git repository is a place where we keep all the files related to our project stored there. Now, there are two types of Git repositories. One is local repository and one is the remote repository. Now, when we work with Git version control system, so what happens that we have a central remote repository which is available there on the Git server. Now, this is something not present in local system. It's on a remote server. So when you do a clone activity, when you bring that repository into your local system, now what happens that in Git version control system, it does not create only a working copy, but in fact a local repository is created. Now this local repository is having the link up, or it's having the connectivity with the remote repository. So whatever the changes you will do, if you push your changes to the remote repository, that is something which will be possible with the help of this version control system. So here it's not like every time you will be interacting with the remote repository. Whenever you feel that you want to push some changes to the remote repository, at that moment of time, there are some couple of operations like push and pull activity which you will be using to interact from the local repository to the remote repository. So local repository is the one which you will be bringing on when you clone the remote repository. Now remote repository is the repository which is having the main important source code. So using the local repository, you will be interacting with the remote repository, and that's how the various kind of operations, you can do the modifications, whatever the commits you have performed, you will push it, you will pull it. So all those activities you will be able to do with the help of local and remote repository. So these two type of repositories are available, which we can further use to make our changes and perform our particular source code changes here. Right, now let's talk about some of the Git commands, because ultimately when we work with the Git version control system, we have to do a various kind of operations like pushing the commits, performing the merging. So all those commands, let's talk about that. Now the very first one, the basic commands over here is that Git Config. So Git Config is the mechanism using which we can configure the username and email ID. Now why we require this? When you will be doing some Git commits or you will be doing the modification, so as a standard feature of version control system, it preserves the author details, like whatever commit it wants to do. Whenever he wants to create a new version, it has to embed some of the author details. Now this author details involve an email ID and a particular username. Now this email ID and username if you don't configure. In that case, some dummy system related email ID and username will be picked up. So in that situation, we will not be able to understand that whether the particular check-in is done by a developer or it's being done by a particular machine. So for better understanding, to get a better comfort, that's the reason why we use the git config over here to configure the username and email address over here. Then we have Git Init Command. Now this Git Init Command is used to create an empty bare repository. So this command, when you run, you will be able to create a bare empty repository, and after that you can further on do the modifications, you can add some commits, you can add some files, and all that stuff you can do over there pretty much. Then when you add some files, now what happens that when you do you want to go for a git commit activity, before that the files should be present in the staging area. Now staging area is a location where you will be preparing or you will be storing the files temporarily before even performing any kind of commit. So git add and git commit command is something which is executed into a sequence. First of all, you will run the git add command to bring all the changes or all the changed file into a staging area, and when you done the git commit command, so all the files will be committed. Now git commit command will not take up how many files you want to commit, because whatever the files you will put up into the staging area, git commit command will read all those files and it will perform single commit for them. So if you feel that you want to only check in 2 files out of 20 files, please go for the git add command and first add only these 2 files into the staging area. If you add all the 20 files into the staging area, then all the 20 files will be modified and a new commit will be created there. Then we have Git Diff Command. Now Git Diff Command is used to see the changes made to the files, to see the difference. You can use Git Diff Command with the branches also to see the difference between the 2 branches. So Git Commit Command is something which makes sure that all the changes are saved permanently into the local repository. So Git Add and Git Commit Command are executed into a sequence, so that first of all you can add the files to the staging area, and then Git Commit Command will pick up those files from the staging area and preserve permanently as a commit into the local repository. Then we have Git Reset Command. Git Reset Command used in various types. One time you can use it as in kind of just to reset the changes in the files, and in a certain way you can also use it to delete the commits from the Git repository. Git Status command displays you the state of working and the staging area. So Git Status command also tells you certain particular features like what are the different files which is in the modification state, how many files are there present in the modified state. So all those information is something which we are getting from the Git Status. Git Merge is a very good feature, because whenever we work with the different branches, so Git Merge is a mechanism to move the changes from one branches to another. So if you are required to do the modification to the develop branch and you want to move those changes to the master branch, in that situation we have to merge develop branch into the master branch. So it's a kind of a mechanism to move the changes from one branch to another. Then we have Git Push. Now till Git Merge command, all the commands you can run to the local repository, which means that you don't require any kind of remote repository. You can simply work on the local system, and without any network connectivity with the remote repository, you will be able to perform those changes. But Git Push is a mechanism to push or move the changes from the local repository to the remote repository. So whatever the commits you have done, every time it will not interact with the remote repository. Only when you run the git push and pull command, that is where you will be performing the interaction or communication between the local repository and the remote repository. Push is to push the changes from local to remote repository, and pull is something which is pulling up the updates from the remote repository to your local repository. Right, now let's talk about some of the basic Git operations here. Now so far we have seen that what are the different basic Git commands are there, which we use time to time to perform the various operations and various tasks within the version control system of Git here. Now let's talk about some of the basic Git operations as such here. Now the very first one operation over here is the initialize of a Git repository. Now this is something which we perform to create a kind of a new repository or a new project. Then we have add operation. to add some files. Then add operation is used to add some changes or modified files to the staging area. Git commit is something which is used to create a new version of the group of files. Then pull is to bring down the changes from the remote repository to the local repository. Then push is there to push the changes from the local repository to the remote repository. So these are some of the basic operations which we perform so that we can move the changes from one state to another. Now the first one is Git Init Command. Now it's used to create a new and empty repository, where a repository over here. Now once the Git Init command is executed, what will happen? You will run the Git Init command in a folder. For example, I have created a folder called Git Repo, and in that I have initialized or executed the Git Init command. Now the moment you did the execution of Git Init command, so what will happen? A .git directory will be created in that system. So this .git directory represents that you are working right now onto a Git repository. You can also further run the Git Status command and find out that, okay, this is the repository preserved over here. But if you don't have the .git directory, it means that it's a plain folder and it is not a kind of a Git repository. Now remember, .git folder is only the folder which is created there. There will be no files which will be created as such in this one. So Git init is only creating a bare empty repository onto the system. Right now, once the repository is initialized, so you can further on go ahead and add some files, some folders, or whatever stuff you want to perform in that repository. Right, so in this diagram you can see that when you run the Git Init command, you will be able to see the .git directory created over here, and you will also see that that's the only folder structure which is created as such over here. So on Windows machine, you will be able to see it pretty easily because of the file name, but usually in the Linux platforms, .git is specifically designed or is known as a hidden folder. So all the files and folder with dot in front will be considered as hidden there. So in that case, you can run ls-lart to get on and to see the content over there. Then we have add operation. Now once you fire the modification is done, so once all the changes are performed there, so you will be adding the in order to perform the commits, first of all you have to add the files to the staging area. So staging area is in a particular temporary location where the git commit command will look upon, and all the files which is present in the staging area will be picked up, and all of them will be preserved or will be converted to a git commit. So before running the git commit command, git add command is required for the files to be added so that we will be able to move them to the commit here. Now in this case, you can see that git status is the one which we are running to check on which status we are right now, and we have modified like a file called alpha.txt. So git add dot is what we are trying to run over here. And then you can see that from the red color, earlier it was an untracked file, but now it's became in tracked files, and it says new file. And then further we did the git commit. So at that moment of time, what will happen, that this file will be completely checked out into the repository. And further after this one commit, if you run git status command, there will be no file present there. So git add and git commit command are executed into a sequence so that they will be able to have a proper commits there. Now the commit is in situation where you will be changing your history of your repository. It makes sure that the changes which you are doing is permanently preserved into the Git repository. So Git commit command requires a particular flag called -m. Now -m is something which is there for providing custom message for what reason you are doing the Git commit. Now if you don't provide this message, your Git commit will fail, but you need to provide a message to specify that what is the reason behind performing this commit activity. So that is what you are trying to provide over here with the -m over here, and preserving and providing the details that yes, this is the reason why you are performing a commit activity into your local repository. So you can see here that we are giving a particular commit message called beta gamma, but in real world you will be providing some commits like fixed debug bug 120, or fix this feature, or fixed this functionality, so that we will be able to see from the commit message that what is the reason behind this commit here. So we don't have to unnecessarily go inside the commit and find out the details. All the details we should be able to get it from the commit message. So that's the reason why it's very important that we provide a valid commit message. right? Then we have the next operation over here is the pull. Now pull is something which is used to fetch the latest updates from the remote repository and then merge those changes back to your local repository. So just kind of operation in which we are taking up the update from the remote repository. The purpose of taking update from the remote repository is that because different developers are collaborating or uploading their source code to this remote repository. So in that situation, if we want to take some updates from the remote repository, that is the reason why we will be using the git pull command to get those changes and merge it into your local repository. Then you can have some example, like we can run the command called git pull origin master. Now it will copies all the files from the remote repository to your local repository. So it will do a sync up of master branch of remote repository into the local repository master branch. You can have the it's in combination of two commands. One is a git fetch. So first of all, it downloads all the content, and then git merge. It combines all the sequence of commits into the specific branch. So it's internally, when you run git pull command, it fetches the specific contents. Now when git fetch command runs, it does not really changes any kind of modifications into your local repository. Ultimately, when the git merge happens, that is where the code changes into your local repository. But if you alone run git fetch command, it will not perform any kind of changes to your local repository. Right here you can see that we are pulling up the details. So here we are pulling up the details of our first repo, and when that is done, so we will be able to see some details out of that. Right now, then we have git push command, which is used to push the changes from your local repository to the remote repository. You will be doing a various kind of commits into your local repository. So at some moment of time, you need to sync up or move those changes to remote repository. That is where we will be running the git push command. So git push command is required. It needs a network connectivity, and before git push command, if you want to do some changes, you can do that. And once you want to share or you want to bring those changes to the remote repository, that is where you will be able to run the git push activity as such. So this is a kind of a mechanism using which you will be able to push some changes from the local repository to the remote repository. So here you can see that we are pushing the changes from the master branch of our local repository to a remote repository. And in this case, as you can see that it here says here as a new branch, because the remote repository was empty and there is no master branch present over there. So that is the reason why it says new branch over here. So these were some of the Git operations which talk about that how we can do some basic information and basic stuff over there. But now next thing which we have over here is the advanced Git operations. Now in this one, some couple of operations involved as in Git branch. Then we have the Git merge, and then we have the Git rebase here. Now the first one is the branch. Now a branch is in kind of a way of doing a parallel and independent development over here. Now at some moment of time, you feel that the developers needs to work on the source code or the changes independent of each other. So in this situation, you will be giving either a feature branch or a development branch to different developers. They will be doing their respective changes to these branches, and then further on you can do the sync up and you can merge the changes to a single branch according to the requirement. So the commits are done isolated from each other. So if you're doing some commits in develop branch, it will not put any kind of impact on the master branch. So git branch command is used to create a branch, to list a branch, to delete a branch, or to particular rename a specific branch also. Then we have merge. When we are talking about branching, then merging is also an important task. So the merge command is used to move the changes or one or multiple changes from one branch to another. So it is a mechanism to perform a sync up of the commits from one branch to another. So git merge command is used to combine two branches, and it's some kind of a mechanism in which we find out a single base, a common base, and then on top of that we move the changes or we combine the two branches here. Now Git Rebase is also performed for the same approach, but the process of rebasing refers to moving or combining a sequence of a commit into a new base commit. So Git Rebase is something which is doing a little bit restructuring of the commits. And normally Git Merge command is involved, in which it can preserve the specific base commit, and on top of that it can add up your commits and it can do the modifications. But when we talk about rebase is something which is combining the commits, but it also preserves, or it may end up in having a new base commit as such over here. So Git Rebase is somehow doing some modifications and restructuring the overall baseline of the commits, right? So Git Rebase command is used to integrate the changes from one branch to another here. Now these were some of the advanced features which is primarily used by the development team to do the modifications in different branches, then use the merge or rebase command to move those changes across the different branches here. Now let's talk about GitHub. Now what exactly is a GitHub there? Now there are some common scenarios where we think that okay, Git is different and GitHub is different. No, it's not like that. Ultimately, GitHub is nothing but an organization which internally uses the Git repository only. So they are using the Git solution only, but it's kind of a web-based graphical interface which is given to you just to have a better interaction with the Git repositories. So it's kind of a Git repository hosting service which is available there. So for example, you have the various hosting machines like GoDaddy is there, different other vendors are there, but ultimately they provide the same virtual machines like Linux, Windows and all that. Similarly here also they are all using the Git only, but they are providing it in as a kind of a good interface. They're providing you certain features, and these features are somewhere you can have the security, you can have the user base, you can have the permissions. So all those features you get with the help of the GitHub here. So it's a kind of a web interface which is given to you just to interact with the Git repository, to create them, to manage them, to delete them, all those activities. So it helps every team member to integrate with each other and at any moment of time. Now this is something which you can access anywhere. If you are using the public version of GitHub, you can use the repository anywhere with any network. But if you are using a private network or a private repository, in that situation, definitely in your office or into your network, you will be able to access. But it primarily depends on the way that how you are doing the modification and how exactly you have done the changes so far and so over here, right? So it's one of the good collaboration tool which is present, which primarily talks about that how we can do the modifications and how we can move the changes from we can have the collaboration between different developers and they can really do the changes and those modifications. Right now, what are the different features which we have of GitHub? So let's talk about that. Now some of the features are present over here in this way that represents that what are the mechanism and understanding about the specific GitHub here. So let's talk about these features. Now the very first feature of this one is the easy project management. Now it's a very good platform where you can have different kind of access levels. Project managers and developers can coordinate, they can track and they can update their work. You can manage the repositories, you can manage the access, you can perform the changes, you can perform the rollback. A lot of things can really happen there, and everything is recorded, nothing. So even the account activity is also recorded. So if someone is creating the repository, is deleting the repository, all that information is there. So it's kind of a easy project management where at a single location all the repositories are there. So it's quite easy for you to manage and to work on these repositories and to talk about them. Next, we have effective team management. Now it helps all the team members to stay on the same page and stay organized. So it's a kind of a modernized tool which is available there so that different people can work on the same platform. They don't have to learn different platforms here. As such, on the same platform they will be able to collaborate and they will be able to work with each other. Then improved code writing. So there are some features like pull request, which gives you functionality before even doing the merge activity. You will be able to do some review. So it definitely helps a kind of a check which is there, that before even doing some kind of merging, you should be able to review it. You should be able to see that what exactly you are trying to do, what kind of commits you are performing, and that can really helps to do some improvements to your source code, to your overall source code. So that's an additional check which is provided by the pull request feature of GitHub. It's not a typical merge only. It's something someone will review, someone approve it, then only the merge activity will happen. Now GitHub uses different tools to identify and analyze the issues there. So there are some tools or features which is available there in GitHub where you can also further on increase or analyze the source code and analyze the issues with the source code there. So development teams can work together to to secure the software supply chain. These particular say repositories are quite secured, and that is the reason why not everyone have the access or default access to the source code. So this is quite restricted, and due to this feature it's easy to maintain the high quality of your source code, right? And then we have the easy code hosting here. So all the codes and documentations are present in one location. There are millions of repositories which is available there on GitHub, and each repository is comprises of its own source code and its own different people having the access, right? And then it increased safety with packages. Those packages can be published privately. You can have both public and private access. The packages can be used or reused by downloading it from GitHub, and other variety of applications is there. So if you're working on open source, in that situation it will be publicly available. If you're working as in privately for a secured organization, in that case it will be available privately there, right? So these were some of the various operations which was there related to Git. Now let's talk about some demo and see that how exactly we can go for that implementation, and we can see some real operations of Git. So let's connect to our Git Simplilearn lab over here, a Linux lab where we can perform all these various operations, and we can see that how exactly it works. So let's log into the lab. Okay, so we have logged into the Simplilearn lab over here in the Linux. Now in this one, the various steps we are going to do is step by step. So first of all, we have our particular GitHub account logged in. So that's the account which we were using. Okay, so we will create a remote repository here. So first of all, we will be preparing a bare empty repository. Now after that, we will be adding some files. We will be doing some Git Commit activities, and then we are going to talk about like some branching concepts, and then the merging concepts and all that stuff, right? So now let's log into the particular lab here. So I'm opening the terminal. Now here does not requires any kind of root access or those kind of stuff. So I'm going to create a folder structure with the name called repo. So repo is the folder which I'm going to create as such over here. So in this case, right now, as you can see that there is no repository or nothing is present here. So I will run the Git Init command, which will do nothing but it will initialize a bare repository over here. So as you can see that when you run the Git Init command, you will be able to see a .git directory created. Now this .git directory represents that you are working with empty bare Git repository. Now once you get the repository, now if you have to execute some Git commands, like I can run the Git Status command, which can really let us know that yes, you are working on a Git repository. If you don't have the .git directory, definitely this kind of response you will not be able to get, right? So far we have only added up a particular kind of a Git empty repository over here. Now I'm going to create some files. Okay, so these files I'm going to create so as I should be able to do some modifications, and I should be able to add some files. So I'm going to create a file called master.txt. In this case, when I edit file, so I'm going to add like my first repository over here. So that's what I need to do. So this is my master.txt file here. So once the master.txt file is created, now if I run the git status command, what will be the response? The response will show me that you are basically trying to add a new file. So there is an untracked file, new file over here. In order to track it and in order to add it to the staging area, we have to further on do the git add command. Now git add command alone will not work. You have to further on after that run the git commit command also to preserve it or to showcase it as an kind of a git commit here. So first of all, I will add the master.txt file. So what will happen to the status? So you can see that the color of the file is being changed from red to green here. Green represents that this is a new file and a master.txt file is being printed over there. So far we have added this master.txt file into the staging area. Staging area is a kind of a area in which we will be adding up some couple of files, and the whole purpose of adding those files is that we should be able to proceed to the next level, which is nothing but the git commit activity. So we are going to run the git commit activity over here. Now in this one I can say like first commit. According to my comfort, I can give whatever the message I want to provide. I can provide that information. Right now in this case, as you can see that it picked up my default author over here, right? So if I want to do that modification, if I want to perform that activity and I want to change my author details, I can run the git config command over here. Now git config command, I can go for global. I can say like user.name. I can have like my name, some dummy IP I can provide here. So what will happen that all the further commits which I will be doing, that I will be able to do, and I will be able to set up there. Right now my author details is configured, so I will reset my author using this command here. So this is in kind of a mechanism that once your details is being changed, your username and email ID's details is changed, you should be able to reset your author details. Right, so it will open the commit message again. You just have to save it, and after that the commit should be performed here. So earlier the commit was being done with the details called Ubuntu, which is the user right now, and some dummy IP address. But at any moment of time you want to have your own username password, so you can say like git config -- global user.name. You have added a username here, then you are going for git config -- global user email ID over here, and after that what you have to do, you just have to reset the author details so that whatever the commits you have done so far, that also should be updated. So instead of having a Ubuntu user and some random email ID, now you're giving a specific author, in this case it's me, a specific author details as such into the history. So once the git commit command is executed, so what will happen that entry will be made up into the history. Now there is only one commit, which means that the last commit which you have performed, that have eventually added up the git commit activity. So this is the overall mechanism that how exactly you can create a bare repository. Then you have added up some couple of files, then you added or executed git add command, and further on you did the git commit command. During the git commit command we faced a difficulty, the author details was not proper, then we added the author details, and then we reset our author details so that we should be able to perform a basic operation. And this mechanism should let us know that how the execution and the performance is happening here. So the overall mechanism you can perform as such over here is that how exactly this particular mechanism or this activity is really performing, right? So this is the way that how exactly the overall operation is really happening, and you are able to get a kind of a log, a kind of a history in the repository, that what is the change which is being done, who is the person who have performed the changes. Now if you want to get the changes that what was changed over here, so for that you can run the command called git show and the specific commit ID. Once that is done, so what will happen, you will also be able to say that yes, you have added the content called my first repo. That is what you have added so far in this commit here. So these are some of the basic operations which time to time we perform so that we can do some changes really to our particular repository. Right, so this was some of the steps there. Now further on what we will be doing, we will be basically performing a branching mechanism. So let's talk about branching. So right now the branch which we have connected so far is the master branch. You can see a static symbol in front of which it means that you are pointing down to this specific branch as such over here. So next what you're going to do is that you are going to create a new branch. So we will say that I'm going to create a develop branch here. So when you run the git branch -l here, so it says that the develop branch is created, but it's not pointed out right now. So in order to move to that branch, so you have to run the git checkout command to move to that branch. Now once you move to that branch, you will be able to see the static symbol is in front of develop branch. So this movement from one branch to another is important, because ultimately if you want to do the modification to the develop branch, you have to be there in that develop branch. If you want to go to the master branch, you have to be there in master branch. So this is something which ultimately you need to understand, so that there should not be any kind of interference between the branches as such over here. So this is the overall mechanism. So now whatever the commits we will be doing, that will be checked into the specific develop branch, and all the changes will be performed as such over there. So now the next activity which we are going to talk about over here is that how exactly we can proceed further to these activities. Now what mechanism we are going to follow over next over here is that right now in this case you can see that git branch -l is there. So develop is being pointed out. If you want to see the difference, so you can say like git diff master. So that will show you the difference. Right now there is no difference as such over here, which represents the difference is not at all present so far in this case, right? So the next activity which we need to do over here in this mechanism is we will be performing some changes to this master branch here. So I will add some content here saying adding content in develop branch, just to have a proper check, so that if somehow I will see the files, I should be able to see that okay, this is what I have changed in the develop branch. Now these 2 lines are there. Definitely when I am going to see the difference here again, when I run the diff command, so it will do a branch to branch comparison, and it will say that yes, in this branch you have some additions which is not present in master branch, right? So that's the whole idea. The particular master branch should not be touched upon. If I'm doing some modification to develop branch, that changes should be present in the particular this branch only. Now in this case, what happens now, we know that git add command and git commit command we have to run. So I'm going to say like develop branch, right? So just an kind of a message you want to provide. So that's done. So if I do the git log here, so I should be able to see a new commit. Instead of 1 commit, 2 commits are there. In master branch, only 1 commit is there. That you can eventually check also. I can go to the master branch and I can check that also. So in master branch, right now you can see the last output is showing 1 commit. This one is showing 1 commit because it's present in the master branch. This one is showing 2 commits because it's present in the develop branch. So both the branches are having 2 different set of commits. Now definitely if you want to move the changes from the develop branch to the master branch, all you have to do is that you have to sync up. And how this sync up is done? It's done using the help of merge activity. So we will double check that on which branch we are right now. So we have checked that we are onto the master branch. We have to merge the specific develop branch into the master branch. So for that, what we will be doing, we will be running the command called git merge develop. So when we do that, what will happen, that it will eventually let me know, or it will eventually move or sync those changes from the develop branch to the master branch. So earlier in the previous situation, master branch was showing 1 commit, but now in this case it's also showing the specific that commit also moved on along over here. So this is how the sync up really happens, and the commits really move from one branch to another. Now in this case, it's not only the commit which is being reflected, but even the file is also being updated over here as such. So the master.txt file is also showing that the second line is being added as such over here. Right? So this is the overall mechanism and the system, that how exactly this whole activity is really working, and how we will be able to get some execution, and we will be able to get some particular results out of this one. So this is the way that how the branching and the merging really happens as such over here. So right now we are working on the repository, and this repository is nothing but a local repository. So far, now next we will be talking about the interaction between the GitHub and this local repository, or remote and local repository. So we'll go to the GitHub remote repository. Here we'll click on the particular new repository here. So I'm going to create a particular repo called Git repo here. the name is available, but if I give some different name, so if it is not available, so that will not allow me to create a repository. So here the public and private specifier you have to select. Public, anyone can see, but no one will be able to do the modification unless we provide the access. Private, nobody will be able to see the content unless and until he is not having the access. So only modification and view access both is restricted if they have the access to the repo. We don't have to initialize the repository with the readme. I want to create a bare repository, so create. Once the repo is created, you will see 3 sections of the information. First, if you want to create a new repository on the command line and do that, so you can see that some of the activities we have already done so far, so we don't require this section. Second section saying that if you already have a repository and you want to push it to the remote repository, so you have to run these commands. So these are something which we need to really do. So I am going to run this command. Now this command is something which is trying to add the remote origin over here. Now why origin is required? Because every time I cannot simply use the lengthy URL and I cannot remember it also. So you can see here that it's kind of a shortcut over here, that origin is being referred as this URL. So both for pull and push activity we will be using this one. So you will be running like git push origin master. It will definitely ask for your credentials, so you will give the URL username and you will also give the password. Now once that is done, so what you will see over here is that you will be able to see that a new branch is created, because in GitHub repository you were not having any kind of code base available. So when you refresh, the code will be available there. But this is just the master branch. If you want to move the particular develop branch here, it's the same details you have to provide. The same username, credentials also are same which you need to provide. And once that is done, you will be able to see that develop branch is also created as such over here. So you see 2 branches. 2 branches are in proper sync up, and you want to delete a branch, you can do that. You want to switch a branch, you can do that also. Because of the dummy IP address, you must have seen that it's showing a particular different username here, because I have just provided a different email ID like abc@abc.com, so which is totally wrong. So ideally, when you will be providing the actual information about the username, that will be presented over here and that should be displayed. But right now I just provided a dummy email ID, so not the genuine one. So here, if you click on this commit ID, so you will see the content. This is the last commit which we were doing. This is the first commit which we did on that part. So this is how you interact with the Git repository. Right from the scratch, we have prepared this repository. We have executed that. And as you can see that once the repository is created, you were able to get a particular Git repository on the GitHub there. So that's it for this demo. To today's topic on Maven tutorial. In this we are going to talk about the Maven here. Now we will be talking about that how exactly we can make use of Maven here in performing various kind of operations, whether it's a build, compilation, various kind of stuff there. So let's talk about it, why exactly we use Maven here. Now Maven is something which is a kind of a build tool which is there for most of the Java-based projects here. So this tool also helps us in building up the source code by downloading some couple of dependencies. These dependencies are something which is being configured by the developers, which a developer feels that the project is dependent on and he requires those dependencies to be downloaded. So this tool is specifically used to build and manage any kind of a Java-based project, whatever the complexity of the topic or the project is there. So this tool will be able to handle that particular requirement or that project. So it simplifies the day-to-day work of a Java developer and helps them in their projects for performing daily to daily activities. Right now, Maven also helps us in getting the specific jar files for each and every project. So if you are you can pretty much make a jar file, var file, or ER file, any kind of a package mechanism you can follow for your Maven there. So to download the dependencies, we don't have to actually go to the official website of each and every software. You can easily get it the dependencies of each and every third-party binaries on the mvnrepository.com. This is a website which is present, on which if you visit, you will be able to download the dependencies which is required by your project or by your specific project over here. So it totally depends on how exactly you want to download and you want to get together a specific repository over here. So mvnrepository.com is the one. If you visit, you will be able to download and go through all the jar files, dependent jar files as in dependencies which you require for your current project. Right. So now what exactly is a Maven all about? So let's see on that part. So Maven is a popular open source build tool which is developed by the Apache group, and the primary ownership of this tool is to build, publish and deploy several projects at once. Maven is written in Java, and it can be used to build projects written in C#, Scala, Ruby, etc. So apart from Java, these are the different programming languages or the tools which is supported by the Maven here for performing the build activity. So the tool is used for build and management of any kind of a Java-based project. It simplifies the day-to-day work of a Java developer and helps them to automate most of the compilation or build perspective tasks on the projects. Right. Now Maven is a kind of a POM-based project, so it also known as a project object model, and it focuses on simplification and standardization of the building process. In the process, it takes care of all the followings here: builds, dependencies, reports, distribution, releases, mailing list. So all these things are being taken care as in this particular process here, and ultimately it's an ability inside the Maven that how the overall build process needs to be automated and standardized here. So all these particular mechanisms can be followed as such over here, so that we can have a good standards and the simplifications implemented as such here. Now what exactly is a Maven repository all about? So Maven repository is something which is a kind of a directory, or it's kind of a location where we have all the jar files packaged all together in a single location. So depending on the software which you want to download, the dependent jar files can be downloaded from there. So the metadata refers to the POM files relevant to each project here. This metadata is what allows Maven to download the dependencies. Now there are three types of repositories from where we can download the dependencies. The first one is the local repository, second one is the remote repository, and the third one is the central repository. So these are the primary three types of repositories which is available there for a specific Maven over here. So whatever repository you want to follow, you want to access, you can pretty much access it and you can go with that. Right now, the local repository will be primarily present onto your PC. That's the way that how it's present there. And the particular remote repository is something which you can store on any remote machine or remote server. And the central repository is something which you can have it onto the internet. So usually the central repositories is something in which we can actually host our different kind of dependencies and the jar files over there. So local repository on the machine of the developer where the project material is saved. So all the particular dependencies jar file will be available on your local machine. Remote machine is the location where you can actually store all your particular dependencies, from where you can download these dependencies whenever you require it. So this repositories work similar to the central repository. Whenever anything is needed from the remote repository, it's first downloaded into your local repository and then it will be utilized. So if you feel that the dependency is something which is not there in the local, it will be first downloaded from the remote repository and then it will be utilized or will be referenced onto the local machine there. And central repository is refers to the Maven community repository there, where you will be able to see each and every dependency present on that repository. So Maven downloads the repositories from here in the local repository whenever they're needed or whenever required. All these dependencies are cached locally, from where it will be referenced in the next, or whenever we want to refer that, we will be able to do that particular reference easily on that part. So this is the way that how the three particular repositories or Maven repositories really helps us for performing various kind of automations as such here. Right now, what are the basic concepts of Maven here? So some of the couple of basic concepts which is present in Maven is, like, for the first time we have the project object model. So project POM refers to the XML file which has all the information regarding the project, how this particular project should be built up, how the different build process should be automated there. It also has a description of the project, details regarding the versioning. Versioning information is also stored as such in this XML file, in this particular POM reference file as such over here. The XML file is which is there in the project home directory. So Maven is something which searches for the POM file in the current directory. If it's able to find that particular POM file, so it will execute or it will proceed with the build step. Otherwise, it will halt there itself. So this POM file is very important because it will act as a kind of a build script, and primarily the Maven tool will be able to process each and everything which is configured as such in this specific XML file there, and according to that only it will function or it will proceed further. Right. Now, second thing is the dependencies and repositories. So dependencies usually refers to the Java files, so the Java libraries which we need into our particular project. So while working on the project, we may be having the dependency on couple of dependencies. So these dependencies we have to actually download or we have to actually refer. And once these particular information or these details are referred, so what will happen that we need to download these specific dependencies from the particular Maven repositories. So if the dependencies are not present in your local repository, then Maven will try to download it from the central repository and cache it into your local repository. But first of all, it will look on into the local repository, and if it is not present in local, then only it will go to the remote or the central repository. Then we have build life cycles and phase and goals there. So build life cycles consists of the sequence of build phases, and each build phase consists of sequence of goals here. Now each goal is responsible for performing a specific task. When a phase is running all the goals related to that phase, and its plugins are also used to performing the compilation, preparing the artifacts, downloading the dependencies, all different things being done by the plugins here. Then we have the build profiles. So build profiles refers to a set of configuration values. Now generally we have the generic build process for all the environments or all the particular code base there, but sometimes we do have some kind of a differences there. So that is where we can go for the profiles, because a specific profile can have its own configuration, and whatever it's required for the build process, we can have different configurations stored inside the Maven build script here. Then different build profiles are added to the POM files, and which enables the different build as such here. So depending on these profiles, we can actually decide that how we need to proceed with the build process and how the different kind of build automations needs to be performed here. Then a build profile helps in customizing the build for the different environments, so that also we can perform as such while performing or while working on the different components and the different management here. So a build profile is something which you can configure, you can utilize, and depending on that build profile, we will be deciding whether to proceed further or how to decide on that particular factor. So these are something which we need to take care, or we need to work according to which we can decide that how the specific configurations and specific automation needs to be performed here. Now usually when we go for the Maven there, so we have to use some couple of Maven plugins. Now the goal of using these specific plugins is to automate some of the basic stuff like compilation, creating the var file, creating the jar file. So when we are using the plugins, we don't have to configure the steps or write the steps that how these specific plugins should be installed or should be referenced. It's ultimately the internal configurations which we are looking forward or which we are using while working on these specific plugins. So you can download some couple of plugins using which we will be able to decide that how a specific goals needs to be achieved here. So Maven has its own standard plugins that can be utilized. So if want to go for a custom one, so you can do that, but pretty much you can go for the default one, and you can pretty much have some specific goals executed with the help of these build plugins. Now next thing is the Maven architecture. So in Maven, what happens that let's talk about the basic architecture of Maven here. So the Maven executable, when it's deployed, so it usually reads the pom.xml file, which is the build script here. Now once the specific pom.xml file is being read out, so it will process the components. It will download, or it will process the dependencies, plugins, life cycles, phases and goals, and even the build profiles. And if any kind of interaction is required, so it will try to connect to the central repository or a remote repository, and according to that it will provide the information and provide the details as such. So Maven repository is something which is very important because it's ultimately trying to connect to the Maven repository and try to achieve the various kind of automation here. So it's very important because ultimately it's trying to help us to go for the complete end-to-end build automation when we'll go for a specific POM based build automation. So Maven executive will read the pom.xml file, then download the dependencies defined into the pom.xml file, and that dependencies are cached locally from the remote or the central repository. Now then create and generate a remote report according to the requirement and execute the life cycles, phases, goals, plugins, etc. So it will process the pom.xml file there, and whatever the plugins and goals or the life cycles which is configured there, step by step each of them will be executed into a sequence here. Now let's talk about the overall build lifecycle of the Maven here. So what happens that the Maven build lifecycle is something which is a kind of a collection of different steps there, and this is something which is followed to perform a build automation for a specific project. So that there are pretty much 3 steps which is being done. So first one is the default, so it handles the project deployment there. Second, handles the project cleaning, which is a clean there, and then we have site, so it handles the creation of the project sites documentation there. So these are the 3 built-in particular life cycles which is available there at the Maven level, which you can utilize to perform a various kind of particular steps execution for your project. Right, so the build cycle has the different build phases or stages there, because when we are performing a build, a variety of things needs to be performed over here. So the first one is the compile, then test compile is there. So compilation is there for the source file, and test compile is there for the test cases. Test will execute the test cases, package will package the bundle, then we have the integration test to run the integration test cases, then we have the verify, then install goal is there, and the last one is the deploy, which is there to deploy the artifacts to the artifact tree. So all these things are the different phases and the stages which is being followed as per a specific build here. So during these builds, these are the different phases and the stages which we normally follow for performing the build automation. Now what is the exactly advantage of a specific Maven here? So that is something which we need to talk about, that how the particular automation needs to be done, or how we can actually go for the configurations where we feel that yes, we want to perform or we want to take certain benefits out of the implementation of Maven here. So for that, what happens that we have to see that the various kind of benefits. The first one is that Apache Maven helps manage all the processes there, such as building, documentation, releasing, and distribution in project management here. So the tool simplifies the process of project building. It increases the performance of the project and the building process altogether. And the task of downloading jar files and other dependencies is also done automatically. We don't have to indulge in any kind of download part as such manually over here. Right, and Maven provides easy access to all the required information. So Maven makes it easy for a specific developer to build a project in the different environments. So we don't have to worry about the environment, we don't have to worry about the infrastructure, nothing is required. Everything is available there inside this package, and depending on the particular, you can write the source code on one machine and you can pretty much do the build on another machine. And this is the reason how the build automation really happens on the first place, because the developer is writing the source code in one location and the same code is deployed onto the particular or built onto this Jenkins or any kind of build tool there. Right, in Maven you can easily add new dependencies, so you must write the particular dependencies in the POM file. So if you feel that you want to download some particular dependencies, so all you have to do is that you have to put that dependency into the specific pom.xml file there, and depending on that the execution will be really performed and executed as such here. Right, so let's talk about the demo now. So let's see that how exactly we can go for this demo and we can perform the various kind of automations. So this is the virtual machine which we have here, on which the Maven is already installed. So we can run like mvn. So Maven will be available as in 3.6.3 here. Now I'm going to run a particular command called mvn archetype generate here. Let me create a directory here, a temp directory, and to perform this activity over there. So mvn archetype generate. Now once we run that, so what will happen that it will download some of the binaries there, because ultimately what we are trying to do is that we are trying to generate a new project, like a Maven project. So a couple of particular plugins will be downloaded by the Maven executable so that it can achieve that particular execution. So we just have to wait for downloading all these values. Now here it's trying to give us particular attributes, like it's asking the different attributes over here. So what exactly we want to configure. So if you want to configure, you can provide that details, otherwise you can perform or whatever the setup you want to perform. Now here it's asking for the version, so which kind of version we want to follow. So I'm going to follow like 5 here, so I'll press 5. Then a group ID which is there, so it's basically a kind of a group mechanism, so I can say like com.Simplilearn. So that's the value which I'm providing here. Artifact ID, I can make it like a sample project or something like that. I can do, so that will be the artifact ID which is there. So version I am keeping the same only. So and yeah, so package same here. So I just want to create, so I'll just provide the value called yes and enter. So with this, what will happen, that a sample project will be created here, right? So whatever the artifact ID you provided, so according to that the project is created in this directory. So you have to go into this directory and see that what exactly the files are created there. So you have the pom.xml file. Now this pom.xml file, when I open, so you can see here that there are some attributes, like you can have the values related to what version or group ID you want to follow. So this is the group ID, this is the artifact ID. So this is jar file. By default you can change it according to your requirement, and this is the version, and if you feel that you want to do the changes to the name, that also you can perform here. So by default the JUnit dependency is added, but if you want to keep on adding your own custom dependencies, you will be able to do that. Now in this case, if you run like mvn clean install, so it will be considered as a particular Maven project. A pom.xml file is already there present in the local directory. So according to that, the execution of the steps will be performed, and according to that you will be able to get some desired values here. So ultimately in the target directory you will be able to see that some couple of jar file or a specific jar file is generated here. So you can see that in the target directory this jar file or this artifact is generated here. So this is a way that how we can actually go for a generic one, like a new particular project, and later on you can, depending on your understanding, you can keep on adding or you can keep on modifying the dependencies, and that's how you can get the final result there. So that's it for this demo in which we have find out that how exactly we can go for a particular project preparation with the help of mvn executable. So that's it for this demo. Thanks. Right, so that was the demo in which we saw that how exactly we can go for the Maven, and we can execute some build process related to Maven there.
Hey everyone, I welcome you all to this JUnit full course by Simplilearn. In this complete course, we will learn everything we need to know about JUnit and Mockito JUnit. We have Anuj to guide us through this journey. We shall begin with understanding the basics of JUnit and have a look at different aspects of JUnit. In these aspects, we shall understand the relevance and features of JUnit. Moving forth, we shall learn the working of JUnit with Java and Eclipse with the help of a hands-on demo. After we have a complete knowledge about JUnit and its working, we shall go on to explore Mockito. In Mockito JUnit, we shall understand what mocking is and how we can perform it. While we are at it, we shall know about the basics of stub and how to create it. To better understand the Mockito JUnit, we shall see all these processes and the entire working of Mockito with a hands-on demo. But before we begin, make sure you have subscribed to our YouTube channel and don't forget to click on the bell icon so you never miss an update from Simplilearn.
Welcome everyone to yet another topic on JUnit tutorial. Now in this one we are going to talk about what exactly is an JUnit tool all about, and how we can do various kind of test implementations with the help of JUnit. So let's talk about the agenda which we are going to cover here. Now in this one specifically we are going to talk about like what exactly is JUnit, what is this particular framework all about. Then we are going to talk about JUnit installation, how we can do the installation of JUnit and what are the different steps we can get involved on that. And then we are going to talk about like the features of JUnit, what are the different typical features of JUnit are all about. Then JUnit annotations we're going to talk about, and then JUnit in Java and the actual implementations, some tutorials or some demos on how to implement JUnit with Eclipse. So these are some of the main topics which we are going to cover all together over here as such. Now let's talk about what exactly is the JUnit tool all about, like what are the different things we can implement with the help of this tool here. So JUnit is basically a kind of unit testing framework which is there for the Java. So it's kind of a default offering for the Java programming language that we can use the JUnit for the unit testing framework for performing the unit testing. Now the main benefit of the JUnit is like it's using the same syntax like a Java programming language. So it makes it very easy for a Java developer to write and execute the test cases. So most of the times when the developers are going to work on the Java programming languages, so they prefer that JUnit as a default unit testing framework for them, because they get the language advantage, they get the easily integrations in the Eclipse. So those benefits helps the developers to decide JUnit specifically for writing the test cases and running the test cases there. Now whenever these test cases are actually being executed, whenever you add up a new piece of source code, so all the unit test cases will be again executed there every time when you run a new build. So all the unit test cases gets executed, but you also need to take care that if you are adding up a new functionalities, you also have to add the corresponding test cases to that. So increasing more and more code will be done by the developers, but at the same time you have to sync or you have to keep your test cases up to date also. And as a part of every build, each and every test cases will be re-executed every time. You're doing the build 5 times, 6 times a day. Every time the all unit test cases will be executed over there and the response will be given back. Right, now let's talk about what exactly is the unit testing. Now unit testing refers to the testing of the small modules or the small piece of chunks or the codes here. Now it's basically used to have the early identification of the defects and the bugs, because you cannot simply rely on the QA team to perform the testing and then provide the feedback. Whereas on the with the help of this unit testing framework, we can immediately get the feedback right away. Once we are running the test cases, immediately we will be able to know like these are the different test cases which we have got over here. Now the developers don't even have to spend more time on fixing the bugs and issues, because these test cases will help them with the easy and the fast feedback. So according to that, they can fix the bugs and they can take the decision whether the source code is working fine as expected or there is any kind of issues as such present with this one. So unit test casing is something which is very important from the developer's perspective also, because it helps the developers to understand that whether they have written a successful code or if there is any kind of scope of issues or bugs over here. Also, the successful unit test cases increases the overall confidence of the developers, because it increases the overall performance and the quality of the product also. So by having the successful executions of the unit test cases, developers can understand that yes, the source code is working fine as expected and there is no scope of bugs or any issues as such with this source code here. So that's the main benefit which we get with unit testing, that with this fast feedback channel, we will be able to take the decisions whether the source code is ready for the production environment deployment or not. So that's a main benefit which we get with the unit testing here. Now, of course, this can be done in 2 ways, manual testing and automated testing. Now, in case of manual testing, you have to do this thing manually within a manual tester or a manual testing approach. And in this one, you will not be depending on any kind of automated tool which can be scheduled or which can be executed in non-interactive manner. On the other hand, automated test cases is something which is used to be executed using the tool, and it is something which is being done so that you will be able to get the complete automation. There is no manual efforts which is required as such. You are going to have like complete deployment and automations being done as such in this case. So automated testing is something in which you will be giving more focus on the automation tools. You may be having one or a couple of tools using which you can write the automated test cases and you can perform the complete automation. In case of manual testing, it's quite less reliable because you are dependent on the a particular tester which can perform the testing according to his efforts, and it's quite time consuming also because you can only run the test cases for probably 8 to 9 hours per day. Whereas on the other hand, the automated test case is something which is quite reliable because it does not depend on a human requirement, so it can be done like 24/7, so anytime you can run those test cases, and that's the reason why these test cases are quite faster as compared to any other manual testing approach here. So JUnit test cases and the automated test cases really helps the developers and the QA professionals to test the source code much faster as compared to the manual testing. Now let's talk about the JUnit installation. Now, as part of the installation of JUnit, you don't require to install any exe file or any kind of program there. There are a couple of jar files which is required, which needs to be there into the class path, so that every time when you write some JUnit test cases, you should be able to refer those jar files, because without having those jar files into your class path of your project, you will not be able to run the JUnit test cases. So that's the only dependency you require. If you are running a Maven build, then these dependencies will be added up into the pom.xml file. If you are referring or doing the build from the Eclipse or doing the development from the Eclipse, then you have to put up these jar files into the class path of the project, so that these jar files can be loaded up and the JUnit can be referred over here. So the installation is pretty straightforward, but let's see what are the different steps we need to follow. Now, as a prerequisite of understanding the demo about JUnit, the first initial two things is like you require a JDK to be installed. Now you can download the JDK 8 over here from this Oracle website, and this is something which you can download for the Windows or whatever platform you have. You can pretty much install it for whatever platform is there. So for Windows platform, you can download for 32-bit and 64-bit both option over here, and once it's installed, so you should be able to use the Eclipse latest tool. Now all you need to do is that you need to go to eclipse.org, and there you can download the latest version of the Eclipse. Now these two main things which you require, because Eclipse will be required for creating the JUnit test cases, and of course a kind of IDE where you can run some test cases, JUnit test cases and all. And then Oracle is something which is required as a runtime for running the JDK also, and the JUnit test cases also, and Eclipse here. So that's a prerequisite which we got over here in this one. So I have already got these two things installed into my system, and I have Eclipse there. So let's move on to the Eclipse and see that how it goes on there. But before that, you also require the JUnit jar files, because in order to have a particular JUnit framework loaded up, we require some particular files, jar files over here in this case. So I can just search for JUnit 4 over here, and when you search for JUnit 4, so what happens, like this particular page will help you or give you all the details about the JUnit 4. Now you can go for the version notes of the different versions, but if you want to download, all you need to do is like you can say like download and install, and the moment you go there, so it will give you the details. Now there are two jar files which is required. JUnit.jar file is required over here. hamcrest-core.jar file, these two jar files are required here if you want to download it into the test class path. If you feel that you want to use a Maven based project, then in that case you have to specifically go for this dependency into POM file, and according to that particular version will be downloaded and will be referred over there. So these are the ways that how you can get the particular softwares, the required things into the place. So I'm going to put up these jar files into a location so that I should be able to get the particular details stored, and I can refer to them into my Eclipse. So I'm going to download this one here from the Maven Central. So I'm going to download this jar file, and then I'm going to go back hamcrest-core, so that also I want to download. Download jar. So these two jar files I have downloaded, and I will be referring these ones into my project because these are the ones which is being required into my project as such. So let's go back to the Eclipse and let's place these jar files into a location so that into my class path I can refer the complete folder with all these two jar files inside that. So let's go ahead with that. So let's create a particular new project over here. So we'll go for new Java project, and here I can give it like a simple one. A simple project name I can provide here, and JDK I'm using like 1.8, so that's the JDK version which I have utilized over here, and then finish. So this is the project which I have got like in the source directory. Now I'm going to create a simple file over here, a new class file over here. So I'll create it like JUnit class. So I'm going to create a class over here in this one, and of course I need to have a particular void main also over here in this specific class over here, because this is the initial class I'm trying to create over here in this one. I can create a custom particular methods also over here, but let's see like if we can execute or we can run some particular functions as such over here. Now I'm going to declare a function over here, public void JUnit method. So I'm just going to create a method over here. I'm just going to run a particular print statement over here. Executing JUnit test cases. Right now this is a kind of a method which is there, which of course I can run into my public void main, and this function will be executed, will be called upon over here. Now the thing is that right now since it's just a normal function, but the moment I convert it, like I have a @test mentioned over here, so what will happen, like this will be converted into the form of a test cases. Now of course, like right now there is no imports which is available there as part of this one, so you can see that the time I have added this annotation @test, I will be able to see like yes, add JUnit4 library to the build path is something which is coming up over here, or it's saying like add JUnit5. So whatever the library you feel that you want to add, you can do that, and that particular library will be added up over here. Now let's go for the JUnit4 library here. The moment I do that, what will happen, you will see some changes. First you will see the changes in the top saying that import org.junit.test. That's a first import, and second import will be like JUnit4. You will see like these two jar files is automatically being picked up by the Eclipse. Now even if you don't download these jar files, this is the main benefit of the Eclipse, that these are already a part of the plugins. You can see their paths, that these are already installed in plugins directory. So the moment you use these particular methods that you want to use the JUnit, these will be automatically imported over here into your system. Now you can just simply call this method into the main void main, and then the specific method will be executed as a form of test cases. So this is the mechanism that how you will be setting up the project. Initially you got the imports, you got the particular annotations configured, and with that the specific jar files will be automatically being added up into your class path. Whatever the jar files we added up, we downloaded previously, we can also have that added up into the custom class path. We can modify this build path of JUnit4 which is coming up automatically. We can just simply say right click, build path, and configure. So this JUnit4 we can actually import, we can remove it from our system, and we can add our external jar files also into the build path or the class path over here. So that depends upon you, that how you want to perform the customizations around that part. But yes, the particular main benefit of using the Eclipse is that it's already having the JUnit plugin installed. Both 4 and 5 version is installed. Whatever version you feel that you want to include, it will be included, and the plugins are already installed, so you don't even have to download the jar files manually. So that's how you will be able to do a very basic initial setup of JUnit, and how a basic project can be created over here in case of JUnit. In the upcoming demos, we'll see like how we can execute these particular test cases, and we'll get the response. We'll come to that point. So let's go back to the main content. Right, so that was the JUnit installation demo which we saw, and we saw like how we can put up or load the jar files related to JUnit into a class path, and we can resolve the basic features about the JUnit, about the test cases. Now let's talk about some of the certain features of the JUnit here. Now there are a lot of features which we get primary with the JUnit. Let's discuss about that one by one. So the very first feature about JUnit is that it's an open source network. Now it's something which is available as an open source to you. We have also seen the installation, so you don't have to really go for any kind of license or something like that. So you can do any number of test cases with this particular tool and this specific automation tool here. You can automate it into Jenkins. Nowhere you require any kind of license around this. So these can be easily integrated. These are already a part of most of the latest Eclipse installation, so you don't even have to configure these manually because it's already a part of your system. Right. Second is that it provides annotations. Now, main annotation we have already seen in the previous case, that when we converted a normal function or a normal method into the test method by using an annotation called @test. So it provides a mechanism to identify that which particular method is a test method and which method is a normal method according to our classes. So these annotations really help us to identify the methods also, and it provides us the flexibility that these particular methods are not the normal methods we need to execute. You need to run it in the form of test cases. So that identification is something we will be able to do with the help of these annotations here. Also, it provides the assertions to identify like what exactly the results are there, because definitely when we are running the test cases, JUnit test cases, we need to assert that what should be the value. So using the assert, we can actually compare that, okay, this method is giving this value. Suppose there is an addition method which is available there, which is giving like a plus b is equal to c. So c is like 5 plus 15 is 20. So with the help of assert, I'm saying like whatever the response I'm going to get from the function when I give the values a and b as 5 and 15, so that should be 20 value. So in the assert, I can hard code like, okay, this is the value, this is the response which I should be getting, and once the function is executed, I should be able to get this particular output as in 20 over here. So that comparison when you do, you will be able to understand easily that yes, when we are doing the assert, I'm getting the proper response, I'm getting the proper output over here. So assertion is something which is very important to compare the things, to compare the inputs which we are getting from the application source code. Next, it provides the test runner. So we can basically run the test runners over here to execute the test cases. So you can configure this within the pipelines. You can configure it with Eclipse and various automations during the build automations. Also, you can configure it. So that flexibility you will be able to get with these test runners here. And it also allows you to provide a better feedback channel, because it acts like a very good feedback provider, because the moment you are done with the development, you will be able to get an instant feedback. So the overall quality of the code is going to be increased in this case, and that's definitely helpful for you, because with this approach, with this JUnit framework, you will be able to get a quite faster and a perfect code writing tool or a quality tool which is available there. So definitely the overall quality of the code is going to improve with the help of this JUnit framework. And it provides the automations also, because these JUnit test cases are having the flexibility that you can configure it within the pipelines. You can automate it with the help of this framework, that you can completely help, or you can have a complete automated workflow with the help of this particular framework. And it provides you an instant feedback. The feedback channel is quite instant in case of this JUnit. Now let's talk about the JUnit annotations. We have already seen like the benefit of the annotation is to define or to provide the metadata about the methods to the different ones. So annotations also refer to the syntactical metadata added to the Java source code. So having a particular better feasibility and identification is also quite easy. So also the overall structure of the source code can be done in a better way, and the readability is also good when we talk about the annotations here. The biggest main difference between the JUnit and the JUnit 3 was the introduction of the JUnit annotations. So earlier, before JUnit 3, we were not able to identify like if this is in kind of a test method or this is a kind of a source method over here. So that identifications is quite easy after the involvement or the introduction of the JUnit 4 framework over here. Also, like this is something which is really helpful to us to see like how exactly we can overall read the overall source code, because you have so many source code there present to your project. So annotation should be able to help you to identify that these are the main portions, with these are the components which is part of the unit test cases, not the actual source code. So @test is something which is going to tell us that the specific method with the public void declaration can be run or can be executed as a test cases. This is not a simple method. This is not an application source code method. This is a test method over here. Now @before is something which is used to run some statement before each and every test cases executes. Maybe having some additional or initial connectivity is something you can do with the help of @before. @after is something which you can do after the execution of the test cases, like some statements which you want to execute after the test cases. So that's something you can do, or you can go with the help of @after. And @ignores is something which you can configure if you feel like during the test execution you feel to ignore some statement. So that's where you can use the @ignores there. So @ignores, @after, @before, and @test. These are the 4 annotations which is being used most of the time into your JUnit test cases. Right? Let's talk about some bit more. Now @before is something which is being used to execute the classes, some statement before even any kind of test class executes. So not only before executing any method, this is something before even loading up any kind of test classes. So before @before class is being used. Similarly, @after will be there to execute it after all the test classes. And if we have a timeout configured, so what we'll have that we will be able to set up a timeout while executing the test cases. So timeout value can be configured over here. And then if you feel like if you want to handle some exceptions during the test execution, so that's where we can use this custom annotations over here to have the exceptions handled or configured over here in this one. So these are some of the very important annotations which is available there on the JUnit perspective. Now let's talk about some another demo on JUnit testing in the Java, like how we can pretty much configure the test cases in JUnit for a programming language called Java, and how we can get along or get execute those things. So now we are going to see like how exactly we can go for the execution of some Java files onto a command line, and how we can using the command line run some execution of the test cases. Typically we do it from the Eclipse, but from the command line also we are going to see like how exactly we are performing the setup and the executions over here. Now what we really need to do is like we need to see like how we can proceed further with the execution. So I'm going to open this particular Java file over here, so to get a better understanding here. So I'm going to use the org.unit JUnit class over here in this case. So we are having like couple of imports. These are the standard imports, so you can do like org.unit JUnit.star also if you don't want to go for the specific imports here. Now here we are going to create a test unit as a sample class, and in this one we got the void main over here, which is the main portion of any kind of class here. The only thing which we got over here is that we have created a test method over here called test print message. So we are assigning a value called message a variable over here as in Simplilearn. Now what happens, like we will be able to do the assert equals over here, that if the value of message is like Simplilearn, So it will be able to help us with the proper output, and there will be no errors as such over here. So everything will be smooth, and that's what we are trying to execute over here in this case. And we are running into the null void that these are the test cases we want to run or we want to execute over here. Now all we need to do is like we need to compile this one. We really need to compile this test cases over here, this file, and then we have to run that one. So for that, let me open the command prompt. So now in this case we will be using the javac command prompt here, and we will be copying the JUnit into the class path, so that we will not be able to get any kind of class not found issues over here. So test unit JUnit.java we are going to run. So if there is no exceptions as such, we will be able to get no errors here. Now I'm going to run the particular class file with the help of Java command, because javac is to convert the .java file to the .class file, the compile format, and then in order to run the .class file we have to go for the Java command line here. Now this means that there is no issues as such with the test cases, and everything is working fine as expected over here in this one. So the assert equals is going to help you to identify that if the execution is proper, and let's say like if we put up some content, like some different content over here in this assert equals. So I'm going to again execute this one, so that I will be able to see like if what will happen, that if this message value and this value does not matches. Like in normal situations it will say like, okay, the particular output is going up and there is no errors as such, right? So let's see like what exactly it will happen, that if we go for the executions, like if we save this file in such a way that we are providing some wrong inputs, and what will happen to our assert equal over here. So I'm going to again compile the file here. So again a new class file will be available, and this time I'm going to execute this class file again over here in this case. And the moment you did it, the assert will give you the comparison over here, saying that there is a failure of the comparison. Why there is a failure of the comparison? Because according to the code base, it was expecting the value called Simplilearn, but it simply got the value called Simplilearn 1.2, which means that your test cases over here got failed down. So this is the real way that how you will be providing the comparison, like what you should be putting up to the application and what kind of response you should be getting in return of that. So that's where you will be able to provide a proper and a complete comparison here, which will help you to understand that what exactly output you're going to get over here. And that's where the output will be completely available to you, and you will be able to get a proper output as such here. Right, so this is the way that how the comparison will be performed, and how you will be able to see like these two comparison being done here as such. So this is the way that how you're going to run the test cases in the form of the from the command line here. So let's go back to the main document. Right, now the next one which we got over here is the JUnit test cases using the Eclipse, because from the command line we saw like using the command line we can do, but we got like so many test cases which is available there, so it's not easy for us to run those one by one. So we will be doing it through the Eclipse, so that we can see like how the execution can be really done, and we can get a hold of those particular components. So let's go back to the Eclipse, and this time we are going to run the test cases in the Eclipse here. Now let's create a new project again here. JUnit project, right, and finish. So a new JUnit project will be created. Now in this one you can see like there is no executables libraries for the JUnit, but you can include it now also, but I'm going to do it later on. So I go for the JUnit project class. Right, so this is a kind of a test class here, so I'm not going to put the null the public void main over here in this one. So finish. Now in this case what I'm going to do is like I'm going to replace this content over here, so with this particular ones, and going to have some basic code base added up over here. So I'm going to import some particular JUnit libraries over here. So over here like org.junit, I'm going to import these ones, and I got like this class over here JUnit project. So I just have to rename it a little bit so that it can be the name of the actual class name here. So that's fine. So everything is fine, but the only thing is that we are getting some failures and problems over here because it's not able to identify these specific JUnit related executables like the functions and the methods. For this one, again, the previous case, you have to do the particular addition of the library to the build path so that you will be able to have like these automatically resolved over here in this one. Right, so you can see now that JUnit 4 started reflecting over here in this case, and you did not got any kind of errors now over here in this one. So you can simply save this, and now you are good to go for running the executions over here. So you can simply say like right click over here, run as, and JUnit test. And when you do that, on the left hand side, you will be able to get a little bit different viewpoint over here, which says like, yes, test underscore JUnit is something which is executed perfectly fine. If for any reason, let's say like I change the value of string 1 here as in string 1, just an typo error I'm trying to do here so that I can show you that how the test cases really fails. So assert equals is basically helping you to find out that if the comparison between the two attributes is correct, that means that the inputs which we are putting up and whatever the output we are getting, it's both the same here. When you do that, you will say like there is a failure over here to the test cases. Now I'm seeing the failure trace over here, so I'll just move this one to the console view. So it says like it should be like string, but I got like string 1 over here, which is causing the problem here. Because of the typo error which I did, the whole execution of the test cases got failed. So I'm just going to revert my changes back here and again run the test cases. It will all be okay right now again over here. So that's the main reason that how the execution really happens and the overall mechanism and the system can be implemented over here in this case. So that's how we basically go on and we execute some JUnit test cases here. Now in this one, we are going to talk about like how exactly we can use both Mockito and JUnit here to go for the unit testing. But before even talking about these two tools here, let's focus on to understand like what is exactly a unit testing here. Now there are various kind of testing which is actually available into our particular industry and into our software testing world there. But yes, there is a very important scope and a position of the unit testing here. So unit testing is something which we also call is an kind of a component testing, is actually a software testing technique in which single component of a software is being tested. We are not talking about like how exactly our application is going to interact with other applications and it's going to interact with it's not a complete full-fledged application testing. So in this case, what we are looking forward is like this is something in which we are focusing on how exactly we can only validate and test out a single component. A single component is what we are basically talking about over here, right? And when we say like how exactly we want to perform, we want to achieve the setup here. So this is the main mechanism, or this is the main kind of testing which an individual developer performs at its own end to see like whatever the piece of source code he's writing, whether it's working fine as expected or not. So this is where we are able to see like exactly what we are trying to achieve here and how a full-fledged or a basic testing validation can be done. Now the main objective of this unit testing is to pick a unit, a very basic small unit of the source code, to verify it so that it will be the moment the developer develops the code base, at that moment of time only this thing will be validated and will be fixed on. So this is something which we are looking forward over here to achieve, like how the automation needs to be done and needs to be achieved over here in this case. Next thing is, what exactly is the mocking here? Now we talked about like JUnit here, but next one is like what exactly we are talking about as in a particular mocking over here. Now when we talk about mocking, so we are basically trying to understand like what exactly we are performing, for what purpose we are going for the mocking process here. So mocking refers to the development of objects which are mock or clone of real objects. They are not the exact objects, or we can say like that's not the exact scenario which we are going to implement, but it's kind of a duplicate, or it's kind of a temporary mocks which we are creating so that we will be able to get it implemented. So mocking is something which is kind of a reference or a kind of a clone of an existing or a real object here. So in this technique, what happens that the mock objects are being used instead of the actual real object. So it's not like we are directly or we are going to access the exact real objects over here. So we are talking about like using or going through the specific mock objects over here in this one. So that's where we are putting up the main focus, right? And mock objects actually give a particular output for each and every input. Whatever the inputs you are going to provide, you are going to get a particular desired output. So the mocking is going to process all these inputs, give you the desired output, and to understand like how the implementations and the setups can be done, right? So for this kind of mocking process, mocking a framework is something which is quite popular. So Mockito is one of the framework which is available there, which is desired for this kind of work or this kind of approach only, where we are trying to see like how we want to perform a mocking implementation over here, right? So let's talk about the Mockito tool, because that's a primary tool which is there for the mocking activity, and we have already focused on like mocking is a process in which we are trying to process the mock objects rather than the real objects. So that's kind of verification here. So Mockito is a kind of a Java-based framework which is being used for doing the unit testing on the Java application. So if you have written the source code in Java programming language, then Mockito is a kind of a framework for you. So this is something which is helpful for validating the development of the kind of application source code here. So you will be able to validate that how your application is going to behave and it's going to work. So when we talk about Mockito over here, so it basically gives you a variety of information, like what exactly approach you are looking forward and what is the end result you are trying to establish over here. So that's the main focus of the Mockito which we are going to get, and it's for the basic approach over here. So Java Reflection API is basically used internally to generate the mock objects. That's a core component, you can say, like the backbone of this whole mocking approach over here. Mockito is used to simplify the test development by mocking the external dependencies and using them in the source code. So it's kind of a blending in the whole environment there, so that your application is going to get the desired environment, and being in that environment, it can start processing the inputs and then give the desired output accordingly. So this is what we are trying to implement as such over here, to see like how exactly this mocking can be done, and Mockito can really help us in this approach here. Right now, what are the different prerequisites which we require to learn Mockito? So we basically need two important prerequisites over here. First of all, we need the hands-on experience in Java programming language. So Java programming language is very important, because Mockito is something which we can write in the Java programming language. It uses the Java programming language syntax. So that's a very important thing there to be considered. And second one is the JUnit framework implementation. So these two things we basically require for performing a complete full-fledged Mockito approach or mocking testing over here. So these are the two important components, or you can say like the two core prerequisites which we need to process before going for the Mockito implementation. Right. So let's go to understand like how Mockito framework can be configured in Eclipse, because Eclipse is the prime tool for creating the development source code for the Java programming language. So we need to see like how we can configure the Mockito framework over there, because that's the single IDE which will be utilized by the developers there. So let's go ahead in that. In this demo, we are going to talk about like how we can create a simple JUnit and Mockito related program over here, so that we can have a basic project created, and we can also have some basic program created on that part. So let me open the Eclipse here. Now in this one, what I'm going to do is like, first of all, I'm going to create a Maven project. Once my Maven project is created, then I'm going to include Mockito and JUnit related dependencies. And after that, I'm going to write a very small source code just to see like how exactly our dependencies are getting resolved, and my source code, which will come up as an error earlier, will come up as an healthy over there. So all I have to do is like, I have to just right click over here, new, and here I need to go for project. Like I want to go for a particular Maven project here, so I can expand the Maven over here and go for Maven project. Here it will basically ask me certain values. I want to use the default workspace location, so I'll just say next. Then I want to have it I want to go ahead with this overall process. So these are all projects, like what exactly architecture type you want to go. So I can just go for the default, whatever is selected, I can just go with that. And here I will be providing like what is a group ID. So I can provide a group ID called com.simplylearn, or depending on your organization you can actually provide it. So here I can provide Mockito, and the version will be like this, and this is the same way like how the project will also be created. The package will be created in case of the project here. So then I'll just say finish, and on the left hand side I will be able to see like my specific source code which is available there. So this is something which is going to come up over here. So it's actually trying to resolve some of the particular options, like some of the the components, like test executions, those are required over here. So I'll just go for this particular resolution later on. Right, so I'll just open this pom.xml file here, and this is the pom.xml file, right? So it's basically looking forward for certain changes like this jar file. So this jar file is not actually available over here. So once I ran the build and those kind of setup can be done, then it will be able to download those particular dependencies. So if you right click on this one, you will be able to see that particular Maven build option here. So I can just run the Maven build, or I can just run the Maven clean here. So according to that, the Maven will be downloading certain plugins, and it's just trying to do some particular process over here. So on the left hand side, the source, main, test, the same package which is available there, the same packages is coming up there. So app test is available there. So here the test is being available. Here I can see like some couple of JUnit related test cases is already being there. Like I created a kind of a sample project. So in here, a basic Java and a basic class file or a test suite is already being available here. So all I have to do is like I have to just try to see like if I can go ahead with this executions there. Now it's using like JUnit 3.8.1 over here, so I can definitely go for a version which is higher, like around JUnit 4 or 5 there. But let me try to do a clean build over here, Maven build over here, so to see like if it really works on there. So what are the goals I need to do? I need to go for the goals called clean install. So that's a goal which we need to do here. So MVN will automatically be resolved there, but clean install is the goal which I want to look forward over here. So let's see like what it really happens. So it's going to download some couple of plugins, whatever the plugins I'm trying to provide here. Some dependent plugins will be downloading. So all that stuff will be downloaded. This is the first time we are running there, so that's why it may download some little bit more jar files than expected ones. You must have seen like these are all jar files. It's not like something we are using into our project, but these are kind of jar files which is being used by the plugins, by the Maven itself. So for that purpose, it's actually going to that particular level. But once these are cached up there, next time if you do the run, if you do any kind of builds there, you are not going to see all these entries. So let me rerun the build here to show you like how clean the output would be there. So I can just go for clean install again and say run, and this time the output which will be a little bit less there. So in this case, as you can see, if I expand the output, so here first of all it ran, like it performed the clean activity, then it compiled my source code here, it also compiled my test cases here in this one, then my test cases got executed over here. So you can see like it's something which got executable over here. So this is the test which is available. I can click on that and I can see that, and after that it went on and prepared the final artifact here, which also means like it performs both the compilation and the test cases execution. And this is what we are doing in any kind of Maven project, and on top of that I'm using a JUnit related frameworks. So this is a mechanism where we can have some dependencies, like I can go for JUnit here, I can increase the dependencies, I can try out the build, so all that stuff I can do here, right? And one more dependency which I can include is of the Mockito here. So I can include the Mockito related dependency also over here, so that we can see like how exactly the response is coming up there. So you can see like it's when I go for the resolution over here, like clean build, clean install, so I can just go ahead with this. So this time it's actually going for the Mockito one. So you can see like all the steps has been executed and we have got the end result. So the build is successful and I have got the test cases also. So this is a test file where I'm actually loading up some JUnit related executables there, so I can just go with that and whatever the activity assert we are using over here, so using which we can do the comparison. So this is a way like how a basic project can be created in Maven, and on top of that how we can manage the dependencies for Mockito and for JUnit here. Right, so that was a demo in which we talked about like how exactly we can configure Mockito into our Eclipse here. Now let's see like when exactly we require the Mockito to be implemented. Now in this case, what happens like when exactly you feel like you need to have a Mockito implementation, or how we can go for the Mockito implementation altogether here. So for example, when a component is to be tested, or a single unit needs to be tested, so this unit or component actually depends on some other component, which is kind of in development process, or maybe some other developer owns that component, and you are not exactly validating that component, you are validating your own component. But since it's actually dependent on other component or some other unit of the whole application, so that's the reason where you may not be able to perform the end-to-end testing. But yes, with the help of Mockito, you will be able to get the mock objects so that you can perform the testing there. You don't have to held up with that other component dependency. You can resolve all these dependencies like that, and you can just proceed further with your verification and your implementation. So this is the main benefit which you get when you talk about the Mockito, so that you can see that a full-fledged understanding like how exactly these different components are going to be processed here. Right, and when there is any kind of concern, like if you know, like if you feel like there are some infrastructure components which is making the testing impossible, so in that case also we can use the Mockito to mock some infrastructure components so that we can proceed further with the validation and the testing here. So all the hindrances and all the problems which we normally face when we talk about the implementation, all those things can be really implemented with the help of Mockito here. So that's a main benefit which you get over here in this one. Now let's talk about the next concept. So the next concept which we have is what exactly is a stub. Very important concept here. So stub is a kind of object which holds up a predefined information, a predefined data. We cannot do a kind of a dynamic verification in case of unit testing, because we have to limit the scope of testing. We are putting up some inputs over here just to see like how our application is going to behave. These predefined data will act like inputs, and the test cases are going to process these inputs and give us the desired output. So these outputs we will be then analyzing to understand that how our application is going to behave, or in other terms like how application is reacting to these inputs, so that we can get an end-to-end desired output as such here. Also, it can be referred to as an object that looks like exactly a carbon copy of a real object. Of course, it's not a real object, it's a kind of mock object over here in this one, but it will give you the exact different details, or you can say like the exact output as such over here in this one. So that's a main benefit which we get with the stub, that it helps us to get a mock object instead of the real object, so that we can get ahead with the testing and we can get all our environment for our test executions there. Right, and stubs actually they can actually return the specific output here, like whatever the output you require, so that will be returned over here. Whatever the inputs you provide, that is going to be processed by this one, and the desired output will be provided to you over here in this one. Now these stubs are used to reduce the complexities, right, so that occur while creating the real object. So that's also the complexity which is going to be reduced when we talked about the these specific stubs as such here. So whenever we talk about the stubs, we talk about the implementation. So this is where the complexities get reduced when we talk about the replication or the mocking of the real objects here. Right, so let's talk about like how we can see the stub in real action so that we can get a better understanding, because from there we will be able to know like what is the main importance of stub in the whole mocking approach here. So let's go ahead with that. In this demo, we are going to talk about like how we can create some prerequisites for testing out a stub here. So I'm going to create a required Maven project and a couple of class files over here to make a kind of environment so that we can test it out the stub implementation in Mockito. So first what I need to do is like I need to just go ahead with a Maven project. So Maven project is what I need to create. A very basic project I want to create over here. You don't have to do much of the changes, like not much things you need to talk about over here. So the package direction, I can make it like okay, I just want the particular package. If you don't want to have the package and you would want to directly store the source code in source main Java, and you want to put the class directly over there without having any kind of particular COM and all that stuff, so you can do that also over here in this case. So that will be much faster. So then you can just go for the finish here, and you will be able to see like a project created, like a source main Java, then this particular package name is there, then source test Java is also there. So here is the test file, here is the main file. I can go ahead with this one, I can create a file over here. You can pretty much do that stuff also. So or you can change like this existing one also. So what I'm going to do is like I'm going to create a new class file here. So I'm going to say like okay, create new class file, and in this one I'm going to put the particular class name and a specific content. So let's see like how exactly we can go. So we can go for a particular class creations as such here, or we want to create so one class and one interface we want to create, so that we will be creating over here. So I'm going to create an interface here, right? So to service, so that's the interface name which I'm trying to provide here. And in this one I'm just pasting the content. So this is already configured here, so you just have to configure like this, right? So then I'm just going to resolve this one. So the java.util.list is also resolved. So this is the to-do service.java which is available there. Now what I have to do is like I'm just trying to create it over here, and I'm just trying to create another class file over here in this one, so which is like my to-do business IMPL over here, which will be using this interface, right? So I'm going to create a particular class file in this one, and we are going to create it. Okay, great. So in this one again I'm going to paste this content. So I have to just sync this one. So this is what, so I have to just rename it a little bit of this one. So I have to just rename as an particular this as a 2 over here. Great. So now I'm pretty much done here. So whatever the imports are required, I can actually go ahead, just this delta I want to remove it, and here we go. So we are creating a particular to-do service mechanism over here in this one. So we are also talking about the list here. So these list I can go for the auto resolution here. So I'm just going to save it, and then I'm going to see like for to do here. So to do is something which is coming up as a particular service here. So a little bit changes in this interface also. So I can you just have to sync it on the names. So whatever name you are using, so that you need to change over here in this case. So here also in to do service I have got it renamed. So that's where it got successfully resolved. And as far as the error list is confirmed, so I can just import that also. So I'm just done here. So if you by chance change this class name, then you change the Java file name also accordingly there, so that you will be there in proper sync up over here. So that's something which is available there, which we can use to see like how the implementation can be done, and that's a basic output which you're getting over here. Now this is where we have got all the required source code available there when we will be testing out the stub. So at that time we can actually use these one interface and one class over here. So this class is basically going for the interface call over here in this one, and that's how it's going on the implementation. So we'll come back during the testing, during the verification of this stuff. At that moment of time, this will act as a kind of basis for us here. So this is a kind of basic structure that how you create a basic program or a basic source code over here in this one. So what I'm going to do is like I'm going to just create these stubs over here in this one to test it out, to validate that the things there. So last time we created the Java source codes there. Now the stubs we will be creating over here in this one. Then we are just trying to create, first one is for the to do service. So to do service stub. So that's the name which I'm going to use, and just finish it off. And I'm just going to put the content over here. So just in order to try out the particular matching over here in this one. So to do stub is what we are trying to implement. So that's what we are going to see here. So I'm just going to remove this mechanism. So I'm able to see like all the imports is working fine. In this case, we are just trying to put some dummy information. So you can see like this is the array. This is the array list content which we are trying to provide over here in this stub. So we are basically trying to understand like how in the mocking activity we are trying to mock some particular inputs here, so that my stubs will be able to pick those up and they will be able to return those there. So that's what we are trying to do here. Now as far as this stub is configured, this is done. So we have to go for another stub here which will be there for the to do business IMPL. So we have to create this one for that particular implementation. So we have to put the content over here in this one to put the do business IMPL stub here, right? So I'm going to paste the content here just to match up the things. So I have to just put this content here. So I have to just rename this one, because even if we create some file, sometimes we may have to rename it. So that, keeping in mind, I can just put this one here and say okay, and I'm just going to remove this component here, and here we go. So we have got like these components, like this is something which is available there. We have got the implementations which we are trying to do. We have got to do service and to do service stub both here, but these are the kind of wrong interfaces. So ideally my interfaces is com.Simplilearn.stub. So that's where we have got the particular to do service over there. And similarly here also we have got the particular ones which is available, so which is also there in the specific com.simplilearn.stub.todo service stub here. So this is a mechanism where we will be able to find out. Even if I don't give this import, that's totally fine, because I'm already there in that package, so I can just refer it from there. And we also have the JUnit related ones which is available there. So we are getting the errors for the JUnit components over here in this case. So we also have the pom.xml file here in which my JUnit is being utilized. So in this one we are basically trying to use some references around the JUnit here, so you can get it on board on that case. So I can just try to run on the particular Maven build here to see like if all the dependencies are getting implemented, so that we will be able to download some required dependencies. So clean install, again I'm going to just refer it over here. I can just run the specific test also, like if I feel, but I'm just trying to download some couple of components over here in this case. So if there is any kind of issues which you're getting during the execution, so you will be able to see over here, for instance like org.junit does not exist over there, right? So since these packages are not downloaded or not installed, so that's why you're getting the issues as such over here in this case, right? So these are the references which is available there. I can just go ahead and import some of the JUnit related ones in this case. if I feel like I want to run it, so I can run this Java file also over here. This file also I can run it over here, right? So those are different options which is available, which we can utilize in this case. So I'm just adding the JUnit 4 library so that my all references related to JUnit should be resolved here. And the moment I picked up that one, you can see like all the errors related to JUnit is gone. Now I can run my build here to see like if it's getting successful. So this time, okay, so it's going for that particular mechanism, so I can change the specific version as in 4.0. let's see, like it's getting resolved, so it should be able to download that particular artifact. So I just have to find out that what is the version, what is the latest version we want to provide, and according to that the artifacts will be there and it will be executed. So there are some cases when we are using the default mechanism of creating a JUnit or a Maven project in Eclipse. Sometimes it actually uses an older version. So it was using 3.8.1 version, which is old version. So I'm using 4.0. So this source code is actually prepared according to 4.0. And the moment I started using that, the moment I tried on that one there, so you can see like here it got executed, like both the test cases got executed over here. I have got the response over here in this one, like these two test cases is being provided over here. So test run is 2. There is no failure, all good, and then ultimately it went on to the jar file preparation here. So this is a way like how the stub is actually going to particular it's going to call the particular specific classes, but yes, in this case we are just trying to input some values, some static values, which is not the real objects, but it's kind of a mock of an real objects. And that's how we are going to continue with our test cases, just to see like some inputs, if they are not there, we can still go for the testing and we can do the verification here. So this is a mechanism like how we can test out a stub to go to see like to understand like how the overall mocking is going to happen here. So that was the main implementation on how the stub can be implemented in the whole process, to see like how exactly we can go ahead with that. Now the next demo which we are going to talk about is like how we can full-fledged implement the complete Mockito code here, so that the end-to-end implementation of the mocking of real objects is what we can get over here in this one. So this will give us the complete insight about this whole process. Now first we will be creating a specific we are taking up a stock inventory kind of example over here. So we are going to create a Java file over here which is named as stock.java. So I'm just going to create a class file here called stock, and in that case we will be providing the content here. So I'm going to create a stock class which is having certain methods, certain functions. Stock is the main function which is available there. Now we have to create a particular interface which is going to be used to get the stock there, and then ultimately at last we will be getting a one test file which will be testing out this thing, the communication, see like if the Mockito is getting passed or the test case is getting passed or not. So this is the class file which is available there. Get stock ID, set stock ID. So basic getter and setters are being used over here in this case. So now I have to create a particular interface here with the name called stock service. And in this case I have to call the get price over there. So get price is basically configured over here in this one, right? So we are going to just call upon on that to see like how exactly it goes out there, right? So we will be utilizing this one. So this is the interface which is calling up the class called stock.java. Now once the stock main class and stock service or stock interface is being created, now we have to create a particular portfolio class here. This portfolio is a kind of interface which is going to consume this specific stock here. So portfolio class is what we are going to create here. So I'm just going to use it, and it's using some list operations. So I'm going to just import the java.util also, so that these can be imported. So These are some couple of activities. Like under this one, we are also calling up the stock service interface, so that can be calling up the stock internally. And this is kind of a business logic which is happening. So portfolio.java is kind of a business logic, business layer, where I'm just trying to call the main class there to fetch the details through an interface. And in this one, we are basically doing the all processing, like whatever the activities I'm trying to do. So here I'm doing the processing about the data here. Right, so this is what we have from the source code perspective. Now we will be moving on to the test cases perspective, where we will be writing a test file to do the mocking over here and to get the stocks and try to do some verification. So now I'm going to create a particular portfolio tester here, which will be testing this specific portfolio here. So that's what we are going to do, right? So it's going to use some of the Mockito related jar files here, and since we already have those dependencies, like we already got those added up to our pom.xml file. So, and these are also being shown up as an Maven dependency here. So both 4.0 and this Mockito dependency is there in the Maven dependencies, and that's why we are not getting any errors for these imports here. And we are getting some list related errors, so let me import those also, and we should be fine by now here. So as you can see, like here we are, when we are doing the verification, right? So using this portfolio tester, we are actually inducing some stats. So here you can see, like we are doing some setup. We are calling that stock service over here, so that we will be able to call upon, or we will be able to get the information. And here we are actually putting up some content. So the whole idea why we are putting up this content, just to have the implementation. We are just trying to replicate real objects here. These are not the actual real configurations or real information which we are getting from the end users, but these are the dummy informations or the dummy data which we are trying to provide here. And depending on that, we will be able to get like how it's going on there. So we are basically trying to call a function called tester.setup there. Tester.setup is what we are trying to call upon over here, which will set up the initial information. And then we are calling the test market value. So my test market value will basically give me a pass or fail kind of result set here, so that depending on that I can decide that whether it's successful or not. And this test market value, only here we are putting up some dummy informations, and against these dummy informations the test cases will be executed. So let's just run it. My build is already success, so I don't have to run it again there. So what I need to do is, like, I need to go for this portfolio tester.java here, so that I will be able to get the results. And here we go, we are getting the pass output over here in this one. Right, so this is what we are trying to do, just to see like how the implementation should be done there. I can go for a negative scenario, like where I can just a little bit modify something over here in the output, and I'm just trying to change a little bit of specific output. So that's what I'm trying to do here. So I can definitely go and see like if this is something going to process properly, or is there any kind of problem which we are getting over here. I can also remove this decimal value just to see like if I'm getting successful over here or not. So I'm just running the test cases again, and here we go, we got the response as in failure, because the expected thing is not coming up, like whatever we are returning. So that's where the failure, it's going for the failure. I'm going to roll back my things here and see like if it's again getting success or not. So yes, here we go, we got the pass success over here, the pass status over here in this one. So just like that, you can actually mock the objects, you can put some inputs, and according to that the responses will be coming up there, and you can go ahead with that particular mechanism. So this is the way that how the things really gets moved on when we talk about the Mockito, and how we can mock the real objects, and we can test out our application here. So that's what we do with the Mockito here. So that was a complete Mockito code, or you can see like complete demo over here, like how the overall process really gets implemented over here in this one. Right, now what are the different benefits of Mockito? Let's process that one by one. So the main benefits of Mockito is, like, first of all, we'll get started with the very first one is like the no handwriting. So that's the very first benefit which is coming up over here. Now second one is the object creation. Third one is the safe refactoring. Then we have an exception support benefit which we get over here. Then we have got like the annotation support which is available there, and then the order support. So these are some couple of benefits which we got over here to completely understand like how exactly the particular Mockito can be really achieved over here in this one, right? So this is the real benefits of Mockito here.
Hello and welcome to continuous integration tutorial using Jenkins. My name is Chidanand and I am with the Simplilearn team. Today let's get started with Jenkins. Jenkins, in my opinion, is one of the most popular continuous integration servers of recent times. What began as a hobby project by a developer working for Sun Microsystems way back in early or mid 2000s has gradually and eventually evolved into very powerful and robust automation servers. It has a wide adoption since it is released under MIT license and is almost free to use. Jenkins has a vast developer community that supports it by writing all kinds of plugins. Plugins is the heart and soul of Jenkins, because using plugins, one can connect Jenkins to anything and everything under the sun. With that introduction, let's get into what all will be covered as a part of this tutorial. I will get into some of the prerequisites required for installing Jenkins, post which I will go ahead and install Jenkins on a Windows box. There are a few first-time configurations that needs to be done, and I will be covering those as well. So once I have Jenkins installed and configured properly, I will get into the user administrative part. I'll create few users and I will use some plugins for setting up various kinds of access permissions for these users. I will also put in some freestyle jobs. Freestyle job is nothing but a very simple job, and I will also show you the powerfulness of Jenkins by scheduling this particular job to run based upon a time schedule. I will also connect Jenkins with GitHub. GitHub is our source code repository where I've got some repositories put up there. So using Jenkins, I will connect to GitHub, pull up a repository that is existing on GitHub onto the Jenkins box and run few commands to build this particular repository that is pulled from GitHub. Sending out emails is a very important configurations of Jenkins or any other continuous integration server for that matter. Whenever there is any notifications that has to be sent out as a part of either a build going bad or build being good or build being propagated to some environment, and all these scenarios, you would need the continuous integration servers to be sending out notifications. So I will get into a little bit details of how to configure Jenkins for sending out emails. I will also get into a scenario where I would have a web application, a Maven based Java web application, which will be pulled from a GitHub repository, and I will deploy it onto a Tomcat server. The Tomcat server will be locally running on my system. Eventually, I will get into one other very important topic, which is the master slave configuration. It's a very important and pretty interesting topic where distributed builds is achieved using a master slave configuration. So I will bring up a slave, I will connect the slave with the master, and I will also put in a job and kind of delegate that particular job to the slave configuration. Finally, I will let you know how to use some plugins to back up your Jenkins. So Jenkins has got a lot of useful information set up on it in terms of the build environments, in terms of workspace. All this can be very easily backed up using a plugin. So this is what I'm going to be covering as a part of this tutorial. Jenkins is a web application that is written in Java, and there are various ways in which you can use and install Jenkins. I have listed popular 3 mechanisms in which Jenkins is usually installed on any system. The topmost one is as a Windows or a Linux based services. So if at all you have Windows like the way I have, and I'm going to use this mechanism for this demo. So I would download a MSI installer that is specific to Jenkins and install this service. So whenever I install it as a service, it goes ahead and nicely installs all that is required for my Jenkins, and I have a service that can be started or stopped based upon my need. Any flavor of Linux as well. One other way of running Jenkins is downloading this generic WAR file, and as long as you have JDK installed, you can launch this WAR file by the command, opening up a command prompt or shell prompt if at all you're on Linux box, specifying java-jar and the name of this WAR file. It typically brings up your web application, and you can continue with your installation. The only thing being, if at all you want to stop using Jenkins, you just go ahead and close this prompt. You either do a Control-C and then bring down this prompt, and your Jenkins server would be down. Other older versions of Jenkins were run popularly using this way, in which you already have a Java-based web server up and running. So you kind of drop in this WAR file into the root folder or the HTTPD root folder of your web server. So Jenkins would explode and kind of bring up your application all user credentials or user administration is all taken care of by the Apache or the Tomcat server or the web server on which Jenkins is running. This was a very older way of running, but still some people use it because if they don't want to maintain two servers, if they already have a Java web server which it's being nicely maintained and backed up, Jenkins can run attached to it. Alright, so either ways, it doesn't matter however you're going to bring up your Jenkins instance. The way we're going to operate Jenkins is all going to be very same or similar one, with the subtle changes in terms of user administration if at all you're launching it through any other web server which will take care of the user administration. Otherwise, all the commands or all the configuration or the way in which I'm going to run this demo, it is going to be same across any of these installations. Alright, so the prerequisites for running Jenkins, as I mentioned earlier, Jenkins is nothing but a simple web application that's written in Java. So all that it needs is Java, preferably JDK 1.7 or 1.8. 2 GB RAM is the recommended RAM for running Jenkins. And also, like any other open source toolsets, when you install JDK, ensure that you set in the environment variable Java home to point to the right directory. This is something very specific to JDK, but for any other open source tools that you install, there is always a preferred environment variable that you got to set in, which is specific to that particular tool that you're going to use. This is a generic thing that is there for, for any other open source projects, because the way open source projects discover themselves is using these environment variables. So as a general practice or a good practice, always set these environment variables accordingly. So I already have JDK 1.8 installed on my system. But in case you do not, what I would recommend is just navigate on your browser to the Oracle homepage and just type in or search for install JDK 1.8 and navigate to the Oracle homepage. You'll have to accept the license agreement, and there are a bunch of installers that you can pick up based upon the operating system on which you're running. So I have this Windows 64 installer that is already installed and running on my system. So I will not get into the details of downloading this or installing it. Let me show you once I install this, what I've done with regard to my path. So if you get into this environment variables, all right, so I've just set in a Java home variable. If you see this, C: program files Java JDK 1.8. This is where my Java is located. C program files Java. Okay, so this is the home directory of my JDK. So that is what I've set it up here in my environment variable. So if you see here, this is my Java home. All right, one other thing to do is ensure that in case you want to run Java or JavaC from a command prompt, ensure that you also add that path into this path variable. So if you see this, somewhere I will see, yes, there you go. C: program files Java JDK 1.8 bin. So with these two, I'll ensure that my Java installation is nice and good enough. So to check that, to double check that or to verify that, let me just open up a simple command prompt. And if I type in Java -version, all right, and Java C -version. So the compiler is on the path, Java is on the path. And if at all I do this, even the environment variable specific to my Java is installed correctly. So I'm good to go ahead with my Jenkins installation. Now that I have my prerequisites all set for installing Jenkins, let me just go ahead and download Jenkins. So let me open up a browser and say download Jenkins. All right. LTS is nothing but the long-term support. These are all stable versions. Weeklies, I would not recommend that you try these unless until you have a real need for that. Long-term support is good enough. And as I mentioned, there are so many flavors of Jenkins that is available for download. All right, so what I want is, yes, this is the WAR file, which is a generic WAR file that I was talking to you earlier. And this is the Windows MSI installer. So go ahead and download this MSI installer. I already have that downloaded. So let me just open that up. All right, so this is my downloaded Jenkins instance, or rather installer. This is a pretty, maybe a few months old, but this is good enough for me. Before you start Jenkins installation, just be aware of one fact that there is a variable called Jenkins home This is where Jenkins would store all this configuration data, jobs, project workspace, and all that specific to Jenkins. So by default, if at all you don't set this to any particular directory, if at all you install an MSI installer, all your installation gets into C:\program files 86 and Jenkins folder. If at all you run a war file, depending upon the user ID with which you're running a war file, the Jenkins folder, there's a .jenkins folder that gets created inside the user home directory. So in case you have any need wherein you want to back up your Jenkins or you want Jenkins installations to get into some specific directories, go ahead and set this Jenkins home variable accordingly before you even begin your installation. For now, I don't need to do any of these things, so I've already downloaded the installer. Let me just go ahead with the default installation. All right, so this is my Jenkins MSI installer. I don't want to make any changes into the Jenkins configuration. C:\program files is good for me. Yeah, this is where all my destination folder and all the configuration specific to it goes. I'm happy with this. I don't want to change this. I would just say go ahead and click installation. Okay, so what typically happens once the Jenkins installation gets through is it'll start installing itself, and there are some small checks that needs to be done. So, and by default, Jenkins launches on the port 8080. So let me just open up localhost 8080. There's a small checking that will be done as a part of the installation process, wherein I need to type in the hash key. All right, so there's a very simple hash key that gets stored out here. So I'll have to just copy this path. If at all you're running as a war file, you would see that in your logs. All right, so this is a simple hash key that gets created every time when you do a Jenkins installation. So as a part of the installation, it just asks you to do this. So if that is not correct, it'll crib about it, but this looks good. So it's going ahead. All right, one important part during the installation. So you would need to install some recommended plugins. What happens is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugin and it's got a dependency which is not installed and you get into all those issues. In order to get rid of that, what Jenkins recommends, there's a bunch of plugins that is already recommended. So just go ahead and blindly click that install recommended plugin. So if you see, there is a whole lot of plugins which are bare essential plugins that is required for Jenkins in order to run properly. So Jenkins as a part of the installation would get all these plugins and then install it for you. This is a good combination to kind of begin with. And mind you, at this moment, Jenkins needs lots of bandwidth in terms of network. So in case your network is not so good, few of these plugins would kind of fail. And these plugins are all available on openly or mirrored sites, and sometimes some of them may be down. So do not worry in case some of these plugins kind of fail to install. You'd get an option to kind of retry installing them, but just ensure that at least most or 90-95% of all these plugins are installed without any problems. Let me pause the video here for a minute and then get back once all these plugins are installed. My plugin installation is all good. There was no failures in any of my plugins. So after that, I get to create this first admin user. Again, this is one important point that you got to remember. Give in any username and password, but ensure that you kind of remember that, because it's very hard to get back your username and password in case you forget it. All right, so I'm going to create a very simple username and password, something that I can remember. That's my name, and an email ID is kind of optional, but it doesn't allow me to go ahead in case I don't. So I just give in an admin and I got a password. I remember my password. This is my full name. All right, I say save and finish. All right, that kind of completed my Jenkins installation. It was not that tough, was it? Now that I have my Jenkins installed correctly, let me quickly walk you through some bare minimal configurations that is required. These are kind of a first time configuration that is required. So, and also let me warn you, the UI is little hard for many people to wrap their head around it, specifically the Windows guys. But if at all you're a Java guy, you know how painful it is to write UI in Java, you will kind of appreciate all the effort that has gone into the UI. Bottom line, UI is a little hard to, wrap your head around it, but once you start using it, possibly you'll start liking it. All right, so let me get into something called as Manage Jenkins. This can be viewed like a main menu for all Jenkins configuration. So I'll get into some of those important ones. Something called as Configure System. Configure System, this is where you kind of put in the configuration for your complete Jenkins instance. Few things to kind of look out for. This is a home directory. This is a Java home where all the configurations, all the workspace, anything and everything regarding Jenkins is stored out here. System message, you want to put in some message on the system, you just type in whatever you want and it's possibly show up somewhere up here on the menu. Number of executors, very, very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. You can kind of visualize it like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, number of executors 2 should be good enough. In case at any point in time, if there are multiple jobs that kind of get triggered at the same time, in case the number of executors are less compared to the number of jobs that have woken up, no need to panic because they will all get queued up and eventually Jenkins will get to running those jobs. Just bear in mind that whenever a new job kind of gets triggered, the CPU usage and the memory usage in terms of the disk write is very high on the Jenkins instance. So that's something that you got to kind of keep in mind. All right, but number of executors, 2 for my system is kind of good. Label for my Jenkins, I don't want any of these things. Usage, how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this node as much as possible. Quiet period. Each of these options have got some bare minimal help kind of a thing that is out here. By clicking on these question marks, you will get to know as to what are these particular configurations. All right, so this all look good. What I want to show you here is there's something regarding the Docker, timestamps, Git plugin, SVN, email notifications. I don't want that. What I want I want this SMTP server configuration. Remember, I mentioned earlier that I would want Jenkins to be sending out some emails. And what I've done here is I've just configured the SMTP details of my personal email ID. In case you're in an organization, you would have some sort of an email IDs that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of send out emails. But in case you want to try it out like me, I have configured my personal email ID, which is on my Gmail, for sending out notifications. So the SMTP server would be smtp.gmail.com. I'm using the SMTP authentication. I've provided my email ID and my password. I'm using the SMTP port, which is 465, and reply to address is the same as mine. I can just send out an email and see if at all this configuration works. Again, Gmail would not allow anybody to send out notifications on your behalf. So you'll have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notifications on your behalf. So I've done already that. I'm just trying to see if I can send a test email with the configurations that I've set in. Yes. All right. So the email configuration looks good. So this is how you configure your your Gmail account in case you want to do that. If not, put in your organization SMTP server details, which are with a valid username and password, and it should all be set. All right, so no other configurations that I'm going to change here. All of these look good. All right, so I come back to Manage Jenkins. Okay, one other thing that I want to kind of go over is the global tool configuration. Imagine this scenario, or look at it this way. Jenkins is a continuous integration server. It doesn't know what kind of a code base it's going to pull in, what kind of a tool set that is required, or what is the code that it's going to pull in and how is it going to build. So you would have to put in all the tools that is required for building the appropriate kind of code that you're going to pull in from your source code repositories. So just to give an example, in case your source code is a Java source code, and assuming that because in this demo, this is my laptop and I've put in all the configurations, JDK, everything on my laptop because I'm a developer, I'm working on the laptop. But my continuous integration server would be a separate server without anything being installed on it. So in case I want Jenkins to run a Java code, I would need to install JDK on it. I need to specify the JDK location of this out here this way. Okay, since I already have the JDK installed and I've already put in the Java home directory, or rather the environment variable correctly, I don't need to do it. Git, if at all I want the Jenkins server to use Git, Git is the command bash or the command prompt for running Git and connecting to any other Git server. So you would need Git to be installed on that particular system and set the path accordingly. Gradle and Maven, if at all you have some Mavens as well, you want to do this. Any other tool that you're going to install on your system, which is your continuous integration server, you will have to come in here and configure something. In case you don't configure it, when Jenkins runs, it will not be able to find these tools for building your task and it'll crib about it. That's good. I don't want to save anything. Manage Jenkins. Let me see what else is required. Yes, configure global security. All right, the security is enabled. And if you see by default, it's the security access control is set to Jenkins' own user database. So what does this mean? Jenkins by default, it uses file system where it stores all the usernames, which hashes up these usernames and kind of stores them. So as of now, Jenkins is configured to use its own database. Assuming that you are running in an organization, you would probably want to have some sort of an AD or an LDAP server using which you would want to control access to your Jenkins repository, rather Jenkins tool. So you would specify your LDAP server details, the root DN, password or the manager DN and the manager password and all these details in case you want to connect your Jenkins instance with your LDAP or AD or any of the authentication servers that you have in your organization. But for now, since I don't have any of these things, I'm going to use this own database. That's good enough. All right. So I will set up some authorization methods and stuff like that once I put in few jobs. So for now, let me not get into any of these details of this. Just be aware that Jenkins can be connected for authorization to an LDAP server, or you can have Jenkins managing its own servers, which is happening as of now. So I'm going to save all this stuff. That's good for me. So enough of all these configurations. Let me put in a very, very simple job. All right. So job, new item. A little difficult to kind of figure out, but then that's the new item. So I'll just say, first job, this is good for me. I just give a name for my job. I would say it's a freestyle project. That's good enough for me. I don't want to choose any of that. So unless until you choose any of this particular button would not be up. I'll give a description. This is an optional thing. This is my first Jenkins job. All right. I don't want to choose any of these. Again, there are some helps available here. I don't want to choose any of this. I don't want to connect it into any source code for now. I don't want any triggers for now. I'll come back to this in a while. Build environment. I don't want any build environment. As a part of this build step, I just want to, run few things so that I kind of complete this particular job. So since I'm on a Windows box, I would say execute Windows batch command. All right. So what do you want to do? Let me just echo something. Echo. Hello. This is my first Jenkins job, and possibly I would want the date and the timestamp pertaining to the job. I mean, the date and time in which this job was run. All right. Very, very simple command that says, this is my first job. It just puts out something along with the date and the time. All right. I don't want to do anything else. I want to keep this job as simple as this. So let me save this job. All right, so once I save this job, the job names comes up here, and then I need to build this job. And you would see some build history out here. Nothing is there as of now because I've just put in a job. I've not run it yet. All right, so let me try to build it now. You see a build number, you would see a date and a timestamp. So if I click on this, you would see a console output. If I go here, okay, as simple as that. And where is all the job details that is getting into? If you see this, if I navigate to this particular directory, all right, so this is the directory what I was mentioning earlier regarding Jenkins home. So all the job related stuff that is specific to this particular Jenkins installation is all here. All the plugins that is installed, the details of each of those plugins can be found here. All right, so the workspace is where all the jobs that I've created, whichever I'm running, there will be individual folders specific to the jobs that has been put up here. All right. So one job, one quick run. That's what it looks like. Pretty simple. Okay, let me do one thing. Let me put up a second job. I would say second job. I would say freestyle project. All right, this is my second job. I just want to demonstrate the powerfulness of the automation server and how simple it is to automate a job that is put up on Jenkins. Which will be triggered automatically. Remember what I said earlier about Jenkins, because at the core of Jenkins is a very, very powerful automation server. All right, so what I'm going to do, I will just keep everything else the same. I'm going to put in a build script pretty much similar to second job that gets triggered automatically every minute. All right, let me do that. Percentage date, and I'll put in the time. All right, so I just put in another job called second job, and it pretty much does the same thing as what I was doing earlier in terms of printing the date and the time. But this time I'm just going to demonstrate the powerfulness of the automation server that is there. If you see here, there's a build trigger. So a build can be triggered using various triggers that is there. So we'll get into this GitHub triggering or hook or a webhook kind of a triggering later on. But for now, what I want to do, I want to ensure that this job that I'm going to put in would be automatically triggered on its own. Let's say every minute, I want this job to be run on its own. So build periodically is my setting. If you see here, there's a bunch of help that is available for me. So for those of you who have written cron jobs on Linux boxes, you'll find it very, very simple. But for others, don't panic. Let me just put up a very, very simple regular expression for scheduling this job every minute. All right, so that's 1, 2, 3, 4, 5. All right, come up, come up, come up. All right, so 5 stars is all that I'm going to put in. And Jenkins got a little worried and he's asking me, do you really mean every minute? Oh yeah, I want to do this every minute. Let me save this. And how do I check whether it gets triggered every minute or not? I just don't do anything. I'll just wait for a minute. And if at all everything goes well, Jenkins would automatically trigger my second job in a minute's time from now. This time around, I'm not going to trigger anything. Look, there you see. It's automatically got triggered. If I go in here, yep, second job that gets triggered automatically. It was triggered at 1642, which is 4:42 my time. That looks good. And if everything goes well, every 1 minute onwards, this job would be automatically triggered. Now that I have my Jenkins up and running, a few jobs that has been put up here on my Jenkins instance, I would need a way of controlling access to my Jenkins server. This is wherein I would use a plugin called role-based access plugin and create few rules. The rules are something like a global role and a project role, project specific role. I can have different roles and I can have users who have signed up or the users whom I create kind of assigned to these roles so that each of these users fall into some category. This is my way of kind of controlling access to my Jenkins instance and ensuring that people don't do something unwarranted. All right, so first things first, let me go ahead and install a plugin for doing that. So I get into manage Jenkins and manage plugin. A little bit of a confusing screen in my opinion. There is updates available, installed and advanced. As of now, we don't have the role-based plugin. So let me go to available. It'll take some time for it to get refreshed. All right, now these are the available plugins. These are the installed plugins. All right, so let me come back to available and I would want to search for my role-based access plugin. So I would just search for role and hit enter. Okay, role-based authorization strategy enables user authorization using a role-based strategy. Roles can be defined globally or for particular jobs or nodes and stuff like that. So exactly, this is the plugin that I want. I would want to install it without a restart. All right, looks good so far. Yes. Go back to the top of the page. Yes. Remember, Jenkins is running on a Java, using a Java instance. So typically many things would work the same way unless and until you want to restart Jenkins once in a while. But as a good practice, whenever you do some sort of a big installations or big patches on your Jenkins instance, just ensure that you kind of restart it. Otherwise, there would be a difference in terms of what is installed on the system and what is there on the file system. You would need to flush out few of those settings later on. But for now, these are all very small plugins, so these would run without any problems. But otherwise, if at all there are some plugins which would need a restart, kindly go ahead and restart your Jenkins instance. But for now, I don't need that. It looks good. I've installed the plugin. So where do I see my plugin? I installed the plugin that is specific to the user control or the access control. So let me go into, yes, global security. And I would see this role-based strategy showing up now. All right, so this comes in because of my installation of my role-based plugin. So this is what I would want to enable because I already have my own database set up. And for the authorization part, in the sense that who can do what, I'm going to install. I mean, I've already installed a role-based strategy plugin, and I'm going to enable that strategy. All right, I would say save. Okay, now I've installed the role-based access plugin. I would need to just set it up and check that, I would go ahead and create some roles and ensure that I assign users as per these roles. All right, so let me go to Manage Jenkins, configure. All right, let me see, where is this? Configure global security. Is that where I create my roles? Nope, not here. Yes, manage and assign roles. Okay, again, you would see these options only after you install these plugins. So for now, I've just enabled the plugin. I've enabled role-based access control, and I would go ahead and create some rules for this particular Jenkins instance. So I would say first, manage roles. So I would need to create some roles here, and the roles are at a very high level. These are global roles, and there are some project roles, and there are some slave roles. I'll not get into details of all of these. At a very, very high level, which is a global role, let me just create a role. A role can be kind of visualized like a group. So I would create a role called developer. Typically, the Jenkins instance or the CA instance are kind of owned up or controlled by QA guys. So QA guys would need to provide some sort of limited access to developers. So that's why I'm creating a role called developer. And I'm adding this role at a global role level. So I would say add this here, and you would see this developer role that is there. And each of these options, if you hover over it, you would see some sort of a help on what are these permissions specific to. So what I want is it sounds a little different, but I would want to give very, very little permissions for the developer. So from an administration perspective, I would just want him to have a read kind of a role. Credentials, again, I would just want a view kind of a role. I don't want him to create any agents and all that stuff. That looks good for me. For a job, I would want him to just possibly read. I don't want him to build. I don't want him to cancel any jobs. I don't want him to configure any job. I don't even want him to create any job. I would just want him to read few things. I would not give him possibly a role to the workspace as well. I mean, I don't want him to have access to the workspace. I would just want him to read a job or check, have read-only access to the job. Run. No, I don't want him to give him any particular access which will allow him to run any jobs. View, configure, yeah, possibly create, yeah, delete, I don't want, read, yes, definitely. And this is the specific role. So what I'm doing, I'm just creating a global role called developer, and I'm giving him very, very limited roles in the sense that I don't want this developer to be able to run any agents, nor create jobs or build jobs or cancel jobs or configure jobs. At the max, I would just want him to read a job that is already put up there. Okay, so I would save. Now I've created a role. I still don't have any users that is there on the system. So let me go ahead and create some user on the system. That's not here. I would say configure, manage Jenkins, manage users. Okay, let me create a new user. I would call this user as, yeah, developer one sounds good. Some password. some password that I can remember. Okay, his name is developer1 d@d.com or something like that. Okay, so this is the admin with which I kind of configured or brought up the system, and developer1 is a user that I have configured. So still have not set any roles for this particular user yet. So I would go to manage Jenkins. I would say manage and assign roles. I would say assign roles. Okay, so if you see, what I'm going to do now is assign a role that is specific to that particular developer. I will find the particular user and assign him the developer role that I've already configured. The role shows up here. I would need to find my user, whoever I created, and then assign him to that particular role. So if you remember, the user that I created was developer1. I would add this particular user, and now this particular user, what kind of a role I want him to have, because this is the global role that I had created. So developer, I would assign this developer1 to this particular global role, and I would go ahead and save my changes. Now let me check the permissions of this particular user by logging out of my admin account and logging back as developer1. If you remember, this role was created with very less privileges. So there you go. I have Jenkins, but I don't see a new item. I can't trigger a new job. I can't do anything. I see these jobs. However, I don't think so I'll be able to start this job. I don't have the permission set for that. The maximum I can do is look at the job, see what was there as a part of the console output and stuff like that. So this is a limited role that was created, and I added this developer to that particular role, which was a developer role, so that the developers don't get to configure any of the jobs, because the Jenkins instance is owned by a QA person. He doesn't want to give developer any administrative rights. So the rights that he set out by creating a developer role, and anybody who is tagged, any user who is tagged as a part of this developer role would get the same kind of permissions. And these permissions can be, fine grained. It can be a project specific permissions as well. But for now, I just demonstrated the high level permission that I had set in. Let me quickly log out of this user and get back as the admin user, because I need to continue with my demo. With the developer role that was created, I have very, very less privileges. One of the reasons for Jenkins being so popular, as I mentioned earlier, is the bunch of plugins that is provided by users or community users who don't charge any money for these plugins, but it's got plugins for connecting anything and everything. So if you can navigate to, or if you can find Jenkins plugins, you would see index of over so many plugins that is there. All of these are wonderful plugins. Whatever connectors that you would need, if you want to connect Jenkins to an AWS instance, or you want to connect Jenkins to a Docker instance, or any of those containers, you would have a plugin. You can go and search up. If I want to connect Jenkins to Bitbucket, Bitbucket is one of the Git servers. There's so many plugins that is available. Okay, so bottom line, Jenkins without plugins is nothing. So plugins is the heart of Jenkins. For you to connect, or in order to connect Jenkins with any of the containers or any of the other tool sets, you would need the plugins. If you want to connect, or you want to build a repository which has got Java and Maven, you would need to install Maven and JDK on your Jenkins instance. If at all you're looking for a .NET build or a Microsoft build, you would need to have MS Build installed on your Jenkins instance, and the plugins that will trigger MS Build. If at all you want to listen to some server-side webhooks from GitHub, you would need GitHub specific plugins. If you want to connect Jenkins to AWS, you need those plugins. If you want to connect to a Docker instance that is running anywhere in the world, as long as you have the URL which is publicly reachable, you just have a Docker plugin that is installed on your Jenkins instance. SonarQube is one of the popular static code analyzers. So you can connect a Jenkins build, you can build a job on Jenkins and push it to SonarQube, and get SonarQube to run analysis on that and get back the results in Jenkins. All of these works very well because of the plugins. Now with that, let me connect our Jenkins instance to GitHub. I already have a very, very simple Java repository up on my GitHub instance. So let me connect Jenkins to this particular GitHub instance and pull out a job that is put up there. All right. So this is my very, very simple, repository that is there called Hello Java. And this is what is there in the repository. There is a hello.java application that is here, or a simple class file that is there. It's got just one line of system.out. So this is already present on github.com at this place, and this would be the URL for this repository. If I pick up the HTTPS URL, this is my HTTPS URL. So what I would do is I would connect my Jenkins instance to go to GitHub, provide my credentials, and pull out this repository which is on the cloud hosted github.com and get it to my Jenkins instance, and then build this particular Java file. I'm keeping the source code very simple. It's just a Java file. How do I build my Java file? How do I compile my Java file? I just say Java C and the name of my class file, which is hello.java. And how do I run my Java file? I would say Java and hello. Okay, so remember, I don't need to install any plugins now because what it needs is a Git plugin. So if you remember, when we were doing the installation, there was a bunch of recommended plugins. So Git is already installed on my system, so I don't need to install it again. So let me put up a new job here. It says Git job. Let it be a freestyle project. That's good for me. I would say okay. All right, so the source code management. Remember, in the earlier examples, we did not use any source code because we were just putting up some echo kind of jobs. We did not need any integration with any of the source code systems. So now let me connect this. So I'm going to put up a source code, and Git would show up because the plugin is already there. SVN, Perforce, any of those additional source code management tools, if at all you would need, just install those plugins, and Jenkins connects wonderfully well to all these particular source control tools. Okay, so I would copy the HTTPS URL from here. I would say this is the URL that I'm supposed to go and grab my source code from. But all right, that sounds good, but what is the username and password? So I'll have to specify a username and password. All right, so I would say the username, this is my username, and this is my HTTPS credential for my job. Okay, so this is my username and this is my password. I just save this. I say add, and then I would say, use these credentials to go to GitHub and then on my behalf, pull out a repository. All right. If at all, at this stage, if there's any error in terms of Jenkins not able to find Git or the git.exe, or if my credentials are wrong, somewhere down here, you would see a red message saying that, something is not right. You can just go ahead and kind of fix that. For now, this looks good for me. I'm going to grab this URL. What am I going to do? This step would pull the source code from the GitHub. And then what would be there as a part of my build step? Because this repository just has a Java file, correct? Hello.java. So in order for me to build this, I would just say execute Windows batch command, and I would say Java C hello.java. That is the way I would build my Java code. And if I have to run it, I would just say Java hello. Pretty simple, 2 steps, and this would run after the repository contents are fetched from GitHub. So Java C, Java, that sounds good. I would say save this and let me try to run this. Okay, if you see, there's a lot of, it executes Git on your behalf. It goes out here, it provides my credentials and says, it pulls all my repository, and by default, it will pull up the master branch that is there on my repository. And it kind of builds this whole thing, Java C hello.java, and it runs this project Java hello. And there you see, this is the output that is there. And if at all you want to look at the contents of the repository, if you can go here, this is my workspace of my system. Hang on, this is not right. Okay, Git job. If you see here, this is my hello.java. This is the same program that was there on my GitHub repository. Okay, so this is a program that was there on my GitHub repository. All right, so this was the same program that was here, and Jenkins on our behalf went over all the way to GitHub, pulled this repository from there, and then it brought it down to my local system on my Jenkins instance. It compiled it and it ran this particular application. Okay, now that I've integrated Jenkins successfully with GitHub for a simple Java application, let me build a little bit on top of it. What I will do is I have a Maven based web application that is up there as a repository in my GitHub. So this is the repository that I'm talking about. It's called MVN Web App. It's a Maven based repository. As you would know, Maven is a very simple Java based build tool that will allow you to run various targets, and it'll compile It will, based upon the goals that you specify, it can compile, it can run some tests, and it can build a WAR file and even deploy it into some other server. For now, what we're going to use Maven is just for building and creating a package out of this particular web application. It contains a bunch of things, and what is important is just the index.jsp. It just contains an HTML file that is there as a part of this web application. So from a perspective of requirements, now since I'm going to connect Jenkins with this particular repository, Git, we already have that set. We only need two other things. One is Maven, because Jenkins will use Maven. So in order to use Maven, Jenkins would have to have a Maven installation that is there on the Jenkins box. And in this case, the Jenkins box is this laptop. And after I have my Maven installed, I also need a Tomcat server. Tomcat is a very simple web server that you can freely download. I'll let you know how to quickly download and install the Tomcat. All right, so download Maven first. There are various ways in which you can kind of download this Maven. There is zip files, binary zip files, and archive files. So what I've done is I've just already downloaded Maven, and if you see, I've unzipped it here. So this is the folder with which I've unzipped my Maven. So as you know, Maven again is a one open source build tool. So you'll have to set in a few configurations and set up the path. So mvn -- version, if I specify this, after I set in my path, Maven should work. And if at all I echo m2 home, which is nothing but the variable environment variable specific to Maven home, it is already set here. So once you unzip Maven, just set this m2 home variable to the directory where you unzipped your Maven. Also, just set the path to this particular directory /bin, because that is where your Maven executables are all found. All right, so that's with Maven. And since I've set the path and the environment variable Maven is running perfectly fine on my system, I've just verified it. Okay, next one is a Tomcat server. Download Apache Tomcat server 8.5 is what I have on my system. So I'm just going to show you where to download this from. This is where you download Tomcat server, and I already have the server downloaded. Again, this doesn't need any installation. I just unzip it here, and it kind of has a bin and configuration. I've made some subtle changes in the configuration. First and foremost, Tomcat server also by default runs on port 8080. Since we already have our Jenkins server running on port 8080, we cannot let Tomcat run on the same port. There will be a port clash. So what I've done, I've configured Tomcat to use a different port. So if I go to this configuration file here, there is a server.xml. Let me open this up here. All right. Okay. So this is the port. By default, it will be 8080. I've just modified it to 8081. So I've changed the port on which my Tomcat server would run. All right. So that's one change. Second change, when Jenkins kind of tries to get into my Tomcat and deploy something for someone, he would need some authentications so that he'll be allowed deployment by Tomcat. So for that, I need to create a user on Tomcat and provide this user credentials to my Jenkins instance. So I would go to Tomcat users.xml file here. I've already created a username called deployer and the password is deployer, and I've added a role called manager-script. Manager-script will allow programmatic access to the Tomcat server. So this is the role that is there. So using this credentials, I will enable or I'll empower Jenkins to get into my Tomcat server and deploy my application. All right, only these two things that is required. Let me just start my Tomcat server first. So I get into my bin folder, I open a command prompt here, and there's a startup.bat. It's pretty fast. It just takes a few seconds. Yes, there you go. Tomcat server is up and running. Now this is running on port 8081. So let me just check if that looks good. So localhost 8081. Okay, my Tomcat server is up and running. That sounds good. The user is already configured on this. That's also fine. So what I'll do as a part of my first job, Maven is also installed on my system. So I'm good to use Maven as a part of my Jenkins. So I will put up a simple job now. I will say job mvn web app. I'll call this freestyle job. That's good. Okay, so this will be a Git repository. What is the URL of my Git repository? Is this guy, HTTPS URL. Okay, that's this URL. I will use the credentials. The old credentials that I set up will work well because it's the same Git user that I'm kind of connecting into. All right, so now the change happens here where after I get this, since I said this is a simple Maven repository, I will have some Maven targets to run. So the simple target first is, let me run Maven package. This creates a war file. Okay, so mvn package is the target. Package is the target. So whenever I run this package, it kind of creates it, it builds it, it tests it, and then creates a package. So this is all that is required. Maybe let me try to save this, and let me first run this and see if it connects well, if there's any problem with my war file, or the war file gets created properly. Okay, wonderful. So it built a war file, and if you see, it all shows you what is the location where this war file was generated. So this will be the workspace. If you see this war file was successfully built. Now I need to grab this particular war file, and then I would need to deploy it into Tomcat server. Again, I would need a small plugin to do this because I need to connect Tomcat with my Jenkins server. Let me go ahead and install the plugin for the container deployment. So I will go to manage plugins, available, type in container, container, deploy to container. Okay, so this is the plugin that I would need. I would install it without a restart. Okay, seems to be very fast. Nope, sorry, it's still installing. Okay, it installed the plugin. So if at all you see this, if you go to my workspace, okay, in the target folder, I would see this web application war file that is already built. So I would need to configure this plugin to pull up this war file and deploy it onto the Tomcat server. For deploying onto the Tomcat server, I will use the credentials of the user that I've created. Okay, so let me go to configure this particular project again. And okay, all this is good. So the package is good. I'm going to just create a package. That's all fine. Now add a post build step. So after the war file is built as a part of this package directive, let me use this deployment to container. Now this will show up after you install the plugin. So deploy this one to the container. Now what is that you're supposed to specify? You're supposed to specify what is the location. Okay, so this is a global configuration that is there that will allow you to, from the root folder, it will pick up the war file that is there. So ******war, that's good for me. Okay, what is the context path? Context path is nothing but just the name of an application that, under which it will get deployed into the Tomcat server. I will just say mvn web app. That's the name of my thing. Now I need to specify what kind of a container that I'm talking about. All right, so the deployment would be for this Tomcat 8.5 is what I need. Okay, because the server that we have is a Tomcat 8.5 server that I have. So this would be the URL. So the credentials, yes, I need to add a credential for this particular server. So if you remember, I had created a credential for my web application. So let me just find that. My Tomcat server, yes, configuration of this. Okay, so deployer and deployer. Username is deployer, password is deployer. Okay, so let me use that credential. I would say add a new credential, Jenkins credential. The username is deployer and the password is deployer. So I would use this deployer credentials for that. And what is the URL of my Tomcat instance? So this is the URL of my Tomcat instance. So take the war file that is found in this particular folder. and then, context path is mn web app, use the deployer deployment credentials and get into this localhost, which is there 8081. This is the Tomcat server that is running on my system, and then go ahead and deploy it. Okay, so that is all that is required. So I would say just save this and let me run it now. Okay, it successfully built the war file. It is trying to deploy it, and looks like the deployment went ahead perfectly well. So the context path was mvn web app. So if I type in this, right, if at all I go ahead into my Tomcat server, there would be a web apps folder. You would see the the date timestamp. So this is the file that got recently copied, and this is the Explorer version of our application. So the application was built, the source code of this application was pulled from the GitHub server. It was built locally on the Jenkins instance, and then it was pushed into a Tomcat server which is running on a different port, which is 80881. Now for this demo, I'm running everything locally on my system, but assuming that this particular Tomcat instance was running on some other server with some other different IP address, all that you got to go and change is the URL of the server. So this would be the server in case you already have that, if you have a Tomcat server which is running on some other machine, that's all fine. With a different IP, that's all good enough. The whole bundle or the war file that was built as a part of this Jenkins job gets transferred onto the other server and gets deployed. That's the beauty of Jenkins and automatic deployments, or other deployments using Jenkins and Maven. Distributed build or master slave configuration in Jenkins. As you would have seen, we just have one instance of Jenkins server up and running all the time. And also I told you that whenever any job that kind of, gets started on the Jenkins server, it is little heavy on in terms of disk space and the CPU utilization. So which kind of, if at all you're in an organization wherein you're heavily reliant on the Jenkins server, you don't want your Jenkins server to go down. So that's wherein you kind of start distributing the load that is there on the Jenkins server. So you primarily have a server, which is just a placeholder or like a master who will take in all the kind of jobs. And what he'll do is based upon trigger that has happened to the job or whichever job needs to be built, if at all, he can delegate these jobs onto some other machines or some other slaves. That's a wonderful thing to have. Okay, use case 1. Use case 2, assuming that, if you have a Jenkins server that is running on a Windows box or on a Linux one, and if at all you have a need where you need to build based upon operating systems, you have multiple build configurations to support. Maybe you need to build a Windows, Windows based .NET kind of a projects where you would need a Windows machine to build this particular project. You also have a requirement where you want to build Linux based systems. You also have a Mac, you support some sort of an apps or something that is built on Mac OS. You would need to build, Mac based system as well. So how are you going to support all these needs? So that's wherein a beautiful concept of master slave or primary and delegations or agent and master comes into play. So typically you would have one Jenkins server who will just configure with all the proper authorizations, users, configurations, and everything is set up on this Jenkins server. His job is just delegations. He will listen to some sort of triggers, or based upon the job that is coming in, he will, if there is a nice way of delegating these jobs to somebody else and taking back the results, he can control a lot of other systems. And these systems may not have a complete, or there's no need to put in a complete Jenkins installation. All that you got to do is have a very, very simple runner or a slave that is a simple jar file that is run as a low priority thread or a process within these systems. So with that, you can have a wonderful distributed build server that can be set up. And in case one of the servers goes down, your master would know that what went down and kind of delegate the task to somebody else. So this is the kind of distributed build or the master slave configuration. So what I'll do in this exercise or in this demo is I will set up a simple slave. But since I don't have too many machines to kind of play around, what I'll do is I will set up a slave in one other folder within my hard drive. So I've got the C drive and D drive. My Jenkins is on my C drive. So what I would do is I would just use my E drive and set up a very, very simple slave out there. I'll just show you how to provision a slave and how to connect to a slave and how to delegate a job to that slave. Let me go back to my Jenkins master and configure him to talk to an agent. So there are various ways in which this client and server talk to each other. What I'm going to choose is something called as JNLP. Java Network Launch Protocol. So using this, I would ensure that, the client and server talk to each other. So for that, I need to ensure that I kind of enable this JNLP port. So let me try to find out where is that. Let me try this. Okay, yes. Agents, and by default, this JNLP agents thing would be disabled. So if you see here, there's a small help on this. So I'm going to use this JNLP, which is nothing but Java Network Launch Protocol. And, I'll configure the master and server to talk to each other using JNLP. So for that, I need to enable this guy. So I enable this guy instead of making by default, the configuration was disabled. So I make him random. I make him, enabled, and I say save this configuration. All right. So now I configured, or I made a setting for the master so that the JNLP port is kind of opened up. So let me go ahead and, create an agent. So I'll go to manage nodes. So if you see here, there's only one master here. So let me provision a new node here. So this is the way, in which you bring up a new node. You have to configure it on the server. Jenkins would put in some sort of security around this particular agent and let you know how to launch this particular agent so that he can connect to your Jenkins master. So I would say new node. I would give a name for my node. I would say Windows node because both of these are Windows only. So that's fine. I just give an identifier saying that Windows node. I would say this is a permanent agent. I would say, okay. So if you see the name, let me just copy this name here with the description. Number of executors, since it's a slave node and both of these are running on my system, I will keep the number of executors as 1. That's fine. Remote root directory. Now this is where, let me just clarify this, since I have both my master is running on my C drive program files 86, or hang on, not 86, C : program files. It is indeed 86. All right, Jenkins. So this is where my master is running. So I don't want the C drive. What I'll do is I'll use something called as A drive. I have another drive in my system, but please visualize this like, you're running this on a separate system altogether. So I create a folder here called Jenkins node, and this is where I'm going to place I'm going to provision my slave, and I'm going to run him from here. So this is the directory in which I'm going to provision my slave node. So I'm going to copy this here, and that is the remote root directory of your particular agent or slave. So I just copy it here. The label, probably this is fine for me. And usage, how do you want to use this guy? So I don't want him to run all kinds of jobs. I will only build jobs with label expressions that match this particular node. And so this is the label of this node. So in order for somebody to kind of delegate any task to them, they will have to specify this particular label. So imagine this way, if I have a bunch of Windows mesh system, I name it as Windows star. Anything that starts from Windows, I can give a regular expression and say that anything that matches Windows, run this particular task there. If I have some Mac machines, I name all these Mac agents as Mac star or something like that. And I can delegate all tasks, saying that start with whatever starts with Mac in this node, run the Mac jobs there. So you identify a node using the label and then delegate the task there. All right. So launch method, we will use Java Web Start because we're going to use JNLP protocol. Okay, that sounds good. Directory, I think nothing else is required. Availability, yes, we'll keep this agent, yep, online as much as possible. That sounds good. All right, let me save this. All right, I'm just provisioning this particular node now. So if I click on this node, I get a bunch of commands along with an agent.jar. So this is the agent.jar that has to be taken down to the other machine or the slave node, and from there I need to run this along with a small security credential. So let me copy this whole text here in my notepad. Notepad plus is good for me. Okay, I copy this whole path there. I also want to download this agent.jar. I would say yes. And this agent.jar is the one that is configured by our server. So all the details that is required for launching this agent.jar is found in this. For launching this agent is found in this agent.jar. So typically I need to take this jar file onto the other system. And then kind of run it from there. So I have this agent.jar. I copy this, or rather I cut this. I come back to my folder, my Jenkins node. I paste it here. Okay. So now with this provision agent.jar, and I need to use this whole command, Control A, Control C, and then launch this particular agent. So let me bring up a command prompt right here and then launch it. So I'm saying in the same folder where there is agent.jar, I'm going to launch this particular agent, java-jar, agent.jar, JNLP. This is the URL of my server. In case the server and client are on different locations or different IPs, you have to specify the IP address. All this anyway would show up. And then the secret and, the root folder of your Jenkins or the slave node. Okay. So something ran, and then it says it's connected very well. It seems to have connected very well. So let me come back to my Jenkins instance and see, if at all you see earlier, this was not connected. Now let me refresh this guy. Okay, now these two guys are connected. Provision a Jenkins node, and then I copied all the credentials of the slave.jar along with the launch code, and then took it to the other system and kind of ran it from there. Since I don't have another system, I've just got a separate directory in another folder, another drive, and I'm launching the agent from here. As long as this particular agent is up and running, or this command prompt is up and running, the agent would be connected. So once I close this, the connection goes down. All right, so successfully we've launched this particular agent. Now this would be the home directory of this Jenkins node or the Jenkins slave. So any task that I'm going to delegate to this particular slave would all be run here. It will create a workspace right here. All right, so good. So let me just come back and let me kind of put up a new task here. I will say that, delegate job is good. I say freestyle project. I'm going to create a very, very simple job here. I don't want it to connect to Git or anything like that. Let me just create a very, very simple echo delegated to the slave, delegated to, I don't like the word slave, delegated to agent. Put this way. All right. So delegated to agent sounds good. Now, how am I going to ensure that this particular job runs on the agent or on the slave that I've configured? Right? Do you see this? If at all you remember how we provisioned our particular slave, we gave a label, right? So now I'm going to put in a job that will only match this particular label. So I'm going to say that whatever matches this, Windows label, run this job on that particular node. So we have only one node that's matching this, Windows node. So this job will be delegated out there. So I save this and let me build this. This is again a very, very simple job. There's nothing in this. I just want to demonstrate how to kind of delegate it to an agent. So if you see this, it ran successfully. And where is the workspace? The workspace is right inside our Jenkins node. It created a new workspace, delegated job, it put in here. So my old or my primary master job is in SQL program files under Jenkins. And this is the slave job that was successfully run. Very, very simple, but very, very powerful concept of master slave configuration or distributed build in Jenkins. Okay, approaching the final section where we've done all this hard work in bringing up our Jenkins server, configuring it, putting up some jobs on it, creating users and all this stuff. Now, we don't want this configuration to kind of go away. We want a very nice way of ensuring that we back up all this configuration. And in case there is any failure, hardware crash or a machine crash, we will want to kind of restore from the existing configuration that we kind of backed up. So one quick way to do that would be, or one dirty way to do that would be just, take a complete backup of our program files Jenkins directory, because that's where our whole Jenkins configuration is present. But we don't want to do that. Let's use some plugins for taking up a backup. So let me go to Manage Jenkins and click on Available. And let me search for some backup. There are a bunch of backup plugins. So I would recommend one of these plugins that I specifically use. So this is the backup plugin. So let me go ahead and install this plugin. All right, so we went ahead and installed this plugin. So let me come back to my Manage plugins. So this plugin is there. So hang on. Backup manager. So you will see this option once you install this plugin. So first time I can do a setup. I would say backup this particular. I'll give a folder. This folder is pertaining to the folder where I want Jenkins to backup some data. And I would say the format should be zip format is good enough. Let me give a name or a template or a file name for my backup. This is good. I want it in verbose mode. I don't want to shut on my Jenkins, or should I shut it down? No. Okay. One thing that you got to remember is that whenever a backup happens, if there are too many jobs that is running on the server, it can kind of slow down your Jenkins instance, because it's in the process of copying few of those things, and if the files are being changed at that moment, it's a little bit problematic for Jenkins. So typically you back up your servers only when there is very less load, or typically try to bring it to a shutdown kind of a state and then take a backup. All right, so I'm going to back up all these things. I don't want to exclude anything else. I want the history. I want the Maven artifacts. Possibly I don't want this guy. I would just say save, and then I would say back him up. So this would run a bunch of steps and all the files that is required as a part of this is pretty fast. But then if at all you have too many things up on your server, for now we didn't have too many things up on our server, but in case you had too many things to kind of back up, this may take a while. So let me just pause this recording and get back to you once the backup is complete. So there you go. The backup was successful. Created a backup of all our workspace, the configurations, the users, and all that. So all this is kind of hidden down in this particular zip file. So at any instance, if at all I kind of crash my system for some instance, or say hard disk failure, and I bring up a new instance of Jenkins, I can kind of use the backup plugin for restoring this particular configurations. So how do I do that? I just come back to my manage Jenkins, come back to backup manager, and I would say restore Hudson or Jenkins configuration.
Monitoring, as the term says, you're monitoring, you're watching, you're logging your production environment. So of course there are a whole bunch of monitoring tools, so they become an important part of your production environment. And a lot of these monitoring tools are also, I've seen them also being used, especially in your UAT environment. And you can optionally have them for some time, even in your development environment. No, not development, because development servers are usually not very high-end configurations, but maybe a decent development / integration server, especially if you have long-running scripts and if you have programs that use a lot of server, maybe CPU or processing power. So then you can have monitoring tools when you're writing such scripts, and you're doing the unit testing for those scripts, so that to see what kind of server utilization happens when you run this script. If you'll put this in production, will it actually slow down your production server, and what kind of impact that will have on the your rest of your application or other applications running on that server. But this particular chapter is more in context with production environment. So these tools, they basically monitor your server, they monitor your switches, of course they monitor your applications and any services that you have deployed on your servers. And they generate alerts when something goes wrong. And that's the whole job of monitoring. It is continuously watching, continuously looking at what is running, what is happening, what is going up, what is going down, when is CPU peaking, when is memory peaking, and all that. So that you typically send limits for these all these different parameters, and anytime any of these parameters goes outside of that limit, even more than that or less than that, these monitoring tools usually send out an alert, and these alerts could again be SMS alerts or email alerts, and there are usually people monitoring these monitoring tools to look out for any issues reported. And they also generate alerts when the problem has been resolved. so they work both ways. So Nagios is an open source monitoring tool, and it can even monitor your network services. There's a little diagram here, which is a little too small, but here is Nagios somewhere, what I can read. And status. So these are different devices, I think. Yeah, these are different devices to which Nagios is sending the status. There's a browser, there's an SMS, there's an email, and then there's a graph also. And these are different objects that Nagios is basically monitoring. This is an SMTP server. I can read SMTP. This is, I don't know, TCP/IP? No, I don't know, some database server. Okay, this is a database server, and this is an application server. This is a switch router. Okay, I can read that now. So these are the different kind of objects. These are different kind of servers that Nagios monitors, and these are the different kind of devices or statuses that it can send. So it helps monitor your CPU usage, your disk usage, and even your system logs. And it uses a plugin script that can be written, in any scripting language actually. If you ask me. So Nagios remote plugin executors are basically agents that allow remote scripts to be executed as well, and these scripts are usually executed to monitor, again, your CPU, disk usage, number of users logged in, who's logged in at what time, logged out at what time, and all these things. So all these monitoring tools work on the concept of polling. So polling is more like, so the NRP agent is a program that will continuously keep polling a machine for certain parameters that are configured in Nagios to be monitored. So this program continuously keeps pinging the server, bringing the program, to keep checking for what it has been asked to check. So in case of logged in users, you keep checking at a, like maybe every 30 seconds or every 1 minute, you keep pinging to see how many users have logged in onto this server and who are the users who have logged in, what time they logged in, what time they logged out, and things like that. So Nagios poll agents on remote machines. This is what basically it means. Nagios has agent programs that can, help you poll or ping even remote machines. The Nagios remote data processor is an agent that allows flexible data transports, and it uses HTTP and XML protocols to do that. And we're talking about essentially your databases and data server usages, like within, if you have an Oracle database, how many database instances are there, how your load balancing is set up on that, how data is moving between different database servers within Oracle, and how data is moving within the load balancers, and there's always a DRP, there's always a backup with database, so that's why you see me mention DRP as soon as I say the word database. And if there's a backup plan, how's the data moving, how much time did the backup take, did it take too much time, and why did it take? So it helps you do all those kind of monitoring. The NS client is basically mainly used to monitor Windows machines, and typically when we talk about servers, we end up talking more about Unix or Linux servers. Of course, now with a lot of Microsoft technologies being robust than they were, like SharePoint or things like that. There are Windows servers too, but 10 years ago, if you would talk about having a Windows server, it was actually kind of frowned upon, especially for production. And again, this helps you monitor your CPU, your disk usage, and it pulls the plugin, and this particular agent listens to this particular port always. So that's a reserved port. And usually your system administrators or server administrators know all these things. So a quick overview on Genios. So it's a three-tier architecture basically for monitoring systems. So it has an instrumentation layer, which has all your software agents that are called net probes, sit on all your monitoring system nodes. Monitoring system nodes are basically what all objects you want to monitor. What all different kind of objects, different kind of servers you want to monitor. Then it has an analysis and consolidation layer, which basically deploys all these net probes, these agent programs that you have set on your nodes, and they basically go and start monitoring what you want them to monitor by processing the data they're receiving from servers, from applications, from databases, from user activity, etc. And of course, then it has a visualization layer that basically is a console that lets you view the status of environment and any current alerts. These kind of monitoring tools usually have a very good UI. I mean, they would do a whole bunch of things in the background, but when you look at the user interfaces, they're pretty crisp. There's like a place for you to see things that need your immediate attention. They'll use a lot of color coding, to indicate something is amber, green, red, etc., etc. So this thing also has a console where you can see the status of different environments, where your net probes are deployed and what's that status. Everything is fine, everything's green. If there's a spike, when was the spike, what happened, did anything crash, how did it stabilize after that, and of course, any alerts that are being thrown on any of these nodes. This is an overview of the architecture. So these are basically your different consoles, your visualization layer. You can have multiple consoles viewing that. You can even have a phone or a tablet to view that. And then this is your analysis and consolidation layer, which has your different rules. What am I monitoring? Capturing data for monitoring, computing that, and also they have knowledge base based on what limits you have set, what you wanted to monitor, which off limits you wanted to monitor, and it does the appropriate database logging and sends out the appropriate notifications. And then these are your net probes, different nodes where your net probes are running, which are basically doing the monitoring for like 1, 2, 3 here, 3 here. These boxes represent your servers. See, very clean, easy to understand.
Hello everyone, welcome to Simplilearn's YouTube channel. In this full session, we will learn about Puppet, Chef, and Ansible from scratch, right from their installation to a full-fledged use case. We will begin the session with the comparison between Chef, Puppet, Ansible, and SaltStack. Followed by that, we will learn what is Chef. Then, we will learn the installation of Chef in our local system. Once the fundamentals are done, then we will start with the complete tutorial where you can learn Chef with us with the perfect hands-on experience. Next, in the same way, we will get started with Puppet. And lastly, we will have Ansible in the stack. And finally, we will wind up the session with the most frequently asked interview questions to make sure that you're on the safer side during your interviews. So I hope I made myself clear with the agenda. But before we begin, make sure that you have subscribed to our YouTube channel and don't forget to hit that bell icon to never miss an update from Simplilearn. So without further ado, let's get started.
Hello, this is Matthew with Simplilearn, and today we're going to go through a real tough battle. We're going to decide which is better for your operations environment. Is it Chef, Puppet, Ansible, or SaltStack? All four are going to go head to head. So let's go through the scenario of why you'd want to use these tools. So let's meet Tim. He's our system administrator, and Tim is a happy camper putting and working on all of the systems in his network. But what happens if a system fails? If there's a fire, a server goes down? Well, Tim knows exactly what to do. He can fix that fire really easily. The problems become really difficult for Tim, however, if multiple servers start failing, particularly when you have large and expanding networks. So this is why Tim really needs to have a configuration management tool, and we need to now decide what would be the best tool for him, because configuration management tools can help make Tim look like a superstar. All he has to do is configure the right codes that allows him to push out the instructions on how to set up each of the servers quickly, effectively, and at scale. All right, let's go through the tools and see which ones we can use. The tools that we're going to go through are Chef, Puppet, Ansible, and SaltStack. And we have videos on most of these software and services that you can go and view to get an overview or a deep dive in how those products work. So let's go and get to know our contestants. So our first contestant is Chef. And Chef is a tool that allows you to configure very large environments. It allows you to scale very effectively across your entire ecosystem and infrastructure. Chef is by default an open source code. And one of the things that you find as a consistent metaphor for the tools that we recommend on Simplilearn is to use open source code. The code itself is actually written in language of Ruby and Erlang, and it's really designed for heterogeneous infrastructures that are looking for a mature solution. The way that Chef works is that you write recipes that are compiled into cookbooks, and those cookbooks are the definition of how you would set up a node. And a node is a selection of servers that you have configured in a specific way. So for instance, you may have Apache Linux servers running, or you may have a MySQL server running, or you may have a Python server running. And Chef is able to communicate back and forth between the nodes to understand what nodes are being impacted and need to have instructions sent out to them to correct that impact. You can also send instructions from the server to the nodes to make a significant update or a minor update. So there's great communication going back and forth. If we look at the pros and cons, the pros for Chef is that there is a significant following for Chef, and that has resulted in a very large collection of recipes that allow you to be able to quickly stand up environments. There's no need for you to have to learn complex recipes. The first thing you should do is go out and find the recipes that are available. It integrates with Git really well and provides for really good, strong version control. Some of the cons, though, are really around the learning speed it takes to go from a beginner user with Chef to being an expert. There is a considerable amount of learning that has to take place, and it's compounded by having to learn Ruby as the programming language. And the main server itself doesn't really have a whole lot of control. It's really dependent on the communication throughout the whole network. All right, let's look at our second contender, Puppet. And Puppet is actually in many ways very similar to Chef. There are some differences, but again, Puppet is designed to be able to support very large heterogeneous organization. It is also built with Ruby and uses DSL for writing manifests. So there are some strong similarities here to Chef. As with a Chef, there is a master-slave infrastructure with Puppet, and you have a master server that has the manifests that you put together in a single catalog, and those catalogs are then pushed out to the clients over an SSL connection. Some of the pros with Puppet is that, as with Chef, there is a really strong community around Puppet, and there's just a great amount of information and support that you can get right out of the gate. It is a very well developed reporting mechanism that makes it easier for you as an administrator to be able to understand your infrastructure. One of the cons is that you have to really be good at learning Ruby again, as with Chef. The more advanced tasks really need to have those Ruby skills. And as with Chef, the server also doesn't have much control. So let's look at our third contender here, Ansible. And so Ansible is slightly different. The way that Ansible works is that it actually just pushes out the instructions to the server environment. There isn't a client server or master slave environment where Ansible would be communicating backwards and forwards with its infrastructure. It is merely going to push that instructions out. The good news is that the instructions are written in YAML, and YAML stands for YAML Ain't Markup Language. YAML is actually pretty easy to learn. If you know XML, and XML is pretty easy, if you know XML, you're going to get YAML really well. Ansible does work very well on environments where the focus is getting servers up and running really fast. It's very, very responsive and can allow you to move quickly to get your infrastructure up very fast. And we're talking seconds and minutes here, really, really quick. So again, the way that Ansible works is that you put together a playbook and an inventory, or you have a playbook. So the way that Ansible works is that you have a playbook, and the playbook, it then goes against the inventory of servers and will push out the instructions for that playbook to those servers. So some of the pros that we have for Ansible: we don't need to have an agent installed on the remote nodes and servers. It makes it easier for the configuration. YAML is really easy to learn. You can get up to speed and get very proficient with YAML quickly. The actual performance, once you actually have your infrastructure up and running, is less than other tools that we have on our list. Now, I do have to add a proviso. This is a relative less. It's still very fast. It's going to be a lot faster than individuals manually standing up servers, but it's just not as fast as some of the other tools that we have on this list. And YAML itself as a language, while it's easy to learn, it's not as powerful as Ruby. Ruby will allow you to do things that at an advanced level that you can't do easily with YAML. So let's look at our final contender here, SaltStack. So SaltStack is a CLI-based tool. It means that you will have to get your command line tools out or your terminal window out so you can actually manage the entire environment via SaltStack. The instructions themselves are based on Python, but you can actually write them in YAML or DSL, which is really convenient. And as a product, it's really designed for environments that want to scale quickly and be very resilient. The way that SaltStack works is that you have a master environment that pushes out the instructions to what they call grains, which is your network. And so let's step through some of the pros and cons that we have here with SaltStack. So SaltStack is very easy to use once it's up and running. It has a really good reporting mechanism that makes your job as an operator in your DevOps environment much, much easier. The actual setup, though, is a little bit tougher than some of the other tools, and it's getting easier with the newer releases, but it's just a little bit tougher. And related to that is that SaltStack is fairly late in the game when it comes to actually having a graphical user interface for being able to create and manage your environment. Other tools such as Ansible have actually had a UI environment for quite some time. All right, so we've gone through all four tools. Let's see how they all stack up next to each other. So let the race begin. Let's start with the first stage, architecture. So the architecture for most of our environments is a server-client environment. So for Chef, Puppet, and SaltStack. So very similar architecture there. The one exception is Ansible, which is a client-only solution. So you're pushing out the instructions from a server and pushing them out into your network. And there isn't a client environment. There isn't a two-way communication back to that main client for what's actually happening in your network. So let's talk about the next stage, ease of setup. So if we look at the four tools, there is one tool that really stands out for ease of setup, and that is Ansible. It is going to be the easiest tool for you to set up. And if you're new to having these types of tools in your environment, you may want to start with Ansible just to try out and see how easy it is to create automated configuration before looking at other tools. Now, and so with that said, Chef, Puppet, and SaltStack aren't that hard to set up either. And you'll find there's actually some great instructions on how to do that setup in the online community. Let's talk about the languages that you can use in your configuration. So we have two different types of language, with both Chef and Ansible being procedural in that they actually specify how you're actually supposed to do the task in your instructions. With Puppet and SaltStack, it's decorative, where you specify only what to do in the instructions. Let's talk about scalability. Which tools scale the most effectively? And as you can imagine, all of these tools are designed for scalability. That is the driver for these kind of tools. You want them to be able to scale to massive organizations. What do the management tools look like for our four contenders? So again, we have a two-way split. With Ansible and SaltStack, the management tools are really easy to use. You're going to love using them. They're just fantastic to use. With Puppet and Chef, the management tools are much harder to learn, and they do require that you learn some either the Puppet DSL or the Ruby DSL to be able to be a true master in that environment. But what does interoperability look like? Again, as you'd imagine, with the similar to scalability, interoperability with these products is very high in all four cases. Now, let's talk about cloud availability. This is increasingly becoming more important for organizations as they move rapidly onto cloud services. Well, both Ansible and SaltStack have a big fail here. Neither of them are available in the most popular cloud environments. And Puppet and Chef are actually available in both Amazon and Azure. We've actually just haven't had a chance to update our Chef link here, but Chef is now available on Azure as well as Amazon. So what does communication look like with all of our four tools? So the communication is slightly different with them. Chef has its own knife tool, whereas Puppet uses SSL, so Secure Sockets Layer, and Ansible and SaltStack use Secure Socket Hashing, SSH, as their communication tool. Bottom line, all four tools are very secure in their communication. So who wins? Well, here's the reality. All four tools are very good, and it's really dependent on your capabilities and the type of environment that you're looking to manage that will determine which of these four tools you should use. The tools themselves are open source, so go out and experiment with them. There's a lot of videos. Our team has done a ton of videos on these tools, and so feel free to find out other tools that we have and covered so you can learn very quickly how to use them. But consider the requirements that you have and consider the capabilities of your team. If you have Ruby developers or you have someone on your team that knows Ruby, your ability to choose a broader set of tools becomes much more interesting. If, however, you're new to coding, then you may want to consider YAML-based tools. Again, the final answer is going to be up to you, and we'll be really interested on what your decision is. Please post in the comments below which tool you have decided to go with and what are the challenges that you're coming up with, because we'll help answer those challenges for you. Today, we're looking at how we can use Chef to improve the way that you administer hardware within your DevOps environment. There's going to be 6 things that we're going to step through. The first is really looking at what is the world that many of you already work in today? How do you administer your networks and your systems today? Then we're going to look at how Chef can be the tool that really helps improve the efficiencies of creating a consistent operations environment. We're going to look at the tools and the components and the architecture that it takes to construct Chef. And then finally, we're going to take a use case of one of the many companies that is using Chef today to improve the efficiency of their operations environment. So let's take a step back at what life was like before Chef. This may well be the life that you're experiencing right now. So as a system administrator, typically the way that you work is that you are responsible for the uptime of all of the systems within your network. And you may have many systems that you are responsible for. Now, if one system goes down, that's not a problem, because as a system administrator, you can get notifications and you can jump right onto the problem and solve it. When things start getting really difficult, however, is when you have multiple systems and you are not able as a single person to get to all those systems and solve them as quickly as possible. The problem that you start having is that your environments are not in sync. If only this could all be automated. Well, this is where Chef comes to the rescue for you. So let me take some time and introduce you to the concepts behind Chef and why it's a tool that you would probably want to be using in your environment. So what actually is Chef? So Chef is a way in which you can use code to fix your physical hardware environment. So what does that look like? Well, the way that we write out scripts in Chef is that you can actually code your entire environment. So you don't have to actually be managing your environment on a hardware by hardware basis, but actually use scripts called recipes that will actually manage the environment for you. So Chef will actually ensure that every system is automatically set to the right states that meet the requirements that you have defined in your code. So you don't have any issues where hardware starts to fail because it references the code to reset the state within that environment. And that makes you a happy system administrator. So let's go through the mechanics of how this actually works with Chef. So Chef is ultimately an automation tool that converts infrastructure to code. And you'll often hear the term infrastructure as code, or IAC. And this really starts as an output of the work that Chef has done. Because you take the policies that you as an organization have created and you convert that into a scripted language that can then be implemented automatically. This enables Chef to be able to manage multiple systems very easily. And considering how broad and deep our systems become, it's very easy to see how this can help you as a system administrator. The code is then tested continuously and deployed by Chef so that you're able to guarantee that your standards and appropriate states for your hardware and operating environment are always maintained. So let's step through the different components that are available in Chef. So the first one is actually creating the actual recipes for Chef. So you actually work on these on a workstation and you'll write out your code, which is referred to as a recipe. And that recipe will be written using a language called Ruby. Good thing for you is that there are lots of examples of Ruby recipes that have been created by the open source community. A lot of examples. Knife is the command tool that you use that communicates between the recipes and the server. So your recipe is the instruction and Knife is the tool that makes that instruction work and sets the appropriate state on the server environment. When you create more than one recipe, you start creating a collection. Those collections are referred to as cookbooks. And you may take an environment such as a large network where you have multiple nodes, potentially hundreds of servers that have to all have a consistent and equal state environment. And you would put that cookbook and use that cookbook to ensure with Chef that the state of each of those nodes is consistent. And then Ojai fetches the current state of your nodes, and then the Chef client configures the nodes as defined within your cookbook. So let's step through the architecture and working environment of Chef. So for an administrator, a systems administrator, you only have to now work from your workstation. And from that workstation, you can then configure all the nodes of your environment. You can use different recipes that you create, and those recipes can be compiled into a cookbook that can be then applied to a node. The thing that's of value is that as you change the environment, as you move and mature as an organization, and your nodes need to mature consistently and quickly with your organization, all you have to do is roll out a different recipe to your nodes, and then the nodes will use the tools within Chef to make the updates. So you can create a second recipe or even a third recipe to be deployed out to your server environment. Knife is going to be the tool that does the hard work of doing the updates on the server. With the server, you have your collection of recipes in a single cookbook. However, understanding the state of the individual nodes is important to ensure that the information is broadcast from the server with the instructions on how to set up the network within those nodes. In this instance, we use Ohai, and Ohai will fetch the state of the nodes and send that back to the server and get the information from the cookbook using the Chef client. In your Chef node network, there is the potential at times that maybe one of your node fails. If there are 2 failed nodes, then a request is sent back to the server, and information on the latest node structure that is identified and defined in the cookbook will be sent to the failed nodes. If that fails to reset the nodes, then the workstation is notified, and you as the administrator will receive a notification to manually reset those nodes. It should be noted that this is a very rare occasion within the Chef network setup. So let's step through a use case. In this instance, we're going to look at Hapoleum and how they used Chef. So Hapoleum is a bank, and it's the largest bank in Israel. And they have a mixture of Linux and Windows servers that they have to maintain. And as you can imagine, this requires a lot of constant configuration and work, and this has led to issues in the past. So the challenge that the team at Hapoleum faced was creating and hardening software that ran the major tasks and was repeatable on those servers, that it didn't matter who the people were performing the jobs, that there was consistency in the work that was being done, and address the problem that the servers, including the hardware on the servers, was not consistent throughout the organization. Chef addresses those specific problems and became the go-to product for Hapoleum. They were able to write the recipes and the cookbooks that could be deployed out to the network effectively. And it didn't matter what the system was, the recipes reflected the standards that the system administration team put together. And they were able to ensure and test each script and use standard testing tools for those scripts. It didn't matter what kind of environment that Hapoleum had, if certain ports need to be closed, or if a firewall needs to be installed or modified, or if custom strong passwords had to be created. All of this could be done using the recipes that Chef offers. And once those recipes had been finalized, they could be packaged into a common cookbook that could then be deployed to the entire network, ensuring a consistency in results for the company. And also, it didn't matter whether the cookbooks were being deployed to Linux or Windows machine, because the scripts were being put together in the recipes and were written in Ruby. You could actually go through and update and modify those scripts depending on the environment. So if you needed to make a modification for Linux, you could make those modifications so they were consistent across all the Linux servers or all the Windows servers. And this really drove in the ability to harden and secure the environment in the entire network within a matter of minutes using Chef versus the days and weeks that it previously took. So if we take a before and after scenario using Chef, before Chef, tasks were repeated multiple times, and it was just hard to keep track of all the people doing the work. And the reality is, because so many people were touching all the different systems, specific standards that the banks had established were simply not being met. After Chef, all of the tasks could be scripted using Ruby, and using the recipe and cookbook model that Chef has created, the Chef tool was able to deploy out to the entire network specific cookbooks that provided a consistent experience and consistent setup and operation environment for all the hardware. The end result is that the system administration team could guarantee that the standards of the bank were being met consistently. So just the takeaways that we have here of Chef. So life before Chef is complicated. If one server goes down, you can probably get it back up and running. But if you are working in a modern system administration environment, you have many systems, and if multiple systems start going down or having failure points, it is difficult to identify where those failure points are and how to solve them. Chef resolves this issue, and it does so by turning the environment that you're managing with hardware and software into code. And once you have it written as code, you're able to then test that code. Chef itself is made up of a number of key components. As a system administrator, you work on your desktop at your workstation and you create recipes. Those recipes are then bundled together into a cookbook. And that cookbook communicates with the server, the main Chef server, and the node of servers within your environment. And Knife is the tool that does that communication. Ohai and the Chef client on the various node servers will communicate back to the Chef server what the standards and the environment are, so that they can provide a two-way communication to validate that the system has been set up and is being maintained to the same standards as defined by the individual recipes. As an architect and working in this Chef environment, it makes it much easier for you to be able to control the entire system administration. Instead of having many people having to work on all the servers, you can now have one person controlling hundreds of servers simultaneously. And at Polum have been able to prove conclusively that Chef is the tool that can help improve the consistent experience of working with hardware.
A very warm welcome to all our viewers. This is Anjali from Simplilearn, and today we'll be looking at the installation for the tool Chef. As you probably already know, Chef is a configuration management tool. So that basically means that Chef is a tool which can automate the entire process of configuring multiple systems. It also comes with a variety of other functionalities which you can check out in our video on what is Chef and the Chef tutorial. So before we move on to the installation process, let me just explain to you in brief the architecture of Chef. So Chef has three components. There's the workstation, which is where the system admin sits, and he or she writes the configuration files here. Your second system is the server. The server is where all these configuration files are stored. And finally, you have the client or the node systems. So these are the systems that require the configuration. You can have any number of clients, but for our demo, to keep it simple, we'll just have one client. Now I'm using my Oracle VM VirtualBox Manager, as you can see here. I'll have two machines, the master and the node. Both of these are CentOS 7 machines. As of the server, we'll be using this as a service on the cloud. So let's begin. Let's have a look at our master system first. This is my master system. The terminal's open over here, and the terminal color here, it's black background with green text. And this is my node system. So the terminal here has a black background with white text. So you can differentiate between the both. So we start at our master system. The first thing we need to do is we need to download the Chef DK. So you can write wget, which is the command for downloading, and then go to your browser and just type Chef DK here. The first link. So here you have different versions of Chef DK. Depending on the operating system that you're using, you need to select the appropriate one. I'm using the Red Hat Enterprise version, and that's number 7. So I'm using CentOS 7. So this is my link for downloading Chef DK. Just copy this link and go back to your terminal and paste it here. So your Chef DK is being downloaded. This will take a while. Right after we download the Chef DK, our next step is to install it on our system. So our Chef DK is downloaded. Now let's install it. So guys, this is the version of Chef DK that you have downloaded. So make sure this is exactly what you type down here too. So great, our Chef DK is installed. So basically our installation for the workstation is done right now. But just so you understand how the flow is, we'll also write a sample recipe on our workstation. So before we do that, let's first create a folder. My folder name Chef Repo, basically the Chef repository. And let's move into this folder. Okay, so we're in. Next, what we need to do is, as I mentioned earlier, all your recipes will be within a cookbook. So let's create a folder which will hold all our cookbooks. And let's move into this too. Okay, so our next stage is to create the actual cookbook within which we'll have our recipe. So the command for creating the cookbook is chef generate cookbook sample. So sample is the name of my cookbook. So guys, please notice here, cookbooks is the directory that I created, which will hold all our cookbooks. And here cookbook is the keyword. So sample is that one cookbook that we are creating under our folder cookbooks. And our cookbook's being created. Great, so that's done. Moving into our cookbook. Okay, so when our cookbook sample was created, automatically there's this hierarchical structure associated with it. So let's have a look at this hierarchical structure to understand what our cookbook sample exactly is before we move on. So the command for looking at a hierarchical structure is tree. So as you see here, within our cookbook, we have a folder recipes, and under this there's the default.rb recipe. This is where we'll be creating our recipe. So we'll just alter the content of default.rb. So let's move on to finally writing our recipes. So we'll move into this recipes folder first. So now we'll open our recipe default.rb in gedit. So the recipe for this particular demo is to install the HTTPD package on our client node, that is basically your Apache server, and we'll also be hosting a very simple web page. So let's begin. So the recipes in Chef is written in Ruby. So I'll explain you the recipe in a while. Okay, so the first line is where you install HTTPD. The second line for service is where you start or enable the HTTPD service on the client node. That's our first task. The second part's where we need to create our web page. So this is the part where your web page will be stored. If you have written any HTML file previously, you know that this is probably like a default path where our web pages are created. Yep, that's it. So this is the content that will be displayed on your web page if everything works right. And I'm pretty sure it will. So now we can save our recipe, and that's done. Close your gedit. So now that we have created the recipe, all our work at the workstation is completed. The next thing we do is we move on to the server. So as I mentioned earlier, we'll be using the server as a service on the cloud. So go to your browser and here just type manage.chef.io. So this is the home page of your Chef server. Click here to get started. We need to first create an account for using the Chef server. This is completely free. We just need to give our email ID and a few other details. It's in fact a lot like creating an account on Facebook or Instagram. Fill in all the details. Check the terms of service box. So the next thing you need to do is go back to your inbox and verify your email ID. So I have my inbox opened here on my Windows machine. So this is my inbox. You would have received a mail from Chef Software. Just click on this link to verify it and create your password. And that's done. So let's continue this on our workstation machine. So type in your username and password. So the first time you log into your Chef server, you'll have this pop-up appear where you need to create a new organization. So create your organization. So this organization is basically the name that will be associated with a collection of the client machines. First thing you do, go to your administration tab and download the starter kit. So guys, when you're doing this part, make sure that you're on your workstation. That is, you're opening your Chef server on the workstation because you need this folder to be installed here. You save the file. So this gets downloaded. So the Chef Starter Kit is the key to connecting your workstation with the server and the server with the node. So basically it has a tool called Knife, which we'll come across later in our demo. This Knife is what takes care of all the communication and the transferring of cookbooks between the three machines. In our case, the two machines, the workstation and the node, and the one server. So let's go back to our root directory. So our Chef Starter zip file is within our downloads folder. What we do first is we'll move the zip folder into our cookbooks folder and then we'll unzip it there, because our cookbooks folder is the one that contains the recipe, and that is where we require knife tool command to be present so we can send these recipes over to the server. So we'll just check the contents of our cookbooks right now to ensure that our Chef Starter.zip file is within the cookbooks. Yep, so it's here. So next thing we do is we need to unzip this folder. Great, so that's unzipped. And this means that our workstation and our server are now linked. So we just need to use the knife command tool to transfer or to upload our recipes, which we created on the workstation, onto the server. So before we execute this command, we need to move into our cookbooks directory. As you know, that is where we unzipped our Chef Starter Kit. So that is where our knife command is present too. And now let's execute the knife command. So it's knife, cookbook, upload, and sample. So as you probably recall, sample is the name of the cookbook that we created. And within sample, we created our recipe, which is default.rb. So we're uploading the entire cookbook onto the server. Execute the command. Great, so our cookbook's uploaded. Now let's check this on our server. So move to your browser where you opened your Chef's server and go to policy. So here you go. This is the cookbook we uploaded, sample. And it's the first time we uploaded it. So the version 0.1.0, the first version. Now what you would notice is if you go to the nodes tab, there are no nodes present. So if you have no nodes, you basically have no machine to execute your cookbooks. And the nodes are not seen right now because we have not configured them yet. So that's the next thing we need to do. All this so far was done on your master machine. Now we'll move on to the node machine. So before moving on, let's just check the IP of our node machine. So that's our IP. Note this down somewhere. And now we move back to our workstation. As we already saw that we uploaded a sample workbook, next thing we need to make sure that our server and node are able to communicate with each other. So again, we use the knife tool for this too. The command here is knife, bootstrap, and enter the IP address of your node, which we just checked. We'll be logging in there. So we'll be using the node as the root user. And then we also need to specify our root password for the node. And we give a name to this node. So this is the name by which we'll be identifying our node at the server. So as you have probably noticed here, we're using the term SSH, which is a secure shell. So it basically provides a channel of secure communication between two machines in an unsafe environment. Okay, so it's done. So if your command has executed right, which in our case, as we can see, has, our Chef server and our Chef node must be able to communicate with each other. So if this is so, we should be able to send the cookbook that we previously uploaded from our workstation onto the server, now from our server to our node. So to do that, before we move on to the node machine, we need to go back to our Chef server. Let's refresh this page. And as you see here, previously under the nodes tab, we did not have any node mentioned. Now we do. Chef node, which is the node we wanted to identify our node by, which is a CentOS platform. And that's our IP. So it's active for 2 hours. That's the uptime. Last check-in. The last time we checked into our node was a minute back. And yeah, that's pretty much it. So now we'll create a run list and we'll add our sample to this run list. So just click on your node and you'll see the small arrow here in the end. Click on that, edit run list, and under available recipes, we have our cookbook sample present. So drag and drop this to the current run list and accept it. Okay, so now that we updated our run list, our recipe is sent to our node. What we next need to do is that we need to execute this at our node. So now we'll move on to our node machine. Chef client is the command to execute your. So while this recipe is executing, you can see what exactly is happening. Our recipe was to install HTTP package first, which is your Apache server. So the first line, that's done and it's up to date. The second line, it's enabled. Third line, the service is started. And the fourth line is where your contents created for the web page at this very location. So by the look of this, everything should work fine. So how do we check this? We can just go to our browser and in the search bar, just type localhost. And there you go. So our HTTP package, which is the Apache server, is installed and our sample web page is also hosted. If you look at the DevOps approach or the DevOps lifecycle, you will see that Chef falls under operations and deployment. So before we begin, let's have a brief look at all that you'll learn today. First, we'll get to know why should we use Chef and what exactly is the Chef. Two of the most common terms used with Chef: configuration management and infrastructure as code. We'll have a brief look at these. We'll also have a look at the components of Chef and the Chef architecture, quickly go through the various flavors of Chef, and finally we'll wrap it up with a demo on the installation of Apache on our nodes. So let's begin, guys. Why should we use Chef? Well, consider a large company. Now this company caters to a large number of clients and provides n number of services or solutions. Of course, to get all of this done, they need a huge number of servers and a huge number of systems. Basically, they will have a huge infrastructure. Now, this infrastructure needs to be continuously configured and maintained. In fact, when you're dealing with an infrastructure that size, there's a good chance systems may be failing. And in the long run, as your company expands, new systems may even get added. So what do? Well, you could say the company has the best system administrator out there, but all by himself, could he possibly take care of an infrastructure that size? No, he can't. And that's where Chef comes in, because Chef automates this entire process. So what does Chef provide? Chef provides continuous deployment. So when you look at the market space today, you see how products and their updates are coming out in a matter of days. So it's very important that a company is able to deploy their product the minute it's ready, so that once it's out, it's not already obsolete. Chef also provides increased system robustness. As we saw, Chef can automate the infrastructure. But in spite of this automation, there's a good possibility that errors do creep in. Chef can detect all these bugs and remove them before deploying them into the real environment. Not only this, Chef also adapts to the cloud. We all know how today the services, tools, solutions, everything's revolving around the cloud. So Chef does really play along by making itself easily integratable with the cloud platform. So now that you know why to use Chef, let's look at what exactly is Chef. Chef is an open source tool developed by OpsCode. Of course, there are paid versions of Chef, such as Chef Enterprise, but other than that, most of it is freely accessible. Chef is written in Ruby and Erlang. If you would have gone through any previous material on Chef, I'm sure you would have come across Ruby being related to Chef, but not Erlang. So this is why, because Ruby and Erlang are both used to build Chef, but when it comes to actually writing the codes in Chef, it's just Ruby. And these are the codes that's deployed onto your multiple servers and does the automatic configuration and maintenance. And this is why Chef is a configuration management tool. So I've used this term configuration management a couple of times. What exactly does this mean? Let's start with the definition of configuration management. Configuration management is a collection of engineering practices that provides a systematic way to manage entities for efficient deployment. So let's break this down. Configuration management basically is a collection of practices. And what are these practices for? These practices are for managing your entities, the entities which are required for efficient deployment. So what are these entities that you need for efficient deployment? They are code, infrastructure, and people. Code is basically the code the system administrators write for configuring your various systems. Infrastructure is the collection of your systems and your servers. And then finally, you have the teams that take care of this infrastructure. So codes need to be updated whenever your infrastructure needs a new configuration or some sort of updation in the operating system or the software versions. Your code needs to be updated at first. And as the requirements of the company change, the infrastructure's configuration needs to change. And finally, of course, the people need coordination. So if you have a team of system administrators and say person A makes some change to the code, person B, C, D and so on need to be well aware when the change is made as to why it was made, what was the change made and where exactly this change was made. So there are two types of configuration management. On our left, we have the push configuration. Here the server that holds the files with instructions to configure your nodes pushes these files onto the node. So the complete control lies with the server. On your right side, we have the pull configuration. In case of pull configuration, the nodes poll against the server to first check if there's any change in the configurations required. If there is, the nodes themselves pull these configuration files. Chef follows pull configuration, and how it does this, we'll see further in our video. Another important term often used with Chef, infrastructure as code. So let's understand what this term infrastructure as code means through this small story. So here's Tim. Tim's a system administrator at a large company. Now he receives a task. He has to set up a server and he has to install 20 software applications over it. So he begins. He sets up the server, but then it hits him. It would take him the entire night to install 20 software applications. Wouldn't things have been much simpler if he just had a code to do so? Well, of course, codes do make things much simpler. Codes have a number of advantages. They're easily modifiable. So if today Tim is told we need MySQL installed on 20 systems, Tim simply writes a code to do so. And the very next day Tim is told, we changed our mind. We don't need MySQL. I think we'll just use Oracle. This does not bother Tim because now he just opens the file, he makes a few corrections in his code and that should work just fine. Code is also testable. So if Tim had to write 10 commands to do something and at his 10th command he realized the very first command he wrote, there was something not right there. Well, that would be quite tiresome, wouldn't it? With codes, however, you can test it even before running it and all the bugs can be caught and corrected. Codes are also deployable. So they're easily deployable and they're deployable multiple times. So now that we saw the various advantages of having codes, let's see what infrastructure as code exactly is. Here's the definition. Infrastructure as code is a type of IT infrastructure where the operation team manages the code rather than a manual procedure. So infrastructure as a code allows the operations team to take care of a code which automatically performs various procedures rather than having to manually do those procedures. So with this feature, all your policies and your configurations are written as code. Let's now look at the various components of Chef. So our first component is the workstation. The workstation is the system where the system administrator sits. He or she creates the codes for configuring your nodes. Now these codes, which in case of Chef are written in Ruby, are called the recipes. And you'll have multiple number of recipes. So a collection of recipes is called a cookbook. Now these cookbooks are only created at the workstation, but they need to be stored at the server. So the knife is a command line tool. So it's basically a command that you will see us executing in one of our demos that shifts these cookbooks from the workstation over to the server. A second component is the server. So server is like the middleman. It lies between your workstation and your nodes. And this is where all your cookbooks are stored. Because as you saw previously, the knife sends these cookbooks over from the workstation to the server. The server can be hosted locally, that's on your workstation itself, or it can be remote. So you can have your server at a different location. You can even have it on the cloud platform. And a final component, the node. So nodes are the systems that require the configuration. In a Chef architecture, you can have a number of nodes. Ohai is a service which is installed on your node and it is responsible for collecting all the information regarding your current state of the node. This information is then sent over to the server to be compared against the configuration files and check if any new configuration is required. Chef Client is another such service on your node which is responsible for all the communications with the server. So whenever the node has a demand for a recipe, the Chef Client is responsible for communicating this demand to the server. Since you have a number of nodes in a Chef architecture, it's not necessary that each node is identical. So of course, every node can have a different configuration. Let's now have a look at the Chef architecture. So here we have a workstation, one server machine and 2 nodes. You can have any number of nodes. First things first, the system administrator must create a recipe. So the recipes that are mentioned in our Chef architecture are just dummy recipes. We'll look into actual functioning recipes later in our demo. So you have 1 recipe, 2 recipes, 3 recipes, and a collection of recipes forms a cookbook. So guys, if you look at the recipe, in source you have Simplilearn 3.erb. ERB is the extension for your Ruby files. So the cookbooks are only created at the workstation. They now need to be sent over to the server where they are stored. And this is the task of the knife. Knife is a command line tool which is responsible for transferring all your cookbooks onto the server from the workstation. Here's the command for running your knife. Knife upload simply-db, where simply-db is the name of the cookbook. We then move on to our node machines. At our nodes, we run the OHI service. The OHI service will collect all information regarding the current state of your nodes and send it over to the Chef client. When you run the Chef client, these informations are sent over to the server and they are tested against the cookbooks. So if there is any discrepancy between the current state of your nodes and the cookbook, that is, if one of the nodes does not match the configurations required, the cookbook is then fetched from the server and executed at the node. This sets the node to the right state. There are various flavors of Chef. We'll quickly go through these. First, we have Chef Solo. With Chef Solo, there's no separate server, so your cookbooks are located on the node itself. Now, this kind of configuration is used only when you have just a single node to take care of. The next flavor is a Hosted Chef. With Hosted Chef, you still have your workstation and your node, but your server is now used as a service on the cloud. This really makes things simple because you don't have to set up a server yourself and it still performs all the functioning of a typical Chef. This is the configuration you will notice that we'll be using in our demo. Chef Client Server. With Chef Client Server, you have a workstation, you have server, and you have n number of nodes. Now, this is the traditional Chef architecture. This is the one we have used for all the explanations previously. And finally, we have Private Chef. Private Chef is also known as Enterprise Chef. In this case, your workstation, server, and node all are located within the enterprise infrastructure. This is the main difference between Chef Client Server and Private Chef. In case of Chef Client Server, all these 3 machines could be dispersed. The enterprise version of Chef also provides the liberty to add extra layers of security and other features. And we reach the final part of our video where we'll have the hands-on. So before we dive into our demo, let me just quickly give you an introduction to it. We'll be using 2 virtual boxes, both CentOS 7. One will be used as a workstation while the other will be a node. So we are just using one node to make things simple. The server will be used as a service on the cloud. Now these are the steps we'll be performing during our demo. We'll first download and install the Chef DK on our workstation. We then make an empty cookbook file and we'll write a recipe into it. We need to then set up the server. So as I mentioned earlier, server will be a service on the cloud. So you'll have to create a profile, but this will be completely free. We then link the workstation to the server and will upload the recipe to the server. The nodes will now download the cookbooks from the server and configure themselves. So now that you have some idea about what we'll be doing, let's move on to the actual demo. We begin our demo. Here's my Oracle VM VirtualBox Manager. I have 2 machines here. I've already created my workstation and node. Both of these are CentOS 7 machines. Just for you to differentiate, this is my terminal. And for my workstation, it's a black background with white text. And as of my node, it's a black background with green text. The first thing you do is you go to your workstation box and open a web browser. Search for Chef DK Installation. go to the first link, which is your chef's official page, and under Red Hat Enterprise, because our system's a Red Hat system, select the link of the version that you're using. So I'm using CentOS 7. So my operating system version is 7. So I'll take this link. Now this is the link for downloading your Chef DK. You copy this link and go to your terminal. Guys, notice I'm in the home directory of my root user. So let's install our Chef DK. And it's getting installed. Now this will take some time because it's quite a large file. And ChefDK is downloaded. Next step, we need to install it. And this is the version of the ChefDK that we have downloaded. So type the same. Okay, so that's done. So now we need to make our recipes, and the recipes will exist within cookbooks. So first let's make a chef repository. So within that we'll have a folder for holding all our cookbooks, and within our cookbook we'll write our recipe. So we start with the directory for chef repository. Move into it. Create a folder called cookbooks, within which we'll store each of our cookbooks. Move into this folder. Okay, so we'll just check the contents here right now. So we have our Chef DK, we have a Chef repo folder here, and let's check the contents of the Chef repo. And this has cookbooks. Okay, so our first cookbook that we'll be making will be under this folder cookbooks. So let's move into cookbooks. We are in. Now we need to create our first cookbook. So the instruction for creating your first cookbook is chef generate cookbook and the name of your cookbook. So I'm just giving the name as sample. Yeah, so our cookbook sample is created. Now when you create your cookbook, you'll notice that a hierarchy is also automatically created. So let's just check the hierarchy of our cookbook. Let's move into sample, and tree is the command for checking the hierarchy. So here, as you can see, we have recipes, and under recipes we have default.rb. So we'll be editing this default.rb to create our recipe. Okay. So let's begin with that. Let's move into our recipes folder and open your default.rb. And here we are. So now we'll type in our code. So what's our recipe for? Our recipe is for installing the HTTPD package on our node, and then we'll also create a small index file where we'll just have a simple content such as welcome or something like that, just to check if our HTTPD is working fine. So let's begin typing the code here. Package HTTPD service HTTPD do. And what must be done with this package is that once it's installed, it needs to be enabled and it needs to be started. And so that's our first task. Our next task is creating our HTML file. So as you know, all your HTML files will follow this path name. And this is the content of your file. You have successfully configured your node. And that's it. That's our simple code. So our recipe is now ready. Save it and exit back to your terminal. Now what we need to do is that we need to configure our server. So go to your browser. On the search engine, type manage.chef.io. So as I mentioned earlier, we'll be using a server as a service on the cloud. So you'll enter your login page for the Chef server, Most of you may not have a profile already, so you go to click here to get started and fill in the details. It's just like creating an account on Facebook. So I already have my account. I've put in the credentials here. I'll just sign in. Now the first thing once you sign in is you'll get an option to create an organization. So all you have to do there is you gotta enter the name of your organization, and just below that there's another box for entering a short form of your organization. Now my organization name was Simplilearn and the short form was SLP123. So when you come to the administration tab under organization, you can see this organization name. Next step, click on this arrow and you got to download your starter kit. Okay, so once you click on starter kit, you'll come to this page where there's a button for download starter kit. So do download it. Save the file. So now come back to your terminal. So you come back to your terminal, and next what you need to do is you need to unzip your chef starter.zip. So for that, first we'll move our chef starter to the root. So it's currently present under the downloads folder. Let's move it. So we have moved our chef starter.zip. Now let's unzip it. First, let's just check the contents of our root directory right now. So we have our chef repository, chef repo folder that we created, the chef starter zip that we just moved, and of course the chef DK. So now we can unzip our chef starter kit. And that's done. So our next step, we got to move the chef starters.zip file into our cookbooks, which lies inside the chef repository. This is done because we'll be executing our further commands to connect our workstation with the server from the cookbooks, because that is where our sample cookbook is. And that's moved. So now we'll run a knife command. So what knife does is that it uploads your recipes or your cookbooks onto the server. So here's the command for running your knife. Samples the name of the cookbook that you're uploading, and uploading sample 0.1.0 and uploading sample. Yeah, so our cookbook is uploaded. Now let's just check this at our server. How we do that is go back to your browser where you have opened your server. So there's no node here yet because we have not configured our node with the server, but we have configured our workstation with the server. And you see here our cookbooks uploaded, sample. So our workstation and our server are connected. So now we need to connect our node with the server. So first we move on to our node machine. We need to take the IP address of our node machine. So for the IP address, we'll just type if config. Right, so this is your IP address. 192.168.2.190. Note this down somewhere, guys. Now that's done, go back to your workstation. I'll just keep it this way so I can see both. Okay. Go back to your workstation's terminal, but this time to connect our server with the node. So we have taken the IP of our node, and this is where we'll be using it. 192.168.2. The username, which is root in our case, and then enter the password, and then finally you enter your node name. So this is the name that will appear for this particular node on our server. I'm just giving it chef node. You can give it whatever you like. We'll just check the command knife bootstrap, the IP address, SSH user, our user, which is root, SSH password, the password for the root, and finally the node name. And the node's getting created. So once the node is connected to your server, we'll go back to our browser, open our server service on the cloud, and we'll check the node tab. So ideally, your node name should appear there. Great. So our node is added. Also, if you notice here, our Chef client service on the node has started running. So let's just check this with the server. Go to your nodes. And here we go. So Chef node, a CentOS 7 platform. This is our IP. So it's all done. So now we need to add a cookbook to the run list of this node. So come here, click on this arrow, edit run list. Here's sample. This is the cookbook that we want to run on our node. Put on the current run list. And here we have the run button. Just click on that. So this should have transferred our cookbook onto the node. Let's check that. Go to your node machine. Clear this. We need to be the root. Let's run the Chef client service. So we are running it once again because after it was started, we did add something to our run list. The changes in the run list is updated. So in 1 minute 56 seconds, our cookbook has run on our node. So the configuration changes should have been made. Let's check that. It's pretty simple. Just go to your browser. On the search engine, just type localhost. And here's our HTML page that we created on our workstation. Congrats, you configured your first node. And I really hope you did. So that is the end of our demo. We have successfully installed the HTTPD package on our node, and we have also executed a HTML file. So with that, we come to an end to our video. Now let's have a quick look at everything you learned today. First, you saw why you should probably use Chef. Then what exactly is the Chef? We looked into the two most important terms often used with Chef, configuration management and infrastructure as code. We also saw the various components of Chef and how these components work together to provide the capabilities that Chef does. We looked into the 4 flavors of Chef, and finally we wrapped it up with the demo on installing HTTPD package on our node and also writing a simple HTML file.
Hello, this is Matthew from Simplilearn. We're going to focus specifically on Puppet. So in this session, what we're going to do is we're going to cover what and why you would use Puppet. What are the different elements and components of Puppet and how does it actually work? And then we'll look into the companies that are adopting Puppet and what are the advantages that they have now received by having Puppet within their organization. And finally, we'll wrap things up by reviewing how you can actually write a manifest in Puppet. So let's get started. So why Puppet? So here is a scenario that as an administrator, you may already be familiar with. You as an administrator have multiple servers that you have to work with and manage. So what happens when a server goes down? It's not a problem. You can jump onto that server and you can fix it. But what if the scenario changes and you have multiple servers going down? So here is where Puppet shows its strength. With Puppet, all you have to do is write a simple script that can be written with Ruby and write out and deploy to the servers your settings for each of those servers. The code gets pushed out to the servers that are having problems, and then you can choose to either roll back to those servers to their previous working states or set them to a new state and do all of this in a matter of seconds. And it doesn't matter how large your server environment is, you can reach to all of these servers. Your environment is secure, you're able to deploy your software, and you're able to do this all through infrastructure as code, which is the advanced DevOps model for building out solutions. So let's dig deeper into what Puppet actually is. So Puppet is a configuration management tool. Maybe similar tools like Chef that you may already be familiar with. It ensures that all your systems are configured to a desired and predictable state. Puppet can also be used as a deployment tool for software. Automatically, you can deploy your software to all of your systems or to specific systems. And this is all done with code. This means you can test the environment and you can have a guarantee that the environment you want is written and deployed accurately. So let's go through those components of Puppet. So here we have a breakdown of the Puppet environment. And on the top, we have the main server environment. And then below that, we have the client environment that would be installed on each of the servers that would be running within your network.
So if we look at the top part of the screen, we have here our Puppet master store, which has and contains our main configuration files. And those are comprised of manifests that are actual codes for configuring the clients. We have templates that combine our codes together to render a final document. And you have files that will be deployed as content that could be potentially downloaded by the clients. Wrapping this all together is a module of manifests, templates, and files. You would apply a certificate of authority to sign the actual documents so that the clients actually know that they're receiving the appropriate and authorized modules. Outside of the master server where you'd create your manifests, templates, and files, you would have Puppet Client is a piece of software that is used to configure a specific machine. There are two parts to the client. One is the agent that constantly interacts with the master server to ensure that the certificates are being updated appropriately. And then you have the factor, the current state of the client that is used and communicated back to through the agent.
So now that we know what Puppet is, let's look into the Puppet architecture. So Puppet has a master-slave architecture. As you can see here, on the top we have the Puppet master and below we have the Puppet clients. So the Puppet master is the system where your system administrator sits. The clients are those systems which require configuration. You can have n number of clients connected to the Puppet master. So don't worry, we look into each of these components in detail. Firstly, we have the Puppet master. So the Puppet master is where the system administrator sits and he or she types in the codes here. So the codes are not only written in the system, but they are also stored here. And whenever the client requires these codes for their configuration, they simply request it. So manifest is the first subcomponent of the Puppet master. These are the actual files where the codes are written. So in case of Puppet, these are Ruby files. Modules tie manifests, templates, and files into a single unit. Now these codes dictate the instructions for performing various tasks on your client. The next component is templates. So if manifests are your code, templates are the data. So let me explain this to you with an example. Consider you want to create a file called index.html on one of your client machines. So what you do is you write the code for creating this file in your manifest and the content of this file is written in your templates. Then you simply link them. But here's the thing, when you divide your code and data in this way, it's a very clean structure. So it's preferred to do it in this manner. Files are your static contents. So the files are basically sent to your client and they are simply downloaded at the client. There is no execution or compilation involved with your files. Now this is where files and templates are extremely different. Because with templates, they are never sent over to your client. The templates are simply read by the parser at the master itself. Modules ties the manifest, templates, and files into a single unit. So modules is not a separate component as such, it just provides a very clean hierarchy. This is the most important component of the Puppet master, CA, which stands for Certificate Authority. Now, as we will see later in this video, the Puppet master and the Puppet client communicate through an exchange of SSL certificates. So when the client sends over the certificate to the master, CA provides the master the authority to sign these certificates. The minute the master signs a certificate, the master is basically saying that yes, this client is registered with me and I agree to exchange data with this client. Our next component, Puppet client, of course these are the systems that require to be configured. Agent is a service installed on the client. The agent is solely responsible for all the communication between the master and the client. And finally, we have Factor. So Factor is responsible for collecting all the data about the present state of our clients and sending this data over to the Puppet master. At the master, this data is compared against the manifests, which are your code files, and then these manifests are sent over to the client depending upon the results of this comparison. So now that we had a look at the various components of Puppet, let's see how these work together. So we have a master and we have 3 clients. Now before any information can be transferred between the master and the client, it's important that these components recognize each other. Also, there needs to be an encrypted channel of communication between each pair of master and client. Now all the data which is transferred between the master and the client, it flows through this channel. So let's see how this entire procedure of recognizing each other works. The core of this procedure are the SSL certificates. SSL stands for Secure Socket Layer. Secure socket layer is a security protocol and it forms an encrypted channel between two components. What this encrypted channel ensures is that all the data that is passed through this channel is not accessible by any other system outside. So it provides complete security. Okay, so we will consider a very general scenario. We have a master and a client here. This is not the Puppet master or the Puppet client. They are just two systems and we are just going forward with master-slave architecture. So the client so far is not a client. It is just a system and we will refer to the system as system A. So system A sends over a client certificate to the master. Associated with this client certificate is the host name of system A. Now master goes through this certificate, it sees the host name and then it decides whether it wants to form a communication link with the system A. If it does, it signs the certificate and the signed certificate is sent back to system A. Now the system A is officially a client. The minute the master signed the client certificate, it said that yes, I am willing to exchange information with this system and I do take the system as one of my clients. So now that the system is officially a client, it can request for data from the master and the master will simply send over the data. Now we are here to talk about Puppet. So if this was a Puppet master and this was a Puppet client, then the first three stages will be the same. So the Puppet client sends over the certificate to the master signs the certificate, sends it back, and the client requests for data. Now by data here, of course, we mean the configuration data. Those are the manifest or even could be your files. So what happens after this request? After this request, the factor service which is present on your clients collects all the information regarding the present state of your client. So this information could include the operating system that's installed on them, the various number of software present on them, the versions of these software. Now all this information is collected, it's called the fact and it's sent over to the master. At the master, this information, that is the facts, is compared against the manifest. So why does the master do this? The master basically compares the facts against the manifest to know if what the manifest is about to perform is already performed on these systems. So if the manifest has some additional functionality, they are compiled into catalogs and then these catalogs are sent over to the client. Now remember those agent services which existed in your clients? Here's where they come in. The agents take the catalog and execute them on the client. Once executed, these catalogs make the required changes on the client and a report is generated. This report is then sent back to the master. So the master keeps record of all the changes that's made in the system, and this comes very handy when one of the systems fail and it's required to be rolled back to its previous working state. So this entire procedure can be repeated n number of times and can be repeated at regular intervals. So if you have a scenario where a system needs to be configured every 30 minutes, what you can do is you can set your interval and automatically every 30 minutes your systems will be configured. So today I'll be showing you how you can use Puppet to install Apache on one of your client machines. So we'll be using two machines here. We'll have a server and we'll have a node machine. The server is essentially your master. The node is your client. I'm just using the term server and node instead because I want to keep it very close to as they are used in the commands. Now both these machines are going to be CentOS 7 machines. And I have Oracle VM VirtualBox installed on my machine. So on that, I've simply created two virtual boxes, both CentOS 7, of course. So before we move on to the actual demo, I'll just take you through the various steps. So first, we'll install the Puppet server on our server or master machine. We'll then start this server service. We then shift over to our node or the client machine and we'll install the Puppet agent service. We will then start this service too. And the minute you start the Puppet agent service, an SSL certificate is created. So this certificate will have the host name of your node attached to it. And this is how the master or the server will recognize this certificate and then it'll sign this certificate. So once your master or the server signs the certificate, you can write your manifests. So the manifests are just the code for configuration. And once that too is done, you shift back to your client or the node system and you run the agent service. So once you run the agent service, your manifest or your catalogs, because as you know, the manifests are compiled into catalogs, these are executed on your node and this will make the required changes. So that's how this entire process is going to work. Now let's move on to the actual demo. This is my Oracle VM VirtualBox Manager. The last two machines you see here are the ones we'll be using for this demo. The Puppet server is your Puppet master, Puppet client, of course, is the client. So let's just have a look at these two machines. This is my Puppet server. So just so you can differentiate, guys, the terminals have been set accordingly. Puppet server has a black background with white text, and Puppet client here has a black background with green text. So we'll move on to server machine or the master machine because that's the one we'll be working on first. So before we begin, we need to set the host name of our master to Puppet. So this is a very essential step in the configuration of Puppet. If you miss this out, there are quite a lot of other changes you'll have to make in certain files. So let's do this first. So that's the command to set the host name. The last word you see there, that's the new host name you want. Okay, so now we'll just check if our host name is set. So just type host name. And yeah, it's Puppet. So next, we will check the IP of this machine. So for that, you just type if config. Enter. So this is your IP, guys, under ENP0S3, init's value, that is 192.168.2.183. Of course, the IP will differ for you guys, needless to say. So note that down somewhere because we'll require it when we are configuring our client. Okay, so now you want your Puppet server and your client to communicate. So for this, we need to remove certain firewalls. So the command for this is sudo, because we want the root permission, systemctl stop firewall d, and put in the password. Okay, so all your firewalls are removed. So the next step, now we start on with our Puppet process. So we download the Puppet labs at first. Now guys, ensure that your systems, your virtual boxes in this case, are connected to the net. Also, you won't be getting an IP if it's not for the first time. So here's the command to download the Puppet lab. Enter the password again. Okay, so the Puppet Labs is downloaded. Now you need to install this. So installation, guys, we will be installing the Puppet server on the master machine or the Puppet server machine. So this may take a while. So that took a while, so I just skipped to the last part where it's completed. The installation process is over. Now we need to make a small change in our system config Puppet server file. So let's just move to the file first. This file will open in VI editor. So this line here, it basically allocates memory for your Puppet server. Now you do not need 2 GB. So we are going to reduce the size. .512 MB should be enough. So guys, notice here I did not type the B, okay? So I just changed this to XMS 512M. Let's save that. Always remember to open this file using sudo. Otherwise, saving the changes you made could be quite troublesome. Okay, so now we can start our Puppet server service. We enable the service. Okay, so that's done. So basically our Puppet server service has started. It's running presently. So for a while we are done with the server machine. Let's move on to our client machine. Okay, first things first, we open our etc host file with sudo because you need to make a few changes and save it. Open this in the VI terminal. Okay guys, so here you have to add this one line at the end. Type in the IP for your Puppet server machine. Puppet -master. So let's save this file. Now we'll move on to downloading Puppet Labs on our Puppet client. So the command is the same that we use for Puppet server. So Puppet Labs is downloaded. Now we need to install the Puppet agent service here. Again, this will also take some time. Puppet server is installed. Let me just clear this window. Now that our Puppet agent service is installed, we'll start this service. So I'll just type in the command for starting the Puppet agent service. As you can see here, ensure changed stop to running. So basically the service was not running before and now it's changed to the running state. And while we executed this command, not only did the service start running, but an SSL certificate was also created. So this certificate should have the host name of this machine, that's a Puppet client machine, attached to it. So let's just check what the host name of our machine is. That's localhost.localdomain. So our certificate should have this attached to it. So guys, the first time your client sends a certificate, the name of the certificate itself is usually the host name of the machine. So our certificate's name should be localhost.localdomain. We'll check this on our master system, and that's where we'll sign the certificate to. So first we list out all the certificates. In our case, since we have just one client and we just started the client, we should have technically just one certificate, and it will be so. Yeah, so this is our certificate, localhost.localdomain. We'll now sign the certificate. Okay, sorry about that. Just need to remove these brackets. Yeah, as you can see, recipes, certificate is signed. Sign certificate request here. So once the certificate is signed, the request for signing the certificate is removed. That's this line. Now that a certificate is signed, we can begin to write our manifest. So let's move into a manifest folder and we'll create a placeholder file. So we'll create a file called sample.pp. This is just a sample file. We won't be writing anything in this file as of now. So we are just checking here. We are just creating this file and then we'll go to our client machine and just check there if we can access this file from there. So now we'll move to our client machine. So let's test the connection. So as you can see here, it says applied catalog in 0.03 seconds. So our catalog is executed on our client machine. Now our catalog was just a placeholder basically. So the file that we created, which is sample.pp, had no content and we were just testing our client. Now let's go back to our master server, put some content into this file and see how the execution takes place. So we'll open our file sample.pp, which we created earlier in the VI editor. Let's type our code here. So node, and then within the brackets we enter the host name of our client machine. So this ensures that our manifest is executed on this particular machine. Now the Apache service package on CentOS is called the HTTPD. So this line that I just typed in is the action. It will ensure that the HTTPD package is installed on your client. And that's it. So this is our code. We'll save it. Now let's go back to our client machine and test it. So this is our client machine. And our catalog's applied on the client. So I just cleared the screen. Now we'll start the Apache service. Okay, so how do we see if it's running? We just need to go to our browser and at localhost, you must have the testing page for your Apache. So we type localhost, enter. And yeah, this is the testing page for Apache. So as you can see, we have successfully used Puppet to install the Apache service on our Puppet client. And this is the end of our demo.
So let's have a look at companies that are using Puppet today. There are a number of companies that have adopted Puppet as a way to manage their infrastructure. So companies that are using Puppet today include Spotify, Google, AT&T. So why are these companies choosing to use Puppet as their main configuration management tool? And the answer can be seen if we look at a specific company. Staples. So Staples chose to take and use Puppet for their configuration management tool and use it within their own private cloud. The results were dramatic. The amount of time that the IT organization was able to save in deploying and managing their infrastructure through using Puppet enabled them to open up time to allow them to experiment with other and new projects and assignments, a real tangible benefit to a company. So let's look at how you write a manifest in Puppet. So manifests are designed for writing out in code how you would configure a specific node in your server environment. The manifests are compiled into catalogs, which are then executed on the client. Each of the manifests are written in the language of Ruby with a .pp extension. And if we step through the 5 key steps for writing a manifest, they are 1. Create your manifest, and that is written by the system administrator. 2. Compile your manifest, and it's compiled into a catalog. 3. Deploy. The catalog is then deployed onto the clients. 4. Execute. The catalogs are run on the client by the agent. And then 5. End. Clients are configured to a specific and desired state. If we actually look into how a manifest is written, it's written with a very common syntax. If you've done any work with Ruby or really configuration of systems in the past, this may look very familiar to you. So we break out the work that we have here. You start off with a package, file, or service as your resource type, and then you give it a name, and then you look at the features that need to be set, such as IP address. Then you're actually looking to have a command written, such as present or start. The manifest can contain multiple resource types. If we continue to write our manifest in Puppet, the default keyword applies a manifest to all clients. So an example would be to create a file path that creates a folder called sample in a main folder called etc. The specified content is written into a file that is then posted into that folder. And then we're going to say we want to be able to trigger an Apache service, and then ensure that that Apache service is installed on a node. So we write the manifest and we deploy it to a client machine. On that client machine, a new folder will be created with a file in that folder, and an Apache server will be installed. You can do this to any machine and you'll have exactly the same results on those machines.
Now let's have a look at the Puppet community. The Puppet community is a rich community of a lot of people. Officially, there is no count. But counting the various channels where people collaborate, there are a little over 2,900 committers to GitHub projects who are directly or indirectly associated with Puppet Labs. There are 4,893 modules on the official Puppet Forge. These include modules from the Puppet Labs and also from open source contributors to GitHub. So that's nearly 5,000 modules of ready-made code available on the Puppet Forge. So before you write any code for Puppet, you can check to see if it's already been written by someone. Now there's a mailing list which has 6,588 participants. Apart from this, on Slack Overflow you have a big tag of Puppet Labs and Puppet, which gives you a list of only Puppet questions. That's a good playground for you to interact with people who are already using Puppet and who are contributing and helping others. Now let's have a look at Puppet Forge. So Puppet Forge is a GitHub client for a repository which is hosted by Puppet Labs. It has almost 5,000 modules of Puppet code. So these are both Puppet Labs and community contributed. The best thing about this is that they're easy to customize. So when you have a requirement for anything you're doing with your infrastructure, you can just grab one of those 5,000 modules, and then you can customize it according to your needs. One of the other benefits is they have built-in tests, so they follow all of the best practices. Now, if you write your own module, you also have to write your own tests, and you have to spend extra time writing best practice code. All of that has been taken care of, and you can just download any one of those and customize it according to your needs, and you're good to go. So that's the benefit you get from such a large community, where people contribute to the modules and the code and share with the community. Puppet DSL. Puppet DSL is a Puppet domain-specific language. It's the Puppet's primary programming language. It's just like plain English, and you don't really need to be a programmer to write code in it. It's kind of a subchild of Ruby because it approaches and uses is equal to and greater than marks to define things, so it's very easy to learn. You can specify packages that you want to install. You can specify services to be managed. You can do things based on the operating system that you have. So we'll be writing a small Puppet module which will be using this Puppet DSL. We will do that after we install the Puppet server and the client. And then we will write a simple Puppet module to show how to use the Puppet DSL. Let's have a look at the demo we are going to do. So you will be setting up the machines using sudo DNS because we want to have a resolvable DNS. Because only by having a resolvable DNS can we use Puppet, because Puppet uses the SSL certificates. Now we'll be installing the Puppet server and the client. We'll be signing the certificates of the client on the server side. And then we'll proceed with writing an NTP module, which we'll be using for installation of NTP on the client. And then we'll look at the Puppet programming language, or DSL. Now, we are going to look at a demo here. So we will be setting up the machines. We'll set up a sudo DNS locally because Puppet requires a fully qualified domain name in order to run, since there is a certificate communication taking place here. We will be installing the Puppet server, the Puppet client. We'll be signing the certificate, and finally we will write an NTP module and make it run. So now we will be starting a Puppet master and a client. I have two machines here. One is the Puppet Master and the second is the Puppet Client. The Puppet Master has got almost 4 GB of RAM and 4 vCPUs, which I can show you here. Because it's a Ruby on Rails application, it requires a lot of CPU and RAM. For the client, I don't need that much RAM and CPU, so I've allotted 1 GB of RAM and 1 vCPU. I will start both of these machines and find out the IP addresses. Right-click, normal start. Both of these machines are starting up. The Puppet client has started up, and the first thing I'll do is log in using root and Red Hat password, and then I will change the host name. So I'll say vim etc host name. This will open a hostname file in a text editor, which is vim. Then we'll do a dd, which will delete that existing host name. And then I press the I for insert mode, and finally I'll type the puppet-client, which will be the host name of this machine. I'll save this file by doing escape semicolon WQ exclamation mark. And I'll reboot the machine. Similarly, going to the Puppet Master, I'll say root Red Hat. I'll open the hostname file. Say dd, then I'll say puppet-master. I'll save this file and reboot the machine for the hostname change to take effect. The hostname change does not take effect unless you reboot the machine. Now both of these machines are ready. I'm going to find out the IPs and use the Mac terminal to log into these. So this is 23 and 21. So 23 is my server and 21 is my client. I'll SSH to 23 first. Now, in order for the Puppet Master to be installed, I need a fully qualified domain name here and a fake DNS, which means a fully resolvable DNS name. So if I do host name here, you see my host name is Puppet Master. In order to set up a fake DNS, I need to go to the etc host file, go to the end, then I say IP address, host name local, then space host name. Now, this is one of the techniques which makes the Linux server believe that there's a fully qualified domain name on this machine. I'll save this. Then I do a host name -f. You see it has a fully qualified domain name now. So now we will be downloading the Puppet Labs repository for Ubuntu 16.04, which is Xennial. So I'll say curl -0 https apt.puppetlabs.com /puppetlabs-release -pc1 -xennial.deb. You can see there's a Debian file which has been downloaded here. I will import this using the dpkg command. So I'll say dpkg-i puppetlabs-release -pc1 -xennial.deb. And then I'll say apt-get update, which will update my apt package indexes on this machine. And now I'll install the Puppet server. So I'll say apt-get install puppet server -y. So the Puppet server is now installed, and we will be configuring the memory allocation for the Puppet server. So I'll say etc default Puppet server. So by default, it has only got 2 GB allocated. We'll give it 3 GB because it's JVM. I'll make this 3, and I'll change this to 3 as well. And I'll save this file. I'll make sure the unconfigured firewall allows port 8140, which is the Puppet Lab Puppet server port. The rules have been updated to allow that. I'll now start the Puppet server. So I'll say systemctl start Puppet server. It takes some time because it's a JVM, so it takes a couple of minutes to start the Puppet server. So the Puppet server is now running. I'll also enable it at boot time. So I'll say systemctl enable Puppet server. It will enable at boot time. Now I also need to configure a fully qualified domain name here. So I'll do that by going into the hosts file. I'll go to the end and I'll say 192.168.1.23 and then puppet-server.local and then puppet-server. If I do a hostname -f, put -master.local because the current hostname is puppet-master. So the trick is to have the hostname.local in front of the IP address in the host file. Having a fully qualified domain name now we will go to the client setup. The client setup is almost the same with just a small difference. The package which we need to install on the client is Puppet Agent. So we will go to the client. So you see this has got a host name. Now we also need to set up the fake DNS here. So I'll copy this host name, open the host line, go to the end, write the IP address, and then .local, and then host name again. So this will give me a fully qualified domain name. So when I do a host name, it says puppet-client. When I do a host name -f, it says puppet client local. To install the Puppet agent on this machine, I will need to download the Xenio packages. So I'll say wget https apt.puppetlabs.com/puppetlabs -release -pc1 -xenio.deb. I'll download this, and then I'll say dpkg-i puppetlabs-release -pc1 -xenio.deb. So this is the repository package which I'll be downloading here. And then I'll say apt-get update-y. This will update my apt caches on this machine. And now I'll finally install the Puppet agent. So I'll say apt-get install Puppet agent -y. Now the Puppet agent is here. I'll start the Puppet agent and I'll enable it at boot time. So I'll say system control, start Puppet, then system control, enable Puppet. Now Puppet is enabled. Now we have set up the fully qualified domain name on the client and the server, but each of them should know each other. So we'll have to do a cross-certificate host mapping. So we will be copying the host file entry of the client and adding it to the server. So I'll go to the etc hosts on the server side. Go to the end, paste it there. Okay, and I'll be adding the entry of the master on the client side. Okay, now both of the servers will recognize each other now, because one of them has the host entry of the other. So if I do from the master ping puppet-agent.local, if I ping the agent from the server, -client.local, it is able to ping it. And if I ping the master from the client, if I say ping puppet-master.local, both of them will be able to ping each other. Now the next step would be to create a certificate signing request. So I'll go to my to this directory, which is opt puppet labs puppet bin, and I'll say puppet agent -t -server is equal to, and I'll give the fully qualified domain name of the puppet master. Then I'll say -f. When I do this, it will create a certificate signing request, you see. Now, if I go to the server and I do an opt, I'll check and see how many certificates are pending to be signed. You'll see there is a puppet client certificate which is pending to be signed, which is denoted by the absence of a plus sign here. I'll be signing the certificate, so I'll say puppet cert sign and then the name. So puppet-client.local, this will sign the certificates. And when I go to the server on the client side, if I run the puppet agent again, you see it's actually pulling down the catalog. As of now, it has an empty catalog. That says there is nothing. Now we have configured the puppet agent and the master. Now we will be taking a module from Puppet Forge. Puppet Forge is a big collection of open source modules which are free to use. As a first step, we will be using a ready-made module, and that would be a demonstration for how to actually get up and running with a module. So search for Apache module here. This is the Puppet Labs Apache module. I'll be using the Puppet command line, Puppet module install. This is the command for that. But I will make sure I run this command from the Puppet home. So I'll go to the master, I'll go to etc Puppet Labs, code, environments, production. In this, I'll do modules. Now I will run it from the binary which is present at the opt Puppet Labs bin puppet. And then module install. Puppet Labs -Apache, and then this version. So we are specifying the latest version, and I'll hit enter. When I press enter, it starts downloading from the Forge API. So you see the module is downloaded in addition to the dependencies. So there is concat, stdlib, and Apache. So now I'll go to a folder here which is one level up called manifests. So this is the file here, etc Puppet Labs code environments production manifests. So in this there's a file which I'll be creating called site.pp. The site.pp will specify, and this is the main controller of how the infrastructure looks. In the site.pp, I specify that I want puppet-client.local node to have the Apache module included. I'll save this file, and the only thing I need to do now is, since all is set on the server side, I need to go to the client side and run Puppet Agent. It will automatically download the Apache module and compile it, and then make sure the server is in a state. So when I press enter, we see a lot of output. It tries to configure Apache on this machine, and done. Now when I go to the front end of this machine, on this port, I should be able to see Apache's default page. So this is Apache's default page. So the module which we downloaded from the Forge was actually written in a way that Apache would be installed and run at boot time. So that is why it is running here. And that is all we have from the Puppet module. And this concludes the demo.
Today I'll be showing you how you can install the configuration management tool, Ansible. So let's have a brief about why one would use Ansible and what exactly is Ansible. So if you consider the case of an organization, it has a very large infrastructure, which means it has more than probably hundreds of systems. And giving one or even a small team of people the responsibility to configure all these systems makes their work really tough, repetitive, and as you know, manual work is always prone to errors. So Ansible is a tool which can automate the configuration of all these systems. With Ansible, A small team of system administrators can write simple codes in YAML, and these codes are deployed onto the hundreds and thousands of servers, which configures them to the desired states. So Ansible automates configuration management, that is configuring your systems. It automates orchestration, which means it brings together a number of applications and decides an order in which these are executed, and it also automates deployment of the applications. Now that we know what Ansible does, let's move on to the installation of Ansible. So here is my Oracle VM VirtualBox Manager. I'll be using two systems. There's the node system, which is basically my client system, and there's the server system or the master system. So let's begin at our server system. So this is my master system, guys. So the first thing we do is we download our Ansible tool. So one thing we must remember with Ansible is that unlike Chef or Puppet, Ansible is a push type of configuration management tool. So what this means is that the entire control here lies with your master or your server system. This is where you write your configuration files, and these are also responsible for pushing these configuration files onto your node or client system as and when required. Great, so our Ansible tool is installed. Now we need to open an Ansible host file, and there we'll specify the details of our node or client machine. So this is our Ansible host file. As you can see here, the entire file is commented, but there's a certain syntax that you'd observe. For example, here we have a group name, web servers, under which we have the IP addresses or certain host name. So this is about how we'll be adding the details for our client system. First, we need to give a group name. Under this group, basically, we add all the clients which require a certain type of configuration. Since we are using just one node, we'll give only the details for that particular node. First, we need to add the IP address of our client machine. So let's just go back to our client machine. And this here is the IP address, 192.168.2.11. Once you have typed in your IP address, give a space, and then we'll specify the user for our client machine. So all communications between the server or the master system and the client or the node system takes place through SSH. SSH basically provides a secure channel for the transfer of information. Follow this up with your password. In my case, it's the root's password. And that's it, we are done. So now we save this file and go back to our terminal. So now that our host file is written, the next thing we do is we write our playbook. So playbook is the technical term used for all the configuration files that we write in Ansible. Now playbooks are written in YAML. YAML is extremely simple to both write and understand. It's in fact very close to English. So now we'll write our playbook. The playbook or any code in YAML first starts with 3 dashes. This indicates the beginning of your file. Next thing, we need to give a name to our playbook. So name, and I'm going to name my playbook sample book. We next need to specify our host systems, which is basically the systems at which the configuration file or the playbook in our case will be executed. So we'll be executing this at the client machines mentioned under the group Ansible servers. So we had just one client machine under it. We'll still mention the group name. We next need to specify the username with which we'll be logging into our client machine, which is root in my case. And become true specifies that you need to become the root to execute this playbook. So becoming the root is called a privilege escalation. Next, we need to specify our tasks. So these are basically the actions that the playbook will be performing. So you would have noticed everything so far is aligned, that is name, host, remote user, become and task, because these are at one level. Now whatever comes under task will be shifted slightly towards the right. Although YAML is extremely simple to understand and read both, it's a little tricky while writing because you need to be very careful about the indentations and the spacing. So my first task is install HTTPD, which is basically an Apache server. So now my command's yum, and this will be installing the HTTPD package. And the latest state of it will be installed. So that's our first task. Now our second task would be running our Apache service. So name run HTTPD, and the action, which is service, will be performed on HTTPD, hence the name HTTPD, and state must be started. Now we come to our third task. So here we'll create a very simple web page that will be hosted. So create content is the name of our task. And the content that we are creating here will basically be copied to our node system at a particular file location that we'll provide. Our content will be congrats. And then we'll provide the destination at which this file will be copied. So this is the default location for all our HTML files. And that's it. We are done writing our playbook. Just save this and go back to your terminal. Before we execute the playbook or push the playbook onto our node system, let's check the syntax of our playbook. So the command for doing so is, and if everything's fine with your playbook, the output would be just your playbook name. So our syntax is perfectly fine. Now we can push on the playbook to our node or the client machine. And that's the syntax for doing so. Now, as your playbook is being sent over to the client machine, you can see that first the facts are gathered. That is, the current state of your client machine is first fetched to check what all is to be changed and what is already present. So the first thing is installing HTTPD. So our system already had HTTPD. So it says OK. Because this does not need to be changed. Our next task was running HTTPD. Now, although our system had the Apache service, it was not running. So that is one thing that was changed. The next was there was no content available. So the content was also added. So 2 tasks were changed and 4 things were okay. Now everything seems fine. And before you move any forward, it is very important that you check this one line of documentation provided by Ansible. You have all kind of information available here regarding which all tasks were executed, if your client machine was reachable or unreachable, and so on. So now that everything's fine here, we can move on to our node system and we'll just go to our browser. So if our playbook has been executed here, what should happen is that the HTTPD service must be in the running state and the web page that we created should be hosted. So let's just type localhost. And great, everything's working fine. So our web page is displayed here. So we come to an end for our installation and configuration video for the configuration management tool Ansible. If you have any doubts, please post them in the comment section below and we'll definitely get back to you as soon as possible.
Ansible today as one of the key tools that you would have within your DevOps environment. So the things that we're going to go through today is we're going to cover why you would want to use a product like Ansible, what Ansible really is and how it's of value to you in your organization, the differences between Ansible and other products that are similar to it on the market and what makes Ansible a compelling product. And then we're going to dig into the architecture for Ansible. We're going to look at how you would create a playbook, how you'd manage your inventory of your server environments, and then what is the actual workings of Ansible. As a little extra, we're going to also throw in Ansible Tower, one of the secret source solutions that you can use for improving the speed and performance of how you create your Ansible environments. And finally, we're going to go through a use case by looking at Hootsuite, a social media management company, and how they use Ansible to really improve the efficiency within their organizations. So let's jump into this. So the big question is, why Ansible? So you have to think of Ansible as another tool that you have within your DevOps environment for helping manage the servers. And this definitely falls on the operations side of the DevOps equation. So if we look here, we have a picture of Sam. And like yourselves, Sam is a system administrator. And he is responsible for maintaining the infrastructure for all the different servers within his company. So some of the servers that he may have that he has to maintain could be web servers running Apache. They could be database servers running MySQL. And if you only have a few servers, then that's fairly easy to maintain. I mean, if you have 3 web servers and 2 database servers, and let's face it, wouldn't we all love just to have 1 or 2 servers to manage? It would be really easy to maintain. The trick, however, is as we start increasing the number of servers, and this is a reality of the environments that we live and operate in, it becomes increasingly difficult to create consistent setup of different infrastructures such as web servers and databases, for the simple reason that we're all human, as if we had to update and maintain all of those servers by hand, there's a good chance that we would not set up each server identically. Now, this is where Ansible really comes to the rescue and helps you become an efficient operations team. Ansible, like other system solutions such as Chef and Puppet, uses code that you can write and describe the installation and setup of your servers. So you can actually repeat it and deploy those servers consistently into multiple areas. So now you don't have to have one person redoing and refollowing setup procedures. You just write one script and then each script can be executed and have a consistent environment. So we've gone through why you'd want to use Ansible. Let's step through what Ansible really is. So, this is all great, but, how do we actually use these tools in our environment? So Ansible is a tool that really allows you to create and control 3 key areas that you would have within your operations environment. First of all, there's IT automation. So you can actually write instructions that automate the IT setup that you would typically do manually in the past. The second is the configuration and having consistent configuration. Imagine setting up hundreds of Apache servers and being able to guarantee with precision that each of those Apache servers is set up identically. And then finally, you want to be able to automate the deployment so that as you scale up your server environment, you can just push out instructions that can deploy automatically different servers. The bottom line is you want to be able to speed up and make your operations team more efficient. So let's talk a little bit about pull configuration and how it works with Ansible. So there are 2 different ways of being able to set up different environments for server farms. One is to have a key server that has all the instructions on, and then on each of the servers that connect to that main master server, you would have a piece of software known as a client installed on each of those servers that would communicate to the main master server and then would periodically either update or change the configuration of the slave server. This is known as a pull configuration. An alternative is a push configuration, and the push configuration is slightly different. The main difference is, as with a pull configuration, you have a master server where you actually put up the instructions. But unlike the pull configuration where you have a client installed on each of the services, with a push configuration, you actually have no client installed on the remote servers. You simply are pushing out the configuration to those servers and forcing a restructure or a fresh clean installation in that environment. So Ansible is one of those second environments where it's a push configuration server. And this contrasts with other popular products like Chef and Puppet, which have a master-slave architecture with a master server connecting with a client on a remote slave environment where you would then be pushing out the updates. With Ansible, you're pushing out the service and the structure of the server to remote hardware, and you are just putting it onto the hardware irrelevant of the structure that's out there. And there are some significant advantages that you have in that you're not having to have the extra overhead weight of a client installed on those remote servers having to constantly communicate back to the master environment. So let's step through the architecture that you would have for an Ansible environment. So when you're setting up an Ansible environment, the first thing you want to do is have a local machine. And the local machine is where you're going to have all of your instruction and really the power of the control that you'd be pushing out to the remote server. So the local machine is where you're going to be starting and doing all of your work. Connected from the local machine are all the different nodes pushing out the different configurations that you would set up on the local machine. The configurations that you would write, and you would write those in code, within a module. So you do this on your local machine for creating these modules, and each of these modules is actually consistent playbooks. The local machine also has a second job, and that job is to manage the inventory of the nodes that you have in your environment. The local machine is able to connect to each of the different nodes that you would have in your hardware network through SSH clients, so a secure client. Let's dig into some of the different elements within that architecture. And we're going to take a first look at playbooks that you would write and create for the Ansible environments. So the core of Ansible is the playbook. This is where you create the instructions that you write to define the architecture of your hardware. So the playbook is really just a set of instructions that configure the different nodes that you have, and each of those set of instructions is written in a language called YAML. And this is a standard language used for configuration server environments. Did you know that YAML actually stands for YAML Ain't Markup Language? That's just a little tidbit to hide behind your ear. So let's have a look at one of these playbooks it looks like. And here we have a sample YAML script that we've written. So you start off your YAML script with 3 dashes, and that indicates the start of a script. And then the script itself is actually consistent of 2 distinct plays. At the top we have play 1, and below that we have play 2. Within each of those plays, we define which nodes are we targeting. So here we have a web server in the top play, and in the second play we have a database server that we're targeting. And then within each of those server environments, we have the specific tasks that we're looking to execute. So let's step through some of these tasks. We have an install Apache task, we have a start Apache task, and we have an install MySQL task. And when we do that, we're going to actually execute a specific set of instructions. And those instructions can include installing Apache and then setting the state of the Apache environment, or starting the Apache environment and setting up and running the MySQL environment. So this really isn't too complicated, and that's the really good thing about working with YAML, is it's really designed to make it easy for you as an operations lead to be able to configure the environments that you want to consistently create. So let's take a step back though. We have 2 hosts. We have web server and database server. Where do these names come from? Well, this takes us into our next stage and the second part of working with Ansible, which is the inventory management part of Ansible. So the inventory part of Ansible is where we maintain the structure of our network environment. So what we do here is part of the structure in creating different nodes is we've had to create 2 different nodes here. We have a web server node and a database server node. And under web server node, we actually have the names that we're actually pointing to specific machines within that environment. So now when we actually write our scripts, all we have to do is refer to either web server or database server, and the different servers will have the instructions from the YAML script executed on them. This makes it really easy for you to be able to just point to new services without having to write out complex instructions. So let's have a look at how Ansible actually works in real world. So the real world environment is that you would have the Ansible software installed on a local machine, and then it connects to different nodes within your network. On the local machine, you'll have your playbook, which is the set of instructions for how to set up the remote nodes. And then to identify how you're going to connect to those nodes, you'll have an inventory. We use secure SSH connections to each of the servers, so we are encrypting the communication to those servers. We're able to grab some basic facts on each server, so we understand how we can then push out the playbook to each server and configure that server remotely. The end goal is to have an environment that is consistent. So let's ask you a simple question. What are the major opportunities that Ansible has over Chef and Puppet? Really like to hear your answers in the comments below. Pop them in there and we'll get back to you, and really want to hear how you feel that Ansible is a stronger product, or maybe you think it's a weaker product as it compares to other similar products in the market. Here's the bonus. We're going to talk a little bit about Ansible Tower. So Ansible Tower is an extra product that Red Hat created that really kind of puts the cherry on the top of the ice cream, or is the icing on your cake. Ansible by itself is a command line tool. However, Ansible Tower is a framework that was designed to access Ansible. And through the Ansible Tower framework, we now have an easy to use GUI. This really makes it easy for non-developers to be able to create the environment that they want to be able to manage in their DevOps plan without having to constantly work with the command prompt window. So instead of opening up terminal window or a command window and writing out complex instructions only in text, you can now use drag and drop and mouse click actions to be able to create your appropriate playbooks, inventories, and pushes for your nodes. All right, so we've talked a lot about Ansible. Let's take a look at a specific company that's using Ansible today. And in this example, we're going to look at Hootsuite. Now, Hootsuite, if you've not already used their products, and they have a great product, Hootsuite is a social media management system. They are able to help with you managing your pushes of social media content across all of the popular social media platforms. They're able to provide the analytics. They're able to provide the tools that marketing and sales teams can use to be able to assess a sentiment analysis of the messages that are being pushed out. Really great tool and very popular. But part of their popularity drove a specific problem straight to Hootsuite. The challenge they had at Hootsuite is that they had to constantly go back and rebuild their server environment, and they couldn't do this continuously and be consistent. There was no standard documentation, and they had to rely on your memory to be able to do this consistently. Imagine how complex this could get as you're scaling up with a popular product that now has tens of thousands to hundreds of thousands of users. This is where Ansible came in and really helped the folks over at Hootsuite. Today, the DevOps team at Hootsuite write out playbooks that have specific instructions that define the architecture and structure of their hardware nodes and environments, and are able to do that as a standard product. Instead of it being a problem in scaling up their environment, they now are able to rebuild and create new servers in a matter of seconds. The bottom line is Ansible has been able to provide Hootsuite with IT automation, consistent configuration, and free up time from the operations team so that instead of managing servers, they're able to provide additional new value to the company.
Ansible is currently the most trending and popular configuration management tool, and it's used mostly under the DevOps approach. So what will you be learning today? You'll learn why you should use Ansible, what exactly is Ansible, the Ansible architecture, how Ansible works, the various benefits of Ansible, and finally we'll have a demo on the installation of Apache or the HTTPD package on our client systems. We'll also be hosting a very simple web page, and during this demo I'll also show you how you can write a very simple playbook in YAML and your inventory file. So let's begin. Why should you use Ansible? Let's consider a scenario of an organization where Sam is a system administrator. Sam is responsible for the company's infrastructure. A company's infrastructure basically consists of all its systems. This could include your web servers, your database servers, the various repositories, and so on. So as a system administrator, Sam needs to ensure that all the systems are running the updated versions of the software. Now, when you consider a handful of systems, this seems like a pretty simple task. Sam can simply go from system to system and perform the configurations required. But that is not the case with an organization, is it? An organization has a very large infrastructure. It could have hundreds and thousands of systems. So here is where Sam's work gets really difficult. Not only does it get tougher, Sam has to move from system to system, performing the same task over and over again. This makes Sam bored. Not just that, repeating the same task leaves no space for innovation. And without any ideas or innovation, how does the system grow? And the worst of it all is manual labor is prone to errors. So what does Sam do? Well, here is where Ansible comes in use. With Ansible, Sam can write simple codes that are deployed onto all the systems and configure them to the correct states. So now that we know why we should use Ansible, let's look at what exactly is Ansible. Ansible is an IT engine that automates the following tasks. So first we have orchestration. Orchestration basically means bringing together of multiple applications and ensuring an order in which these are executed. So for example, if you consider a web page that you require to host, this web page stores all its values that it takes from the user into a database. So the first thing you must do is ensure that the system has a database manager, and only then do you host your web page. So this kind of an order is very crucial to ensure that things work right. Next, Ansible automates configuration management. So configuration management simply means that all the systems are maintained at a consistent desired state. Other tools that automate configuration management include Puppet and Chef. And finally, Ansible automates deployment. Deployment simply means the deploying of application onto your servers of different environments. So if you have to deploy an application on 10 systems with different environments, you don't have to manually do this anymore because Ansible automates it for you. In fact, Ansible can also ensure that these applications or the code are deployed at a certain time or after regular intervals. Now that we know what exactly Ansible is, let's look at Ansible's architecture. Ansible has two main components. You have the local machine and you have your node or the client machine. So the local machine is where the system administrator sits. He or she installs Ansible here. And on the other end, you have your node or the client systems. So in case of Ansible, there's no supporting software installed here. These are just the systems that require to be configured, and they are completely controlled by the local machine. At your local machine, you also have a module. A module is a collection of your configuration files. And in case of Ansible, these configuration files are called playbooks. Playbooks are written in YAML. YAML stands for YAML ain't a markup language. And it is honestly the easiest language to understand and learn since it's so close to English. We also have the inventory. The inventory is a file where you have all your nodes that require configuration mentioned. And based on the kind of configuration they require, they're also grouped together. So later in the demo, we'll have a look at how the playbook and the inventory is written, and that will probably make it clearer. So of course, the local machine needs to communicate with the client. And how is this done? This is done through SSH. SSH is your secure shell, which basically provides a protected communication in an unprotected environment. Okay, so we saw the various components of Ansible. Now, how does Ansible exactly work? You have your local machine on one end. This is where you install Ansible. If you've gone through any previous material on Ansible, you would have come across the term agentless often being associated with this tool. So this is what agentless means. You're installing Ansible only on your local machine and there's no supporting software or plugin being installed on your clients. This means that you have no agent on the other end. The local machine has complete control and hence the term agentless. Another term that you would come across with Ansible is push configuration. So since the local machine has complete control here, it pushes the playbooks onto the nodes and thus it's called a push configuration tool. Now the playbooks and the inventory are written at the local machine and the local machine connects with the nodes through the SSH client. This step here is optional but it's always recommended to do so. It's where the facts are collected. So facts are basically the current state of the node. Now all this is collected from the node and sent to the local machine. So when the playbook is executed, the task mentioned in the playbook is compared against the current status of the node and only the changes that are required to be made further are made. And once the playbooks are executed, your nodes are configured to the desired states. So as I mentioned before, Ansible is currently the most trending tool in the market under the configuration management umbrella. So let's have a look at the various benefits of Ansible which gives it this position. Well, Ansible is agentless, it's efficient, it's flexible, simple, idempotent, and provides automated reporting. How does it do all this? Let's have a look at that. Agentless, as I already mentioned before, you require no supporting software or plugin installed on your node or the client system. So the master has complete control. And automatically this means that Ansible is more efficient because now we have more space in our client and node systems for other resources and we can get Ansible up and running real quick. Ansible is also flexible. So an infrastructure is prone to change very often, and Ansible takes no amount of time to adjust to these changes. Ansible cannot get any simpler with your playbooks written in a language such as YAML, which is as close to English as you can possibly get. Idempotent basically means that if you have a playbook which needs to be run n number of systems, it would have the same effect on all of these systems without any side effect. And finally, we have automated reporting. So in case of Ansible, your playbook has a number of tasks, and all these tasks are named. So whenever you run or execute your playbook, it gives a report on which tasks ran successfully, which failed, which clients were not reachable, and so on. All this information is very crucial when you're dealing with a very large infrastructure. And finally, we reach the most exciting part of our tutorial, the hands-on. Before we move on to the actual hands-on, let me just brief you through what exactly we'll be doing. So I'll be hosting 2 virtual boxes, both CentOS 7 operating systems. One would be my local machine and other my node or the client machine. So on my local machine, first I'll install Ansible. We'll then write the inventory and the playbook and then simply deploy this playbook. On the client machine, there's just one thing that we need to do, is that we need to check if the configurations that we mentioned in our playbook are made right. So we'll now begin our demo. This is my Oracle VirtualBox. Here I have my master system, which is the local machine, and this is the client machine. So let's have a look at these 2 machines. This is my client machine. The terminal is open right now. So the client machine terminal has a black background with white text, and the master machine terminal has a white background with black text, just so you can differentiate between the 2. So we'll start at the master machine. The first thing to do is we need to install our Ansible. So yum install Ansible-y is the command to do so. So this might take some time. Yeah, so Ansible's installed. The next step, we go to our host file. So our host file here is basically the inventory. It's where you'll specify all your nodes. In our case, we just have one node. That's the path to your host file. As you'll see, everything here is commented. So just type in the group for your client nodes. So I'm going to name it Ansible Clients. And here we need to type the IP address of our client machine. So my client machine's IP address is 192.168.2.127. So before you come to this, it's advised that you check the IP address on your client machine. The simple command for that is ifconfig. Now once you type the IP address, put a space, and here we need to mention the username and the password for our client. So I'll be logging in as the root user. So this is the password. And then the user. Which is root in my case. That's it. Now you can save this file. Just clear the screen. Next, we move on to our playbook. We need to write the playbook. So the extension for our playbook is YML, which stands for YAML. And as you can see here, I have already written my playbook, but I'll just explain to you how this is done. So a YAML file always begins with 3 dashes. This indicates the start of your YAML file. Now the first thing is you need to give a name to the entire playbook. So I have named it sample book. Host is basically where this would be executed. So as we saw earlier in our inventory, I mentioned client's group name as Ansible Clients. So we use the same name here. The remote user is the user you'll be using at your client. So in my case, that's root. And become true is basically to indicate that you need to set your privileges at root. So that's called a privilege escalation. Now a playbook consists of tasks. So we have here 3 tasks. The first task, I've named it to install HTTPD. So what we are doing here is we are installing our HTTPD package, which is basically the Apache server. And we are installing the most latest version of it. Hence the state value is latest. The next task is running HTTPD. So for the service, the name is HTTPD because that's the service we need to start running and the state is started. Our next task is creating content. So this is the part where we are creating our web page. So copy, because this is the file that will be created at the client. The content will be welcome and the destination of the file will be var www.html index.html. As you know, this is like a default path that we use to store all our HTML files. Now, as you can see here, there's quite a lot of indentation. And when it comes to YAML, although it's very simple to write and very easy to read, the indentation is very crucial. So the first dash here represents the highest stage, that is the name of the playbook, and all the dashes under tasks are slightly shifted towards the right. So if you have 2 dashes at the same location, they basically mean that they are siblings. So the priority would be the same. So to ensure that all your tasks are coming under the tasks label, make sure they are not directly under name. So yeah, that's pretty much it. So when you write your YAML file, the language is pretty simple, very readable. Indentations absolutely necessary. Make sure all your spaces are correctly placed. We can now save this file. Next thing we need to check if the syntax of our YAML file is absolutely right, because that's very crucial. So the command to check the syntax of the YAML file is Ansible playbook, the name of your playbook, syntax check. So we have no syntax errors, which is why the only output you receive is sample.yml, which is the name of your playbook. So our playbook is ready to be executed. The command to execute the playbook is Ansible playbook and the name of your playbook. So our playbook's executed. As you can see here, gathering facts, that's where all the facts of the node, that's the present state of the node, is collected and sent to the local machine. So it's basically to check that if the configuration changes that we are about to make is already made. So it's not made. We do not have the HTTPD package installed on our node. So this is the first change that's made. Also, if it's not installed, of course, it's not running. That's the second change that's made. So it's put into the running state. And a final task, which is create content, is under the OK state. This means that the content's already present in the client machine. So I made it this way so that you can at least see the different states that's present. So over here we have OK4, so 4 things are all fine. The facts are gathered, 2 things are changed, and 1 is already present. 2 changes are made. 0 clients are unreachable and 0 tasks have failed. So this is the documentation that I was referring to previously that Ansible provides automatically and is very useful, as you can see. So our next step, we need to just check on our client machine if all the changes that we desired are made. So let's move to our client. So this is my client machine. So to check this, since we are installing the HTTPD package and hosting a web page, the best way to do it is open your browser and type in localhost. So there you go. Your Apache server is installed and your web page is hosted.
Hi guys. In this video, we have compiled the most important interview questions of configuration management tools, Chef, Ansible, and Puppet that you might face in a DevOps interview. So without further ado, let's get started.
So let's just get into the first section, which is configuration management. So one of the questions that you'll get asked right away is, why do you have SSL certificates used for Chef? Really fundamentally, your immediate answer should be security. SSL provides for a very high level of private security and private and public key pairing. This really is essential to ensure that you have a secure environment throughout your entire network. The second part should be that if you're using SSL and you're using the private public key model within SSL, you're able to guarantee the systems on your network that the Chef, that you'll be able to validate that the nodes within your network that Chef is validating against actually are the real nodes themselves, not imposters. So you will also be asked some questions such as the following. Which of the following commands would you use to stop or disable the HTTP service when the system boots? And you'll typically get 4 responses, and there'll be #systemctl disable httpd.service, or is it system disable http.service, system disable httpd, or the final option, which is systemctl disable httpd.service. Your answer should be the first one, which is #systemctl disable http.service. So Chef comes with a series of tools that allow it to function effectively. And one of the tools that you're going to be asked about is, what is Test Kitchen? And Test Kitchen is essentially a command line tool that allows you to be able to test out your cookbook before you actually deploy it to a real node. So some of the commands that you would use are, for instance, if you want to create an instance of Test Kitchen, you would do kitchen create. If you want to destroy an instance after you created it, you do kitchen destroy. And if you want to be able to combine multiple instances, you would do kitchen converge. So a question you'll get is around Chef is, how does Chef apply differ from Chef client? So fundamentally, the difference between them is that Chef apply will validate the recipe that you're working on, whereas Chef Client looks to apply and validate the entire cookbook that's run in your server environment. So one is focused on the recipe and the other is focused on the entire cookbook. So there are some differences when you're working with different command lines. So for instance, when you're working with Puppet and you're working with one version of Puppet and you want to do what is the command to sign a requested certificate, the top example here is for Puppet version 2.7, whereas the lower option here is for Puppet version 3. And that's something to bear in mind when you're going through your interview process, is that the tools that are used within a continuous integration, continuous delivery DevOps model do vary. And so you want to be able to talk knowledgeably about the different versions of the tools so that when you're talking to your interviewer, you're able to show the deep knowledge that you have. Which open source or community tools do you use to make Puppet more powerful? And essentially this question is going to be asking you to look beyond the core foundation of Puppet itself. And so the 3 options you have is being able to track configurations with Jira, which you should be doing anyway, but it's a great way to be able to clearly communicate the work that's being done with Puppet. Version control can be extended with Git. And then the changes should be passed through Jenkins. So the 3 tools you want to be looking at: integration with Jira, Git, and Jenkins. So what are the resources in Puppet? Well, fundamentally, there are 4. The resources are a basic unit of any configuration management tool. They are the features of the nodes. They are the written catalog and the execution of the catalog on a node. So as we dig deeper into Puppet, one of the things that you are likely to be asked regarding Puppet is, what is a class in Puppet? And so a class in Puppet is really the name blocks in your manifest that contain the various configurations. And this can include services, files, and packages. And we have on the screen here an example of what a class would look like when you write it out. And you may want to memorize just one class. Don't memorize just a whole set of classes. Just memorize one. The person that's interviewing you is just really looking for someone who has a working knowledge. They're not looking for you to have memorized complete massive classes, but having one small class to be able to illustrate the experience you have is extremely valuable to the interviewer, particularly if it's a technical interview. So as we move into Ansible, one of the things that you're going to be asked around Ansible is, what is Ansible role? So a role is an independent block of tasks and variable files and templates embedded inside of the playbook. So the example we have here on the screen actually shows you one role within a playbook. And in this role, it is to install Tomcat on a node. Again, as with previous question within Puppet of a class, it's probably good to have memorized just one or two roles so you can talk knowledgeably about Ansible when you're having your interview. So when you're working with Ansible, when should you be using the curly brackets? And so just as a frame of reference, there's often two different ways that these kind of brackets are referred to. They're either referred to as French brackets or curly brackets. Either way, what you'll be wanting to ask is, when would you use these specific types of brackets within Ansible? And really, the answer comes down to two things. One is that it makes it easier to distinguish strings and undefined variables. And the second is for putting together conditional statements when you are actually using variables. And the example we have here is this prints the value of, and we have foo, and we have to then put in the variable conditional statement of foo is defined as something. So what is the best way to make content reusable and redistributable with Ansible? And there's really essentially three. The first is to include a submodule or another file in your playbook. The second is to import an improvement of an include, which ensures that a file is added only once. And then the third is roles to manage the tasks within the playbook. So a question you will be asked is, provide a differences between Ansible and Puppets. So if we look at Ansible, it's a very easy agentless installation. It's based on Python. You can configure it with YAML, and there are no support for Windows. In contrast, Puppet is an agent-based installation. It's written in Ruby. The configuration files are written in DSL, and it has support on all popular operating systems. So if we dig deeper into the actual architecture, Ansible, it has a much more simple architecture, and it's definitely a push-only architecture. In contrast to Puppet, it's a more complicated but more sophisticated architecture where you're able to have a complete environment managed by the Puppet architecture.
Hello everyone. Today we will be looking at the interview questions which a typical DevOps engineer faces in an interview. This is both for people who are new to the DevOps world and people who are experienced in other fields like Linux or production support and are willing or wanting to move to DevOps. So let's take a look. So pretty much it'll start with questions about yourself. They'll have a resume in front of them, as obviously you would have sent your resume to them. So they'll look at that and they will ask you to quickly walk them through your resume and tell them what you've been doing in your previous project. So you'll have to summarize this in a way in which, kind of walk through all three layers, and you have to tell them that you worked on a team where you kind of managed the AWS part and the automation part of it. So that can also include telling them about any infrastructure deployment scripts which you have written. It could also include any configuration management that you've done and deployment automation you might have done. So it would also include things like setting up a monitoring system, setting up the entire thing on the cloud, collaborating with teams, everything. Maybe what your code review process is, Scrum methodology, whatever you do in your team. They will definitely ask you what your team size was. So you could say you've been working on a team of about 5 to 6 people, which would include team leads, consultants, managers, Scrum masters, etc. What was your role in the team? That's the typical DevOps role in which you've written code for automation of stuff on the cloud. They'll ask, how good are you at programming? Now, this is a typical question that's asked of a DevOps engineer to gauge whether he's fit for the DevOps role or not. So you would answer that you've not written full-fledged applications such as Java or Ruby on Rails, but you're good at Ruby, Python, Shell, and Perl from a scripting language perspective. Maybe I'm not a full-fledged programmer, but I know the ins and outs of scripts. One of the typical questions is, are you from the dev side or the ops side? And the answer is you're from the ops side, but you have a good hold on the programming languages which are used for scripting and configuration management, and whatever code is required, you can write that easily. They may ask, how quickly can you learn, which is a gauge of the candidate's ability to learn new things and flexibility to adjust himself to a new environment. Given the chance, can you architect an application? The answer is definitely yes. Tell them you have been working with architects recently and that you've been contributing to the architecture from a DevOps perspective and giving your input so that the application could be developed in a more easily deployable manner. Given the chance to lead a team, can you do that? You'll say yes, definitely. I have more than 5 years experience. Typically, this is true for people who have had at least 5 years experience leading a team because less than that would really not be meaningful. The next level of questions that come up in a DevOps interview are typically Linux questions. These questions could be anything from the Linux world, but typically these are the most common questions. What is the command to view the cron tab? The command is cron tab -L. What is an alias in Linux? An alias in Linux is something that tells you the shortcuts on that system. These are defined in the etc-rc file. What does the chmod command do? The chmod command basically allows you to change the permission of a file in Linux. It can be changed from read-write in executable mode, so it could be changed from read to read-write or to read-write-execute depending on the use case. What is SSH port forwarding? It's a way to actually forward your ports through SSH protocols, so it allows you to bypass firewalls and also tunnel ports through strictly guarded environments. So this is one of the ways which you can connect to instances or services in your private subnets in AWS or your data center. The next question is, what is a zombie process? Now this is about the most common Linux question asked in an interview. Zombie process is a process which is in a terminated state, but which has not yet released the resources. So basically, it's most commonly a child process where the parent has exited, but the child is still there. Basically, its entry is in the process table. They'll ask how to check the top CPU consuming processes, and you can use the top command to check that. The top command gives you a very nice view of the entire Linux process table. Looking at the top deployment-related questions, which is one of the most important areas people use to gauge their candidates, one of the questions which comes up is, what is a blue-green deployment? So a blue-green deployment is something that in which you have X number of resources running your application, and say that number is 10. So you have 10 servers in a web farm. Now in a blue-green deployment, what you do is take out half of those from the actual production state. You deploy the new code on those. Now, in the meantime, the other 5 or the other half would be serving the production traffic. And these 5 would not be hindered or hampered in any way. Now, the first 5 in which you complete the deployment, which you've taken out of the actual production load, you put those back in and you wait for those to come back into service. And then you take the other 5 out of the actual load and you start deploying on those. So in a blue-green deployment, what happens is you never let the end user see the downtime. It's an always-up environment. How do you do a hot deployment? This is just a rephrasing of the previous question, really. A hot deployment can be done either by having 2 environments of the same size, and then you redirect traffic through a load balancer or a proxy service to one of the environments, deploy it on the other, and then redirect to the first one and apply it to the second. And just like a blue-green deployment, you never showed the end user the downtime. And what is your rollback strategy? This is something you need to be very confident about because every deployment should have a rollback associated with it. So let's say your deployment fails. How do you roll back the system? It has to be linked to a blue-green or a hot deployment. So you have to say that you have a Jenkins job or a script which basically does a blue-green deployment, and in the middle of that blue-green deployment, it checks to see whether or not services are up and running, and at the least the SGTP endpoints of your application are running or not. Have you used Jenkins for deployment? Yes, I've used it, and you've used it using a couple of strategies. You've used it with plugins, and I've used it with my script, so my plugins used to deploy code on the environment using build or publish or SSH, and I have also had my Ansible or Chef or Puppet code, which used to do the deployment for me. So we used to use Jenkins as an orchestrator and Puppet and Chef and Ansible for the actual deployment of the target service. One of the other common questions from a deployment perspective is, what Jenkins plugins have you used? You would say Jenkins plugins you've used, Maven and Gradle. I've used Cobetra for testing, PMD for programmatic mistake detection, Aztec for Ruby on Rails testing, Karma for AngularJS testing and integration with S3. I've also used Git plugin for checking out code, SVN plugin for checking out SVN repositories, upstream, downstream plugin for connecting the builds. In addition to this, I've also used Archive Artifacts plugin, Publish HTML Reports plugin to publish test reports. Have you ever used user data for deployment? You answer yes, I've used it in AWS. So when you have instances behind load balances, we used to use it. It will actually define the deployment script so that every time a new instance comes up in the auto-scaling group, it has got the latest code on it. So that latest code is checked out using the sh command, which is specified inside the user data. Looking at the AWS questions, so what is a VPC? A VPC is a slice of the Amazon cloud which they give you to run your resources. What is the difference between a public and private subnet? A public subnet is a subnet which is directly accessible from the internet. A private subnet is a subnet that is not accessible from the internet. It's only accessible from within the VPC. What is reserved instance? A reserved instance is an instance which is reserved for you by Amazon for a year, and they give you significant price reductions on that. You can buy that no upfront, partial upfront, or full upfront payments, and you get discounts from 20 to 60% based on the payment type and terms. What is the difference between spot instance and reserved instance? The spot instance is like a bid instance, where you have a specific price which you have bid, and based on that you are assigned instances. Now, the moment your bid is lower than the next highest bid, your instance is terminated and it's assigned to the next highest bidder. A reserved instance, on the other hand, is not a biddable instance. You have to buy it for specific terms. What is CloudFormation? CloudFormation is an orchestration or an infrastructure or a server deployment tool, a managed server deployment tool or service which Amazon provides. So it takes a JSON as an input. In that JSON, you provide everything that is required to build up an environment, from VPS to servers to buckets, everything. So it's an Amazon-provided service. It lets you build entire application stacks from scratch. Have you used Route 53? Yes, I've used Route 53. I used it for managing DNS. I use it to redirect our code ID DNS to Route 53 using Amazon name servers. And then from there in Route 53, we used to create CNM entries, A records, MX records, TXT records, and we used to manage the entire DNS from there. What is the best feature of AWS which you like? I like the auto-scaling group and the elastic load balancer because it allows you to infinitely scale your application to any level. Coming to configuration management. Which configuration management tool have you used? So you can say that you've used all three, Chef, Ansible, and Puppet, in one project or another. I have good hands-on experience with each of them, and I've written Chef cookbooks, Puppet modules, and Ansible playbooks. What is the difference between Chef and Ansible? So Chef is a Ruby-based tool. It uses Ruby as its main programming language. It's open source, just like Ansible. Chef uses a client-server and client-only architecture. So the difference is that Ansible is simply an agentless tool. So there is no agent in Ansible whatsoever. In Chef, there are two methodologies. One is agent-based and the other is agentless. But if you talk about the difference, one of the differences is that there is no agent in Ansible. And the other difference is Ansible uses YAML for defining the state of the systems and its playbooks, whereas Chef uses Ruby for defining the state of the systems in its cookbooks. And it's more of a programming language when it comes to Chef, and the YAML in Ansible is not really a programming language. It's more of a statically typed code. Have you written any cookbooks or modules and the playbooks? Yes, I've used both from the repositories, which each of these configuration management tools provide. So for Chef, I've used the Chef Supermarket cookbooks, and I've also written custom cookbooks. For Puppet, I've used modules from Puppet Forge, and I've written my own modules for custom applications. For Ansible, I've used the community-provided playbooks, as well as I've written my own custom playbooks for provisioning of instances on the cloud, as well as managing. And now production support. What is the biggest issue you faced in a production environment? So you can say that there's an application we used to run on the cloud, and there was some application deployment error. It was a logical error in the application which caused an error behind the elastic load balancer. So we had an elastic load balancer which was tied to the auto-scaling group. So it kind of snowballed the application, and we were not able to control it. So the application scaled infinitely, and it was snowballing the instances. So we had to go in and manually freeze the size of the auto-scaling group. once the size was frozen, we were able to go into the instances, check the logs, fix the issue, rebuild the IMI, restart the auto-scaling process. So that was one of the biggest issues in production I've faced recently. What is your DR strategy in a live website? So a DR strategy is that you do a failover check using Route 53 DNS. So one of them is a DNS-based failover in which you've got an exact replica of your environment, your web servers, your database, your cache. So your database may not be synced in real time with the DR. So it could be a 1 day behind sync. So the traffic is switched to DR whenever there's a downtime in production, automatically through a DNS switch. The other DR strategy is that you can have instances in 2 availability zones, and then you can have your load balancer to switch traffic based on the availability of those 2 zones. But that is a same region DNR. So from a multi-region DNR, the best option is to have a DNS-based switch. And you can also have an interface tool, an interface proxy, which can route traffic based on the health of your endpoints. How do you scale a production web service? So if you're on the cloud, you can use the auto-scaling group, which will scale automatically based on demand. If you don't want to go into instances and you don't want to manage instances, you can use the Elastic Beanstalk for a managed stack, which takes care of the load balancing itself. Now, if you have an application which is already containerized, it's a better practice to run them on ECS on the cloud, which would allow you to scale your applications based on demand, and you can create an application load balancer there. If you're in-house, you can scale your application by having a container management system in which you can have some base hosts on which you run multiple services. So you can keep on adding multiple hosts to that cluster, and you don't have to worry about the scaling part because the hosts can be added on the fly to that hardware. So your Docker cluster, like a Swarm or a Kubernetes, can take care of getting those new machines into your cluster and running the containers which are existing on your cluster on those new machines. Thanks a lot, everyone. This is all from the interview question.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.